Sekolah Tinggi Ilmu Farmasi Makassar. Bersama saya, yuk kenali kampus kita. Hai. Saat ini kita berada di ruang administrasi. STIFA Makassar juga dilengkapi dengan beragam fasilitas. Yuk! Untuk mencari referensi dan menggali informasi, saya selalu ke perpustakaan ini.
In this library, we can read books to expand our knowledge, information, or others.
STIFA Makassar juga dilengkapi dengan apotek simulasi.
With this facility, students have a chance to improve their skill in pharmaceutical practice.
Nah, saat ini kita berada di ruang CBC.
STIFA Makassar also have a computer-based test room.
Untuk pengembangan riset dalam penemuan obat baru juga ditunjang dengan fasilitas ini.
We also facilitated by this laboratory to support our experiment and various of drug research and invention.
Berbagai prestasi berhasil diraih oleh STIFA Makassar. Sebanyak 25 proposal PKM berhasil didanai oleh Ristekdikti dan meloloskan 3 PKM di ajang Pekan Ilmiah Nasional, serta berhasil memperoleh gold and silver medal pada ajang International Young Scientist Association di Malaysia, dan beragam prestasi lainnya. Nah, bagaimana? Segera bergabung bersama kami di STIFA Makassar. STIFA Makassar mengedepankan knowledge, skill, and character. Selamat datang di Sekolah Tinggi Ilmu Farmasi Makassar. Bersama saya, yuk kenali kampus kita. Hai. Saat ini kita berada di ruang administrasi. STIFA Makassar juga dilengkapi dengan beragam fasilitas. Yuk! Untuk mencari referensi dan menggali informasi, saya selalu ke perpustakaan ini.
In this library, we can read books to expand our knowledge, information, or others.
STIFA Makassar juga dilengkapi dengan apotek simulasi.
With this facility, students have a chance to improve their skill in pharmaceutical practice.
Nah, saat ini kita berada di ruang CBC.
STIFA Makassar also have a computer-based test room.
Untuk pengembangan riset dalam penemuan obat baru juga ditunjang dengan fasilitas ini.
We also facilitated by this laboratory to support our experiment and various of drug research and invention.
Berbagai prestasi berhasil diraih oleh STIFA Makassar. Sebanyak 25 proposal PKM berhasil didanai oleh Ristekdikti dan meloloskan 3 PKM di ajang Pekan Ilmiah Nasional, serta berhasil memperoleh gold and silver medal pada ajang International Young Scientist Association di Malaysia, dan beragam prestasi lainnya. Nah, bagaimana? segera bergabung bersama kami di STIFA Makassar. STIFA Makassar mengedepankan knowledge, skill, and character. Selamat datang di Sekolah Tinggi Ilmu Farmasi Makassar. Bersama saya, yuk kenali kampus kita. Hai. Saat ini kita berada di ruang administrasi. STIFA Makassar juga dilengkapi dengan beragam fasilitas. Yuk! Untuk mencari referensi dan menggali informasi, saya selalu ke perpustakaan ini.
In this library, we can read books to expand our knowledge, informasi, or others.
STIFA Makassar juga dilengkapi dengan apotek simulasi.
With this facility, students have a chance to improve their skill in pharmaceutical practice.
Nah, saat ini kita berada di ruang CBC.
STIFA Makassar also have a computer-based test room.
Untuk pengembangan riset dalam penemuan obat baru juga ditunjang dengan fasilitas ini.
We also facilitated by this laboratory to support our experiment and various of drug research and invention.
Berbagai prestasi berhasil diraih oleh STIFA Makassar. Sebanyak 25 proposal PKM berhasil didanai oleh Ristekdikti dan meloloskan 3 PKM di ajang Pekan Ilmiah Nasional, serta berhasil memperoleh Gold and Silver Medal pada ajang International Young Scientist Association di Malaysia, dan beragam prestasi lainnya. Nah, bagaimana? Segera bergabung bersama kami di STIFA Makassar. STIFA Makassar mengedepankan knowledge, skill, and character. datang di Sekolah Tinggi Ilmu Farmasi Makassar. Bersama saya, yuk kenali kampus kita. Hai. Saat ini kita berada di ruang administrasi. STIFA Makassar juga dilengkapi dengan beragam fasilitas. Yuk! Untuk mencari referensi dan menggali informasi, saya selalu ke perpustakaan ini.
In this library, we can read books to expand our knowledge, information, or others.
STIFA Makassar juga dilengkapi dengan apotek simulasi.
With this facility, students have a chance to improve their skill in pharmaceutical practice.
Nah, saat ini kita berada di ruang CBT.
STIFA Makassar also have a computer-based test room.
Untuk pengembangan riset dalam penemuan obat baru juga ditunjang dengan fasilitas ini.
We also facilitated by this laboratory to support our experiment and various of drug research and invention.
Berbagai prestasi berhasil diraih oleh STIFA Makassar. Sebanyak 25 proposal PKM berhasil didanai oleh Ristekdikti dan meloloskan 3 PKM di ajang Pekan Ilmiah Nasional, serta berhasil memperoleh Gold and Silver Medal pada ajang International Young Scientist Association di Malaysia, dan beragam prestasi lainnya. Nah, bagaimana? Segera bergabung bersama kami di STIFA Makassar. STIFA Makassar mengedepankan knowledge, skill, and character. Selamat datang di Sekolah Tinggi Ilmu Farmasi Makassar. Bersama saya, yuk kenali kampus kita. Hai. Saat ini kita berada di ruang administrasi. STIFA Makassar juga dilengkapi dengan beragam fasilitas. Yuk! Untuk mencari referensi dan menggali informasi, saya selalu ke perpustakaan ini.
In this library, we can read books to expand our knowledge, information, or others.
STIFA Makassar juga dilengkapi dengan apotek simulasi.
With this facility, students have a chance to improve their skill in pharmaceutical practice.
Nah, saat ini kita berada di ruang CBT.
STIFA Makassar also have a computer-based test room.
Untuk pengembangan riset dalam penemuan obat baru juga ditunjang dengan fasilitas ini.
We also facilitated by this laboratory to support our experiment and various of drug research and invention.
Berbagai prestasi berhasil diraih oleh STIFA Makassar. Sebanyak 25 proposal PKM berhasil didanai oleh Ristekdikti dan meloloskan 3 PKM di ajang Pekan Ilmiah Nasional, serta berhasil memperoleh Gold and Silver Medal pada ajang International Young Scientist Association di Malaysia, dan beragam prestasi lainnya. Nah, bagaimana? segera bergabung bersama kami di STIFA Makassar. STIFA Makassar mengedepankan knowledge, skill, and character. Selamat datang di Sekolah Tinggi Ilmu Farmasi Makassar. Bersama saya, yuk kenali kampus kita. Hai. Saat ini kita berada di ruang administrasi. STIFA Makassar juga dilengkapi dengan beragam fasilitas. Yuk! Untuk mencari referensi dan menggali informasi, saya selalu ke perpustakaan ini.
In this library, we can read books to expand our knowledge, information, or others.
STIFA Makassar juga dilengkapi dengan apotek simulasi.
With this facility, students have a chance to improve their skill in pharmaceutical practice.
Nah, saat ini kita berada di ruang CBC.
STIFA Makassar also have a computer-based test room.
Untuk pengembangan riset dalam penemuan obat baru juga ditunjang dengan fasilitas ini.
We also facilitated by this laboratory to support our experiment and various of drug research and invention.
Berbagai prestasi berhasil diraih oleh STIFA Makassar. Sebanyak 25 proposal PKM berhasil didanai oleh Ristekdikti dan meloloskan 3 PKM di ajang Pekan Ilmiah Nasional, serta berhasil memperoleh gold and silver medal pada ajang International Young Scientist Association di Malaysia, dan beragam prestasi lainnya. Nah, bagaimana? Segera bergabung bersama kami di STIFA Makassar. STIFA Makassar mengedepankan knowledge, skill, and character. Sekolah Tinggi Ilmu Farmasi Makassar. Bersama saya, yuk kenali kampus kita. Hai. Saat ini kita berada di ruang administrasi. STIFA Makassar juga dilengkapi dengan beragam fasilitas. Yuk! Untuk mencari referensi dan menggali informasi, saya selalu ke perpustakaan ini.
In this library, we can read books to expand our knowledge, information, or others.
STIFA Makassar juga dilengkapi dengan apotek simulasi.
With this facility, students have a chance to improve their skill in pharmaceutical practice.
Nah, saat ini kita berada di ruang CDC.
STIFA Makassar also have a computer-based test room.
Untuk pengembangan riset dalam penemuan obat baru juga ditunjang dengan fasilitas ini.
We also facilitated by this laboratory to support our experiment and various of drug research and invention.
Berbagai prestasi berhasil diraih oleh STIFA Makassar. Sebanyak 25 proposal PKM berhasil didanai oleh Ristekdikti dan meloloskan 3 PKM di ajang Pekan Ilmiah Nasional, serta berhasil memperoleh gold and silver medal pada ajang International Young Scientist Association di Malaysia, dan beragam prestasi lainnya. Nah, bagaimana? Segera bergabung bersama kami di STIFA Makassar. STIFA Makassar mengedepankan knowledge, skill, and character. Selamat datang di Sekolah Tinggi Ilmu Farmasi Makassar. Bersama saya, yuk kenali kampus kita. Hai. Saat ini kita berada di ruang administrasi. STIFA Makassar juga dilengkapi dengan beragam fasilitas. Yuk! Untuk mencari referensi dan menggali informasi, saya selalu ke perpustakaan ini.
In this library, we can read books to expand our knowledge, information, or others.
STIFA Makassar juga dilengkapi dengan apotek simulasi.
With this facility, students have a chance to improve their
Tinggi Ilmu Farmasi Makassar. Bersama saya, yuk kenali kampus kita. Hai. Saat ini kita berada di ruang administrasi. STIFA Makassar juga dilengkapi dengan beragam fasilitas. Yuk! Untuk mencari referensi dan menggali informasi, saya selalu ke perpustakaan ini.
In this library, we can read books to expand our knowledge, informasi, or others.
STIFA Makassar juga dilengkapi dengan apotek simulasi.
With this facility, students have a chance to improve their skill in pharmaceutical practice.
Nah, saat ini kita berada di ruang CBC.
STIFA Makassar also have a computer-based test room.
Untuk pengembangan riset dalam penemuan obat baru juga ditunjang dengan fasilitas ini.
We also facilitated by this laboratory to support our experiment and various of drug research and invention.
Berbagai prestasi berhasil diraih oleh STIFA Makassar. Sebanyak 25 proposal PKM berhasil didanai oleh Ristekdikti dan meloloskan 3 PKM di ajang Pekan Ilmiah Nasional, serta berhasil memperoleh gold and silver medal pada ajang International Young Scientist Association di Malaysia, dan beragam prestasi lainnya. Nah, bagaimana? Segera bergabung bersama kami di STIFA Makassar. STIFA Makassar mengedepankan knowledge, skill, and character. Selamat datang di Sekolah Tinggi Ilmu Farmasi Makassar. Bersama saya, yuk kenali kampus kita. Hai. Saat ini kita berada di ruang administrasi. STIFA Makassar juga dilengkapi dengan beragam fasilitas. Yuk! Untuk mencari referensi dan menggali informasi, saya selalu ke perpustakaan ini.
In this library, we can read books to expand our knowledge, informasi, or others.
STIFA Makassar juga dilengkapi dengan apotek simulasi.
With this facility, students have a chance to improve their skill in pharmaceutical practice.
Nah, saat ini kita berada di ruang CBC.
STIFA Makassar also have a computer-based test room.
Untuk pengembangan riset dalam penemuan obat baru juga ditunjang dengan fasilitas ini.
We also facilitated by this laboratory to support our experiment and various of drug research and invention.
Berbagai prestasi berhasil diraih oleh STIFA Makassar. Sebanyak 25 proposal PKM berhasil didanai oleh Ristekdikti dan meloloskan 3 PKM di ajang Pekan Ilmiah Nasional, serta berhasil memperoleh gold and silver medal pada ajang International Young Scientist Association di Malaysia, dan beragam prestasi lainnya. Nah, bagaimana? Segera bergabung bersama kami di STIFA Makassar. STIFA Makassar mengedepankan knowledge, skill, and character. Selamat datang di Sekolah Tinggi Ilmu Farmasi Makassar. Bersama saya, yuk kenali kampus kita. Hai. Saat ini kita berada di ruang administrasi. STIFA Makassar juga dilengkapi dengan beragam fasilitas. Yuk! Untuk mencari referensi dan menggali informasi, saya selalu ke perpustakaan ini.
In this library, we can read books to expand our knowledge, informasi, or others.
STIFA Makassar juga dilengkapi dengan apotek simulasi.
With this facility, students have a chance to improve their skill in pharmaceutical practice.
Nah, saat ini kita berada di ruang CBC.
STIFA Makassar also have a computer-based test room.
Untuk pengembangan riset dalam penemuan obat baru juga ditunjang dengan fasilitas ini.
We also facilitated by this
datang di Sekolah Tinggi Ilmu Farmasi Makassar. Bersama saya, yuk kenali kampus kita. Hai. Saat ini kita berada di ruang administrasi. STIFA Makassar juga dilengkapi dengan beragam fasilitas. Yuk! Untuk mencari referensi dan menggali informasi, saya selalu ke perpustakaan ini.
In this library, we can read books to expand our knowledge, information, or others.
STIFA Makassar juga dilengkapi dengan apotek simulasi.
With this facility, students have a chance to improve their skill in pharmaceutical practice.
Nah, saat ini kita berada di ruang CBC.
STIFA Makassar also have a computer-based test room.
Untuk pengembangan riset dalam penemuan obat baru juga ditunjang dengan fasilitas ini.
We also facilitated by this laboratory to support our experiment and various of drug research and invention.
Berbagai prestasi berhasil diraih oleh STIFA Makassar. Sebanyak 25 proposal PKM berhasil didanai oleh Ristekdikti dan meloloskan 3 PKM di ajang Pekan Ilmiah Nasional, serta berhasil memperoleh gold and silver medal pada ajang International Young Scientist Association di Malaysia, dan beragam prestasi lainnya. Nah, bagaimana? Segera bergabung bersama kami di STIFA Makassar. STIFA Makassar mengedepankan knowledge, skill, and character. Selamat datang di Sekolah Tinggi Ilmu Farmasi Makassar. Bersama saya, yuk kenali kampus kita. Hai. Saat ini kita berada di ruang administrasi. STIFA Makassar juga dilengkapi dengan beragam fasilitas. Yuk! Untuk mencari referensi dan menggali informasi, saya selalu ke perpustakaan ini.
In this library, we can read books to expand our knowledge, information, or others.
STIFA Makassar juga dilengkapi dengan apotek simulasi.
With this facility, students have a chance to improve their skill in pharmaceutical practice.
Nah, saat ini kita berada di ruang CBC.
STIFA Makassar also have a computer-based test room.
About 421 participants come from universities from Indonesia that are Muhammadiyah University Kudus, Hasanuddin University, Brawijaya University, Islamic State University, Mula Warman University Samarinda, Institute Teknologi Bandung, also from abroad universities that are Chulalongkorn University, Thailand, and West Virginia University. And also we have participants from Bahtermas Hospitals, Dr. Harjanto Hospital Balikpapan, Konawe Hospital, Indonesian Pharmacist Association, Indonesian Dentist Association, National Agency of Food and Drug Control Indonesia. For everybody, welcome to this international seminar. Hopefully you can enjoy this seminar till the end of this session. Before we continue, I would like to ask some rules to ensure everybody has the best gain from this international seminar. Please follow these rules. First, your microphone will be automatically mute. Second, you will have the opportunity to engage with the panelists and each other via chat room. Third, be respectful of other participants and panelists by keeping comments related on topics succinctly. 4, submitting questions only in Q&A window. You may mention the panelists to address your questions. 5, do not post any requests for technical support in the chat room. 6, do not provide your feedback about the quality of the session in the chat room. You will be given the opportunity to do this by completing a survey at the international seminar's conclusion. 7, the international seminar is recorded and live streamed on YouTube. 8, we provide a link for the post-test and participant attendance list at the end of the seminar via chat room. 9, e-certificates will be distributed via email to the participants who have already paid. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
The Honorable Head of LL Dikti Region 9 Sulawesi, Profesor Dr. Jasruddin Master Science. Assalamualaikum, Prof.
Waalaikumsalam.
The Honorable Head of Al-Marisah Madani Foundation, Dr. Andes Haji Sahibuddin Agani Apoteker. The Honorable Head of STIFA Makassar, Dr. Nur Samsiar Master Science. The Honorable invited speakers, Professor Maurice Ducret, OVEC PhD, from Department of Chemistry, University Disjang, West Cameroon. Associate Professor Waranyo Pulkeron, PhD, from Chulalongkorn University, Thailand. Professor Dr. Ibrahim Jantan, from Tyler's University, Malaysia. Professor Dr. Suwijio Pramono DEA Apoteker from Gajah Mada University, Indonesia, and Abdul Halim Umar, S4 Master Science from Sekolah Tinggi Informasi Makassar. Also the unforgettable, all the committees and participants who have of the 4th International Seminar of Natural Product. First of all, let us thanks to Almighty Allah, who has given us some mercies and blessings. Even though we are in COVID-19 pandemic, we can still attend these activities, namely 4th International Seminar of Natural Product. Ladies and gentlemen, let me deliver the seminar program as follows. First, opening by Master Ceremony. Second, prayer. Third, welcome speech by the head of STIFA Makassar. 4, opening remark by the head of LL Dikti Region 9 Sulawesi. 5th, seminar topic presentation session 1 by speakers. 6, discussion session 1. 7, break. 8, seminar topic presentation session 2 by speakers. 9, discussion session 2. 10, closing. Ladies and gentlemen, let us open this seminar by reciting Basmalah together. Bismillahirrahmanirrahim. Now for the second agenda is prayer by Mr. Fahri Mubarak, S4 Master Science. For Mr. Fahri Mubarak, time is yours.
Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Before we start the 4th International Seminar on Natural Product I would like to invite all participants to pray together. Hopefully our event today have a blessing on the side of Allah subhanahu wa ta'ala. And let me pray according to my religion and believe that Islam and other please adjust. أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. الحمد لله رب العالمين. حمدا ناعمين حمدا شاكرين حمدا يوافي نعمه ويكافي مزيده. يا ربنا لك الحمد كما ينبغي لجلال وجهك الكريم وعظيم سلطانك. اللهم اغفر لنا ذنوبنا ولوالدينا وارحمهما كما ربونا صغارا. اللهم سهل لنا أمورنا وأمور أهلنا وأمور أصحابنا وأمور مؤسستنا المريسة مداني وأمور جامعتنا STIFA Makassar. Allah, simplify our dealings, our family affairs, our friends affairs, our foundation affairs Al-Marisa Madani, and our schools affairs STIFA Makassar. Allahumma aslih lana dini alladhi huwa ismatu amrina, wa aslih lana dunyaya allati fiha ma'ashuna, wa aslih lana akhiratina allati fiha ma'aduna, waj'al hayata ziyadatan lana fi kulli khair, waj'al al-mawta rahatan fi kulli syarr. Allah, set right our religion with the safeguard of our affairs, and set right our world wherein is our living, and set right our next life to which is return, and make life for our an increase in all good, and make death a relief for every evil. Allahumma inni as'aluka 'aishatan haniyatan wa mitatan sawiyatan wa maradan ghayra muhzin wala fadih. Allah, we ask for a comfortable life, a quiet bed, and a place of return that is not embarrassing and humiliating for us. Allahumma fa'anna al-bala wal-bawah virus corona wal-bala fi masambah lu utara wa zina wal-fitan ma dhahara minha wa ma batan ishfi maradana wa mardal muslimin isbirhum washfi ilayhim la hawla wa la quwwata illa billah. At present, the whole country is being exposed to the calamity of coronavirus. Take up this coronavirus outbreak, a disaster in Masambah, Northern Luwu. Give them patience to receive this calamity. Keep away from adultery, defamation, both clear and hidden. Restore all life as again. There is no power and evil is only yours, Allah. Rabbi zidna ilman warzuqna fahman. Add useful knowledge for us and give us understanding of it. Rabbana taqabbal du'a'ana. Please accept our prayers. Rabbana zalamna anfusana wa illam taghfir lana wa tarhamna lanakunanna minal khasirin. Rabbana atina fid dunya hasanah wa fil akhirati hasanah wa qina adzaban nar. Subhana rabbika rabbil izzati amma yasifun wa salamun alal mursalin walhamdulillahi rabbil alamin. Syukran, thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Mr. Fahri Mubarak. Ladies and gentlemen, the next welcome speech by the head of STIFA Makassar, which now will be delivered by Mr. Samsunur, SPAR Master Science Apotheker. For Mr. Samsunur, time is yours.
Thank you very much. The Honorable Head of Lembaga Layanan Pendidikan Region of Dr. Jasrudin, MSc. Assalamualaikum, Prof.
Waalaikumsalam.
The Honorable Head of Al-Marisa Madani Foundation, Dr. Haji Saibuddin Agani Apotheker. The Honorable invited speakers, Associate Professor Maurice, PhD, from University the Exchange Cameroon. Good night in the Cameroon time. Professor Dr. Apotheker Suwijito Pramono from Universitas Gadjah Mada, Indonesia. Associate Professor Waradio, PhD, from University Chulalongkorn, Bangkok, Thailand, and Professor Dr. Ibrahim Jantan from Pilot University, Malaysia, and my colleague Abdul Halim Umar, S.Farm, Master of Science from Sekolah Tinggi Ilmu Farmasi, Makassar. The Honorable all of committee and all of participants that present on the 4th International Seminar of Natural Product 2020. Good morning. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam.
The all speakers and participants of the 4th International Seminar of Natural Product 2020 with the topic Herbal Remedies for COVID-19 Treatment, State of the Art and Perspectives. First of all, I would love to greet and welcome you on this webinar at 4th International Seminar of Natural Product in Makassar. This international seminar is the 4th international natural product, which is always held every 3 years by Sekolah Tinggi Ilmu Farmasi Makassar. But for these years, unfortunately, this seminar is done virtually because Indonesia, especially Makassar, South Sulawesi, is a pandemic area for COVID-19 that is categorized as a red zone by the government. The all speakers and participants, we are very proud to be present this great event that facilitates sharing expertise and knowledge on pharmaceutical areas, including basic and applied sciences related to it. And we were intended this webinar will provide a platform and cover the latest finding in drug discovery and development, especially from natural resources. Therefore, this webinar could give a significant contribution in the growth of the new drugs that are needed to solve the new disease, especially remedies for COVID-19 is pandemic now. We hope this program will provide a good opportunity for all pharmaceutical scientific across all of the universities, research institutions, and pharmaceutical industries to discuss and learn about remedies to COVID-19 through development drug discovery from natural product or traditional medicines. So, Sekolah Tinggi Ilmu Farmasi Makassar as a college of pharmacy, on behalf of the organizing committee, would like to thank all of our invited speakers. We realize that this event is only a small effort to contribute exchange in research and expertise. Therefore, more collaborative work and continuous relationship between us are still needed. Maybe finally, I would like to thank all the partners who have supported this webinar or international seminar. We hope that everyone will enjoy this event, and we hope that you can gain a lot of knowledge and experience through this international seminar. Thank you for coming in the international seminar. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Okay, thank you very much, Mr. Samsunur. Ladies and gentlemen, the next opening remark by the head of LL Dikti Region 9 Sulawesi, Professor Dr. Jasruddin, Master Science. For Professor Dr. Jasruddin, time is yours.
Thank you for check. MG, can you hear my voice?
Yes. Yes.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillah wa syukrillah. Wala hawla wala quwata illa billahil aliyil azim. Assalatu wassalamu ala asrafil anbiya'i wal mursalin wa ala alihi wa sahbihi ajma'in. Amma ba'd. Good morning. Best wishes for all of us today. The Honorable, the Board of Trustees and Chairperson of the foundation that organized the this international seminar that present invite speaker present who have expert in their field. This one proves that STIFA has entered the global era with one of its characteristics in the global era is the university or institution who have network of cooperation with world-class university and academy with international class. For this reason, I would like to express my appreciation and thanks to all of invited speakers at this seminar. Thanks to the organizers and managers of STIFA, continue to the work to younger generation who will play an important thing in the development of Indonesia nation and of course in the world. To all participants, congratulations to all of you. So, in the name of Allah, we say Bismillahirrahmanirrahim. The international seminar today, I say, let's begin. Healthy greeting to Allah Subhanahu wa Ta'ala of everything. Wabillahi taufiq wal hidayah. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Thank you very much, Prof. Jasruddin. Ladies and gentlemen, now let us proceed to the next program. The first session will be delivered by three our honorable invited speakers that are Professor Maurice Ducret Ovek, PhD, Associate Professor Waranyo Pulkeron, PhD, and Professor Dr. Ibrahim Jantan. This session will be led by Bese Hardianti, SSI M.Pharm, as the moderator. For your information, Mrs. Bese Hardianti got her master's degree from Institute of Natural Medicine, Toyama University, and now she is in the last year of PhD program in the same university. Ladies and gentlemen, I'm now pleased to invite our moderator. Please welcome Mrs. Bese Hardianti.
Thank you very much, Ms. Radia, as the host today. Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Good morning, ladies and gentlemen. Welcome to the fourth international seminar on natural products, which is entitled Herbal Remedies for COVID-19 Treatment, State of the Art and Perspective. His Excellency, Professor Dr. Jasruddin, MSc, as the head of LL Dikti Region 9, the respectable foundation's president of Al-Marisa Madani, Dr. Andes Sahibuddin Agani, and the head of STIFA Makassar, Dr. Nusram Siat. The honorable, all the invited speakers, the lecturer of STIFA Makassar, as well as all the attendees, thank you very much for joining us in this seminar. I am Bese Hardianti, the moderator of this fourth session today's seminar. I am very pleased to see you here and welcome all of you to this virtual seminar. This seminar is conducted by STIFA Makassar. Before we start the presentation, I would like to read the sequence of this seminar. This seminar is divided into two sessions. Each session consists of presentation, 40 minutes for each invited speaker, and discussion around 30 minutes. And to remind you all attendees that the last second session, we will have post test, which can be done by clicking the link that will be provided in the last minute of this event. Furthermore, in the first session, we will have 3 speakers. The first speaker is delivered by Professor Maurice Ducret, a Womfed PhD, as the first speaker from University de Changi, Cameroon. I hope I didn't mistake to pronounce your name, Professor Maurice. The second speaker will be presented by Associate Professor Walanya Punarun, PhD from Chulalongkorn University, and the last speaker is from Dr. Ibrahim Jantam from Taylor's University, Malaysia. And now I would like to invite Professor Maurice to sharing his expertise. And before doing that, I would like to read his curriculum vitae. Dr. Maurice Awamfat is a holder of PhD in Organic Chemistry, Natural Product Research from the University of Destang, Cameroon, where he is currently working as Associate Professor at the Research Unit of Natural Product Chemistry. He was a postdoc fellow at the Institute of Natural Medicine, University of Toyama, Japan, under the Japan Society for the Promotion of Science 2016 until 2018. And the Matsume International Foundation Fellowship, and at the Faculty of Veterinary Science at the University of Pretoria, South Africa. He was also a short-term Germany Academic Exchange Science, the AAD, doctoral scholarship at the Institute of Environment Research, the University of Technology, German, 2008 until 2009. His research interest is focused on the isolation and characterization of bioactive secondary metabolism from medicinal plant of Cameroon. He is author of 43 publications in peer-reviewed journal and 3 book chapters. He is associate editor of BMC Medicine and Therapies, and has several scientific society memberships such as Cameroon Bioscience Society, Association for African Medicinal Plant Standards, Society for Medicinal Plants and Natural Product Research, Pharmaceutical Society of Japan, and Japanese Society of Pharmacognosy. For Professor Maurice, time is yours.
Thank you. Mrs. Bese, can you hear me?
Yes.
Okay, thank you. Good morning, everyone. Here in Cameroon is we are around 2:34 a.m. So we are all in the morning now. So thank you for your kind presentation, your kind introduction to my person. So my talk today is on the African medicinal plants as a source of potential drug candidates against COVID-19. So you already introduced me, and to start this talk, I would like to introduce to you the African Natural Product Research Network. That is a research network that is stimulating continental and intercontinental scientific and research cooperation related to natural product sciences. So we are also promoting and developing high quality all natural product researchers with a continental platform for discussion on natural product topics relevant to Africa and to the world as well. So our main contact is in Germany is Dr. Blaise Kimbari, which is now at the Technical University of Dortmund in Germany. He's from Congo, DRC Congo. Yeah, as you may see here on the pictures, you have our members. We have 15 of us. You have Professor Eddie, who is now at the Hokkaido University as assistant professor, and he's from Congo as well. You have Clara, who is in Zurich. She's she's from Kenya. And we have James, I will just say like this, who is from Ghana. He's working in Ghana as well. We have Shema, who is from Egypt. She's working also in Egypt, and me as the last person in this slide. The second slide are all the full members of our research network. We have Mark also, who is from Kenya. Another Cameroonian is Remy. He's working in Cameroon at the same university as me, University of Chang. And we have Jean-Pierre, who is working in Germany. He's from Congo as well. We have Mamolasi, who is from South Africa. She's working at the University of Pretoria. And we have also Charles, who is from Nigeria, and he's working in Nigeria as well. We have another Cameroonian, Serge, who is Harvard Medical School in USA. He did his PhD in Germany, and he moved to Harvard for some job. We have also Mary, who is from who is working in Australia, and she's from Nigeria. Another two Cameroonians coming, Xavier, who is working in South Africa in Rhodes University, and we have Fidel, who is also working in Germany, and she's from Cameroon. And lastly, our main contact, Dr. Blaise Kimberly Lombe, who is from Congo, as I said, and he's also working in Germany. Okay, we were talking about African medicinal plants as a source of potential drug candidates against COVID. I'm not an expert of viral diseases, but what I found in Wikipedia is the coronavirus viral structure that is shown on the slide here, from which we can see the spike glycoprotein S and E protein, also membrane protein M, the RNA genome, and the envelope that is containing all the constituent. We all know that the coronavirus disease 2019, that is now called as COVID-19, is an infectious disease caused by severe acute respiratory syndrome coronavirus 2, SARS-CoV-2, and was identified at the first time in December 2019 in Wuhan, Hubei, China, and has resulted in an ongoing pandemic. This pandemic has rising some statistics every day from the World Health Organization, and that's what I just got from in July 13 of this year, and around 12,700,000 people are confirmed as a case, and about 600,000 people are dead for this pandemic, and these are happening in around 216 countries, area, and territories with cases. So when coming back to the background of treatment of viral diseases in the world, I just found this publication, and they were saying that the chloroquine was, as other anti-parasitic compound, where long-time using can be used for viral infections. And this is an old drug against today's diseases. That is why for the side effect of chloroquine, many people move to hydroxychloroquine for the same purposes. So coming back to African medicinal plants, I may not have many examples to show, but I would like to say that African medicine plants can really be source of potential drugs candidates against COVID-19, knowing that many of them are using for antiparasitic drugs against viruses. There are also some African medicinal plants with potential anti-malaria activities, and many protocols used in several countries, those type of compound drugs were used to fight against COVID-19. So where is Africa in the world? When you look at the map, Africa is somewhere here, and that Africa is served on the map is aside at the right. And where is Cameroon? Maybe most of you doesn't know where is Cameroon. Cameroon is in Central Africa, and the Cameroon itself is bordered by the Republic of Nigeria, Chad, Central African Republic, Congo, that is different of Democratic Republic of Congo. And we have Equatorial Guinea as well, and it's also open to the Gulf of Guinea. And our main capital, our political capital is Yaoundé, and our dialing code is +237. Our currency is Central African CFA franc, and our population is about 25 million as counted by the World Bank at 2018. Our president is Paul Biya, and we are using both French and English as official languages. Many of you may know Cameroon about the country of soccer. If you guys were watching the World Cup of soccer 1919 and so on, you may know a lot of Cameroonian players as well. So our flora in Cameroon is more diverse and made of dry land, as you can find in far north. And when moving to the littoral, you may have mangrove. You have a lot of sea with the plants having their roof in the sea, and that have particular secondary metabolite, specific secondary metabolite. And when moving to the Nja, that is we are going to the south, you may see the Nja forest. When we are going to the west side, we'll see a lot of forests and lake. We have some lake happening in the top of the mountain, and with some special plants growing around. And what is particular of this climate or this flora of Cameroon is that there is we call it Africa in miniature. Means in Cameroon, we found all the weather that we can have in the whole continent of Africa. So at this time, it's more likely that you may find almost all the plants that you get around Africa in Cameroon because the weather is favorable. How are those plants used for as drugs? Usually, to collect our plants, we rely on some indication or good effect of plants from the environment. As you can see at the first picture, you have a plant here bearing a hole of the insect. So this may give us some information as a phytochemist. So to say why insects choose only this plant to come and build their house on it. So we may collect the plant, some parts to see what can be the secondary metabolite in those kind of plants. And here you have, down there you have some, a market where people are selling medicinal plants. And at your, on the side, we have traditional healers collecting medicinal plants as well in Africa. So in Cameroon, we have about 8 state universities and we have 8 state universities and about 120 private universities as well, and about 50 state schools of professional education. The last one is the one of the University of Chong, where I'm coming from. The University of Chong, if you look here, is a web page of our university. I just captured a few letters ago, so a few hours ago, and we have some buildings here, and this is the design of the whole university. We're still on the building. So by the end, our university will have this this map. But you have some down here. I'm not sure if you can see where I'm showing. So down here we have the Faculty of Agriculture and Agricultural Sciences. So we have a lot of building with restaurant and student house and so on. And here we have the main building of the Faculty of Science, where I'm coming from, and this row is showing the natural product chemistry research unit laboratory which is at the third floor. And in this laboratory where I'm working, our main research interest is to collect medicinal plants relying to ethnobotanical and ethnomedicinal information collected from other researchers. And those plants, after collection, we dry and make the extraction and fractionation to isolate and characterize secondary metabolites using chromatography and spectroscopy technique to get their structure. And after that, we try to get in collaboration with biologists, we try to get the activity of the compound and the extract as well. And sometimes we have to use a bioassay guided isolation to reach the same goal. And usually we also try to make the chemical modification of some compound isolated so that we may keep the activity and decrease the toxicity, and try to improve the activity on reducing the cytotoxicity. And in many times, we will be able to determine the structure activity relationship and determine also the pharmacophoric element, which is the main part of the structure that is responsible of the activity on that structure. And from there, we may have the lead compound that could be used to develop a new drug. So some bioactive secondary metabolite from our medicinal plants. I'm taking some example of 3 plants that we already investigated in Cameroon. Maybe it will not be on COVID. You know, COVID-19 is a very new topic, and with a lot of time spending at home, no one can have a reliable data now from the lab. So these are previous data that we got in our medicinal plants. And we have Erythema glomerata as a plant, Crotella ladinophora, and Erythema robustum, all plants collected in Cameroon from Fabaceae family. Erythema glomerata, which is a small shrub found in the grassland of west region of Cameroon, is rarely attaining a height of greater than 1.5 meters, and the roots and leaves are used for wound dressing, venereal diseases, helminths, and skin diseases. The whole plant was collected and the powder was extracted to yield, to give the crude extract. That crude extract that was dissolved in methanol chloroform water 2:1, and the chloroform soluble portion was subjected to chromatography techniques to lead to give 6 compounds. From those 6 compounds, 2 compounds were new ones, compounds 7 and 8. And the structure of the known compounds shown here were identified from their spectroscopic data compared with those of the literature, while the structure of the new compound, this is the first one, was determined by analysis of their NMR data. And the first one was flavonoid that we named eriochalcone A. And the second one, when we did the mass spec, we realized that the difference between the 2 compounds were about 30 atomic mass unit. So that suggests that one of the compound, the second one, is missing the methoxyl group that we found at position 4 in the first one. So we finally, with the NMR, we confirmed the structure as eriochalcone B. That was just the methoxyl missing of the first one. Though these 2 compounds were on their this sample were subjected for their antimicrobial activity against some bacteria and fungi, and this was this test was carried out using the agar diffusion assay for their inhibition. So as a result, we realized that the most potent was the new compound eriochalcone B that got 30 millimeter against the fungal Macrobacterium violasum, while compound 7, eriochalcone A, was the most active against gram-negative bacterium, Escherichia coli, with 10 millimeter of diameter. This work was published in Planta Medica, And we also carry out some chemical transformation of eriochalcone A and B. We firstly try the cyclization of this separately of these two compounds. And from this cyclization, we use the TFA at overnight at room temperature. That is a weak acid. And we were able to obtain 4 compounds, from which 2, 9, and 11 were new derivatives. So this is the structure of the known one and the structure of the new compound, the new derivatives. We try to explain the mechanism of formation of these derivatives, and we realized that in the acidic medium, the double bond of the prenyl group could lead to the carbocation, and this can afford the cyclization both sides of the hydroxy group on these prenyl groups. So we also carry out the methylation reaction of both sample, both compound eriochalcone Bs and A and Bs, using the trimethyl sulfonium hydroxide in the triethyl amine with 10% toluene at 100 degrees Celsius for 1 hour. And this also led to 4 compounds, and all these 4 were new derivatives. So these are the structure of the new derivatives, methylate compound. And what we did further was the antimicrobial activity of the precursor and their semi-synthetic derivatives. From these results of antimicrobial activities, we were able to suggest the structural activity relationship of this class of compound hydrochalcones. And we realized that we confirmed that the prenyl group is really the inducer of the antimicrobial activity, as previously suggested. And this was confirmed from the fact that after the cyclization and the losing of the double bond, the activity suddenly decreased. And in some cases, we have increasing of activity depending on the substitute chain at position 4. This was also published in Planta Medica. So the second plant, Crotalella lachnophora, that is a perennial shrub or subshrub up to 3 meter tall that we collected in Cameroon, is using for the treatment of hair disease, helminths, and skin diseases. So the whole plant was there also collected, and the chloroform soluble portion was subjected to reverse phase preparative HPLC, from which we obtained 16 fractions from this chromatogram you can see. And on this chromatogram, fraction 12 and 16 were new compound, while the 8 other ones that were pure was non-compound. So these are the structure of the non-compound. And the first new compound was also a flavonoid, that's an isoflavonoid with cyclization of prenyl groups. And the second one, we also realized that the mass spec of the second one was less than 2 atomic mass unit to the first one. And we quickly observed that it was a cyclization between position 2 and the OH at 2 prime. Of isoprenyl group at position 6 changed from 5 to 7. So this compound was therefore characterized as lachno isoflavone B. And when we tried to analyze the alpha D of this compound, because we have a chiral center at 5 prime of both sample, means a chiral center. So when we tried the alpha D, we realized that the alpha D was almost close to 0. This therefore suggests that we are having a racemic mixture in each case. And we tried to use the quantum chemical calculation to perform the program to optimize the geometric of both enantiomers, and to we further also try to use the the chiral separation column to see if we can separate the compound 15. And from our chromatogram, you can see that this is a mixture, is a racemic mixture with having the same base peak, and it was in proportion of around 60 and 40. So unfortunately, we could not separate this compound, and we have to report as a mixture, racemic mixture. So we try also the antimicrobial assay of these samples, crude extract and compound, against some microorganism, and the result it shows in this slide. The crude extract had the most interesting extract was the result was the crude extract compound 19, that is luteolin 7O alpha rhamnose. We have also 7O methyl tectogenin, cagenol, prenitin, and cajanin, as well as lyco-hygroisoflavone that gave the diameter zone of inhibition around 9.3 and 9.7 millimeters. This was published in Journal of Natural Products. So we move to the third plant, that is Eryosema robustum. It's also a fabaceae that is used in the treatment of cough and skin disease in traditional medicine in Cameroon. And we also use the same separation procedure to get 8 compounds, out of which the first and second one were the new compound. These are the structure of the known compound that were obtained by identification of their structure after comparison of the NMR data with those reported in the literature. While the known compound, the new compound, the first one, they were all flavonoids. This one was a polyoxygenated flavonoid, and it was named riboflavin A, and the second one, riboflavin B. We tried to test this compound for antimicrobial activity using a broad microdilation method against some fungi and bacteria. So from the results in this slide, we may see that the crude extract and fraction A and B had significant activity on some bacteria and fungi, and we may see that the most interesting here was again Staphylococcus aureus with 0.02 milligram per milliliter. So, and some compounds obtained as a new compound, riboflavin A and riboflavin B, had moderate activity against Candida albicans and Pseudomonas aeruginosa with MIC 65 and 63 microgram per mils. So that was the result obtained at this stage. We also tried to run the cytotoxicity of the same samples, and we were able to calculate some selectivity index from microorganism. And what happened is we realized that the compounds were quite toxic, and the selectivity index, was between 0.01 and 1.59. So this also gave 2 publications, one in Phytochemistry Letters and the other one in BMC, Complementary and Alternative Medicine. As a conclusion, I will say that we obtained 26 compounds from 3 Cameroonian medicinal plants, Eryosema glomerata, Eryosema robustum, and Crotalaria lacinophora, including 14 new flavonoids and derivatives. We report their antimicrobial activities, and in other biological activity of some of these compounds are still under investigation. Let's say that how the African medicinal plant can be used as a potential candidate against COVID-19. You know that the African medicinal plants are very rich, are very rich in biodiversity, and their uses in traditional medicine to fight against several diseases could be considered as a promising source of potential drugs candidates against COVID. We may have some activity that's already proven as anti-malarial, some viral diseases, and infection diseases. So I would like to acknowledge some of my collaborators, mainly Professor Hiroyuki Morita at Toyama University, Japan, the Japan Society for the Promotion of Sciences, the University of China, my home institution, and our network, the African Natural Products Research Network, and you organizer of the 4th International Seminar of Natural Products that gave me the opportunity to present this work. Thank you for your kind attention. Yeah.
Okay, thank you very much for Dr. Maurice for giving such information and very interesting presentation. And now, that was the presentation by Professor Dr. Maurice. Now we directly go to the discussion session because now in Cameroon it's already very late at night. So I may ask you, for the attendees, please write your question in question and answer window and not in the chat room. Okay, Professor Maurice, now we already have one question coming from Ms. Irmayani from STIFA Makassar.
Yeah.
Her question is, as mentioned, chloroquine can be used as an alternative for COVID-19. As we know that many malaria drugs have resistance. Her question is, can we give chloroquine in the patient that has been resistant with chloroquine? What does strategy to avoid resistance during treatment? That is the question from Ms. Irma. Could you answer for this question, Dr. Maurice?
Okay, thank you, Mrs. Bass, and thank you to the person who asked the question. I could not record the name. It's a little bit. I'm sorry.
Irmayani.
Yeah. Irmayani, yeah. Sorry. You know, as I mentioned, and if you saw my background, I'm not someone working in the pharmacology. Or pharmacology. I'm a phytochemist, so my specialization is to isolate the active compound. So when we are working to look for active compound, what to do is to have collaboration with biologists. But what I will say is maybe you doing pharmacy, you are most specialized on some specific field. That is that of what he's saying from the question. So I think for now, there are many protocols that are used by several countries and several medical doctors, and if they are accepted by their country. So if chloroquine is given resistant to some patient, to some in some cases, what to do is the medical doctor have to switch to another protocol that may avoid chloroquine, I guess. And in some cases, people are using hydroxychloroquine. But if the hydroxychloroquine is still giving problem, I think they have to switch to another protocol. So that's what I'm learning from you. Thank you.
Thank you very much. And now let's see
another question.
Another question.
Yeah. Oh, it's like a comment. I know this Smile saying Smile. It's a friend. Okay.
Ismail, yes, Ismail. Coming from Ismail.
Yes. Yeah, we have been to Toyama together, I guess. So bonjour is a good morning in French. So let me read the question. Bonjour, Maurice Sensei. I'm Ismail from UNSHA Makassar. We have met before in the lab, Morita Sensei in Toyama, a few years before my question. Natural product that you isolate in Africa, especially Cameroon, you think it can use for COVID-19? That's the first question.
Yes, that's the first question.
Can I answer directly?
Yes,
please?
directly, please.
Okay. You know, we are researcher, and COVID-19 is something very new to us. So what we have to do is to, if you have some sample that we keep in the lab that we already isolated, we have to screen, to make output screening, to screen all those samples to see if any of those samples could be active against COVID-19. What important thing to note is that before screening, we may focus on those used as antiparasitic. Yeah, we may have more chance to have one or several samples that could be active against COVID-19. So I think this question is a very interesting one, and we have to do that to show that it's possible to get a compound that can be used to develop drug against COVID-19. So for the second question, is asking what tests you have done with the all pure compound that you already found, because as we all know, the process to get new drug candidates is very long and expensive. I had carried out a lot of, I couldn't present all my work here, but as you saw during my presentation, was mostly antimicrobial and cytotoxicity, but I also carry out some antioxidant activity and anti-proliferative. I mean, because the cytotoxicity here was only on normal cell line. So when we switch to cancer, it has to be anti-proliferative and so on. So, and we also doing some anti-inflammatory in Cameroon. And at this time, my student in the lab, we are working on anti-ailments. So we have a lot of experiment going on. Yeah. So for the third question, Shimai-san is asking, and I agree with Maurice Sensei, biodiversity from all the world, I think, will become as promising source of potential drug candidates against COVID. Okay, thank you. Yeah.
Okay,
I agree
Dr.
with Smile.
Yeah. We move to the next question from Aisha Nur Sapriyati.
Yes.
Can you see the question? This question is
yes.
about this plant. This plant have indication as antimicrobial, and there was a discussion about COVID, but in the research section, I didn't see use virus, only bacteria and fungi. Whether testing on bacteria and fungi could be said to have activity against viruses, or this plant just for bacteria and fungi. That's part of the some structure as the structure of chloroquine, so that later it can be used against COVID virus 19. So this question coming from
that's a very interesting question, I can see.
Yeah.
Thank you for this question. So like I mentioned during my talk, I say that the COVID-19 is something very new to us. And suddenly when arrived, we have to close all labs and wait at home. And when we came back, we have to focus on some seminar as the one we are talking today. So I could have presented some of the works that we already carry out in our lab that are having antimicrobial activities, anti-malarial activities and so on. But till now in our lab, we don't have any results about anti-COVID-19. We have to be clear about that. So if I came today to present such a work to you, means that I'm lying. So, but for anti-malaria, we have a lot of work that have been done so far since the creation of our lab. And for some conflict of interest, I may not be able to give some answer to this question, because there are a lot of things that we are still planning, we are on the way to do. that I could not tell you today. Maybe next year for the fourth international same conference, I will be presenting some results. Thank you. So let's move to the next question. Are they parts of the same structure as the structure of chloroquine so that later it can be used against COVID virus 19? There is not similarity about the structure. What we have to know about natural product is you may find two anti-malarial that are working very well, but their structure are not similar. So most of the time is the reason being is that you have to look. That's why I was telling during my presentation that when we are doing the isolation and the biological activity, we have to look for the pharmacophoric elements. So there's a basic skeleton of the compound that is responsible of the activity. This may change from one class of to another of secondary metabolite. So the most important when you say this could be used for this and this disease, you should know the pharmacophoric element and know what you may put in to increase the activity and to decrease the cytotoxicity and so on. So they may be different. Unless we want to do synthesis, we have to focus on the basic structure of chloroquine and try to develop something else. So my structure did not have any similarity with chloroquine. I'm sorry.
Okay.
Should I move to the next one?
Yes, we move to the question coming from Riswandi. Riswandi asks about, could you explain how
the African plants be promoted by the government? That is also a good question. What we are doing is we have two ministries involved in this case. We have the Ministry of Research and Innovation, and we have the Ministry of the Higher Education. Me, I'm linked to the Ministry of Higher Education, and our main what we are doing is when we get these results, if the results are the one we have to implement it, we have to move forward. There are such program in the Ministry of Research and Innovation that people are putting in place some program to see how to standardize the results of what we are getting. And we are also working directly with the Ministry of the Environment, where we have a direction of what we call, how can I call it? We have to share the sharing. I'm not sure about what I'm saying, but we have to, in this case, the benefit sharing of the advantages of research should be equitable. Because if we are working on genetic resources as a plant, we have to share equitable the results of the income. So that's leading to the protocol of Nagoya about genetic resources. So our government is very strict on this. And when you are collecting plants from one region, you have to get some permits from the ministry for that. And you have to get the feedback to tell them what you got on your research. So the government is really controlling the plan on natural resources around the country. I want to read the next part of the question of Rwandi. When some people already know the effects of these plants could help the people to increase their immune and avoid COVID, these plants may suddenly rise and the price will increase. Yeah, this is a very interesting comment because I remember we were having people were using Artemisia, you know, Artemisia annua from China, original from China. So people were using their tea in Cameroon, just for relief for some malaria and so on. But when the COVID-19 came, and the price was around $1 for a box. So during the COVID time, the price was now times 5, in some cases times 6 and 7. So this is, and now even when you want to buy, you may not find the medicine. So that's is a big problem. But a lot of people are also involving in doing cultivation to produce in large amount so that they can produce the enough quantity for the population. So that will also, in some cases, increase the economy of the country for some people. Yeah, thank you. Let's move to Mr.
Yeah.
Is it Mrs. or Mr. Sherfi?
Mr. Safri.
Safri,
Mr.
yeah.
Safri maybe asks about
Honey plus ginger equal to treatment for flu.
Is it true?
That is our mother, we call it our modern medicine. So at home, our mother always do this and give to us when we are coughing and so on, or we are getting flu and we get relief. I think this is true, but it doesn't mean that if you take it in 2-3 days, you don't feel relief, you have to go to the hospital. So that may help if it's just the beginning of the flu and so on. And these are just there to give you some, it's just some tonic constituent in this honey and ginger. So we always take it when we were young, and even at this time of COVID-19, we are also taking. So, and if people are relieved, I think from essential oil we have in the ginger, they are very good for flu, you know. So, yes, it's the same, asking if it is true. Someone saying good morning to me. Okay, thank you, good morning, but yeah. It's Morris, it's not Moorish. Sorry. So, it's still coming.
Still, the same question from Mr. Safri.
Honey plus noni fruit. Treatment for higher blood pressure is true. Noni fruit. I'm not sure about noni fruit. Can I have the name? Noni fruit?
Noni is Annona muricata, I think. Annona squamosa.
Let me write down. Maybe this is something I have to search. You know, it's not only every plant that is in Asia that we have in Africa. Oh, that is common to us.
Yes, that's Annona.
Annona. Yeah, it's if it's Annona, means it's Annonaceae. That it may have alkaloid. Yeah.
Yeah, very bitter.
It may have alkaloid. So I have no experience about these plants. I work on alkaloid, but the alkaloid I work on was alkaloid of Amaryllidaceae family. That's from Crinum and so on. So I didn't work on this part. And as I said earlier, when we are talking about blood pressure, let's look for pharmacologists and so on. So my part is when you say this plant is active against this disease, I should go in the plant and get the single compound that is responsible for the activity you are claiming. So that's my job. So, but in sometimes with experience, sometimes we may know which plants can be used for which disease and so on. So at this step, I'm sorry, I cannot give you the exact answer. I'm sorry. So let's move to Islamuddin.
Ahmad, yes.
Ahmad, yeah, sorry.
From East Kalimantan.
Okay.
It's not in the same province here.
I see, I see. I am Islamuddin Ahmad from Samarinda, East Kalimantan, Indonesia. my question, what do you think about the potential of derivatives of analog of flavonoid group to, I think maybe to help SARS-CoV-2 on how is related to antiviral activity with the level of cytotoxicity of compounds, of a compound. I think this question is still coming to my derivative that I got after chemical transformation. And like I said, those slides of chemical transformation was just to show you that when we are doing the research from African medicinal plants, it's still possible if you get a compound that is having an activity but is toxic. It's possible for us to modify the chemical structures to maintain the activity and to try to increase the to maintain the activity and to decrease the cytotoxicity as well. But in some cases also, we are doing that to identify, because if you can produce a lot of derivatives, around 30 and so on, you may be able from the activity to quickly identify the part of the compound responsible for the activity. That's a pharmacophoric element. So doing this kind of research is not only to show that we have the active compound, but it's also to develop and show something about which part of the structure is responsible of the activity. And at that time, you may, maybe the compound that we isolate is in few amounts. And in the same plants, we obtain some of compound with just some substitution on it and very similar to the very active one. What you do is to make the chemical transformation for the large amount compound to the small amount that will be with the great activity. So we have to know about that. Yeah. Should I move to the next question?
Yes, the question coming from Aristianti.
Aristianti, yeah, NS.
Yes.
So we know that chloroquine, yeah, we know that chloroquine in clinic practitioner still controversial. Some clinicians agree, but the other are not. But what I would like to ask is the interaction between chloroquine, clindamycin, high dose vitamin C to human, again, like to cardiopulmonary system. I think these are pharmacy students, I think, or medical students. So this is a more specific question. Thank you for your question. It's more specific and it should be answered by a more specialized researcher. So I may not be able to give you the answer. I'm sorry. Question 2, some of patients consume the medic combination, got vision blue, rotch in skin, and cognitive disturbance temporary. Do you think it's due to COVID or the combination of drugs? At this stage, I can trivially give, a common answer can come out because this could be from the side effect of the compound also. And the side effect could also come from the combination, the wrong combination of many compounds. And at this stage, the person who is more educated to answer to this question is the pharmacist, because when the medical doctor is making the prescription, the pharmacist, I think, is the last one to confirm that the prescription is okay, because he know exactly how the mechanism. Doctor, I think I'm not wrong because I'm not specialist. Yeah. So I think in this case, you may have many answers. This could come from the side effect that could be lead to one or combination of wrong combination of compounds, and pharmacies are more likely to give the answer to this question. Yeah.
Yeah. Thank you very much, Dr. Morris. Yeah. Maybe I would like to introduce noni fruit is coming. The Indonesian name is mengkudu, and they write the name in
Morinda
Morinda citrifolia.
folia.
Have you ever heard about that?
Sorry, I will just I want to see the photo. Maybe if I see the photo, I can tell you something.
Okay, later.
So,
Maybe we go to someone asks.
yeah, thanks a lot,
Mr.
Mr. Morris. Okay, thank you.
Can you answer one of them? Three of attendees want to ask by raise their hand.
They want to ask directly?
Yeah, I think so. Would you like
but
to ask?
There's a last question that is written here with Himam Suya Pratama.
Okay, so
maybe can you explain about ethnobotanical approach in your research? I think I already make a slide on this ethnobotanical approach in my research. I said, when we are collecting medicinal plants to use for research, what we do is we may, at this stage, we used to follow what traditional practitioner, those doing traditional medicine, because traditional medicine in Africa is totally different to what you call in Asia traditional medicine, because here is you have traditional healers are those who have some ancestral knowledge that they were not in school anywhere, but they know that these plants can be used to cure these diseases. So, and I know in Asia, when you say traditional medicine, it's phytomedicine. So people already make and label and put the name of all the compound inside and everything. But here in Africa, in most of the cases, it's different. So here you have someone who claimed to be a traditional healers that know exactly what these plants can cure in our system. So at that time, when we are collecting, when we need plants, we have to go to them and ask them to visit the forest together. And at that time, they show us that this tree is used to cure these diseases. At that time, we have to shoot the pictures of the tree. And we also go with the botanist. The botanist already, it can give out the name of the genus. It can give out the name of the family of the plant. It can even give the name of the species if it's very experienced. So at that time, we have to search on internet, SciFinder and so on to see, is there anywhere someone would try to isolate compound from those plants? Yes, we may see, okay, what type of compound came in, what technique was used, was it the latest technique? If not, we can use the latest one to get more compound and more active compound and test against the activity claimed by the traditional healers. So, let's keep the ethnobotanical ways. I was also saying, we also by ourselves visit the forest with students, and while walking, sometimes you may find one tree that around the tree, there is no herb growing, no herbs growing around the tree. So all the area is clear. At that time, we have to stop and question ourselves. No one is here to clean under the trees. So what is happening so that these trees, around the trees, everything is clear, there's no herb? Maybe the tree is developing some secondary metabolite that are throwing away, that are destroying any herbs that growing around. And if you are looking for maybe plants again, cancer and so on, you may collect those kind of plants and go and see what is happening. So there are a lot of strategy to approach our research, and mainly to collect the plants, because it's the most important part. Yes, yeah. You said we still have some questions.
Okay, thank you very much, Dr. Morris. Maybe because of the time, we still have to invite speakers in this session. So maybe for the question attendees who raise hand, we will discuss later. Thank you very much, Dr. Morris, for joining us today. We hope in the next future we still have collaboration, maybe in the next international seminar. And very nice to meet you in this seminar, and hopefully you could get a nice rest today.
Thank you. Should I ask you something? Can I? I'm not sure to continue the seminar because, as you see, it's very late here.
Yes, we understand.
Otherwise, I will find myself in the morning without sleeping, or I will be sleeping in front of my laptop. I'm sorry.
Okay, so you can take a break, and then we continue to the next presenter.
Okay, I'm sorry. Thank you so much.
Thank you so much for joining us today.
Thank you. Thank you.
Thank you. Ladies and gentlemen, we proceed to the next invited speaker. The second speaker is Associate Professor Waranyo. First, I would like to read her curriculum vitae. Yeah. Associate Professor Waranyo Pulkaran PhD, coming from Thailand, Chulalongkorn University. Her education in 2010, she got PhD in plant biology, Arizona State University, USA. In 2003, master degree in molecular genetics and genetic engineering in Institute of Molecular Biology and Genetics, Mahidol University, Thailand. And bachelor degree 2001 in Faculty of Science, Chulalongkorn University, Thailand. She has a research special in molecular farming, plant biotechnology, and molecular biology. She got award, 3 awards here: the Nagai Award Thailand 2018, Leader in Innovation Fellowship 2018 until 2019, Newton International Fellowship 2013 and 2015. And also, she got grants in 5 years respectively. In 2019 until 2022, she got Thailand Research Fund grant from Mid-Career Researcher. And also in 2018 to 2019, as the National Science and Technology Development Agency in Thailand, and many others. And about her experience, in 2016 until 2010, she did research and teaching assistant in School of Life Science and Biodesign Institute, Arizona State University, until 2011 to 2013, lecture in Department of Pharmacognosy and Pharmaceutical Botany, Faculty of Pharmaceutical Science, Chulalongkorn University. And now 2018 until present, Associate Professor in Pharmaceutical Science, Faculty of Pharmaceutical Science, Chulalongkorn University. And about publications, she also got around 31 publications, and one of the newest one is about perspective on monoclonal antibody therapy as potential therapeutic intervention for coronavirus disease 19 in Asia. So this is a little introduction about Dr. Waranyo. Dr.
Hello.
Hello. Good morning, okay. Professor Waranyo. Time is yours.
Good morning, everyone. Thank you very much for the very nice introduction. And first of all, I would like to thank the organizing committee for inviting me to give a talk here. In my talk today is about the technique, what we call molecular farming, how of COVID-19. Then actually it's a little bit like changed from the previous talk, right? As all you heard from the previous talk, that's all about secondary metabolite. But what I will talk today is about the plant-produced recombinant protein and how we use it for COVID-19. First of all, I would like to introduce about the technology, what we call molecular farming. You might see that sometimes some people use like FARM, some people use PHARM. Actually, like the word itself is about the technology for production of recombinant pharmaceutical proteins by using plant biotechnology. Then we use like FARM to kind of emphasize the use of plants, like plant farming. But because our goal is using plants to produce pharmaceutical protein, then sometimes we use PHARM. That's how we play with the words, okay? And because molecular farming is a new technology, and this technology will give the opportunity to manufacture medicines to improve global health. And actually in our work, we use the technique we call transient plant-based expression. This is different from producing genetically engineered plants. Then what we do it here, we did not engineer the gene in the plant. We just use wild type plant, you know, that we actually this plant we can grow it outside because no new gene. And what we do here is when we grow the plant, and when we get the plant at the right size, then we will insert the gene that we want into the plant. For example, if we want to produce the antibody, we will insert the antibody genes into the plant. And how to insert it? We use agrobacterium as a tool to transfer the gene into the plant. And we will infiltrate agrobacterium into the leaf, and then agrobacterium will transfer antibody genes in the plant. After infiltration, we will grow the plant for like 4 to 7 days, you know, and then we can cut it and extract and purify the protein out. And then we can use it as a drug or the vaccines, okay? I would like to show you the video how we do this in the lab, okay? And the first video of this one is what we do in our faculty of Pharmaceutical Science, Chulalongkorn University. Then the plant that we use is the scientific name is Nicotiana bentamiana. Is the same family as tobacco, but different one because it's the species that have low nicotine amount. And normally we grow the plant in our plant room. And when we get the plant at the right size, you can see here, when we get the plant at the right size, then we will infiltrate. Like this is in small scale. When we want to taste, we just infiltrate, insert agrobacterium into the leaf. And then after that, we grow it just for like less than a week. Then we can cut it and extract, just simple way using the blender, you know, adding the PBS, you know, because this protein is soluble. And after that, we use the crude extract, purify it, you know, with affinity chromatography. Then for the purification, whatever platform that you use to produce recombinant protein, mammalian cells, bacteria, yeast, the purification step is the same. Okay, then this is how we work in the lab. And some of you might have the question and about like this technology, whether we can use it in the real industry. Then I just want to show you, this is the example. This is a facility in US that they try to produce flu vaccine using molecular farming technology. And you can see that here they grow all the plant in the control room using the robotic system, right? And then they grow in large scale, and they infiltrate like large amount of plant in the big chamber. How they infiltrate this? They just close the lid and then use a vacuum pump to make the inside of the chamber be like vacuum. And then after they open the valve, the air fill in, and then all agrobacterium solution can get into the leaf. You know, that's how they do. And they cut all the plant. You can see this is in the industry scale. Then they can extract. Actually, the principle is quite the same, but you just have to have the larger equipment for making this in the industry. Okay, And the objective of this technology is kind of like to disrupt pharmaceutical industry, because as we all know that in the pharmaceutical industry, most use mammalian cells, right? Then you will get used to the upper figure that if you go to the biologics industry, you will see the fermenter with this mammalian cell and media inside the fermenter, right? The pros is highly controlled. Everything is sterile, right? And it's well established industry standard. Then FDA or the regulator get used to this picture, but uh, the cons is that because it's high technology and very expensive, like if some of you who work with cell culture, you know that even we work with a small flask, like all these media are very expensive, right? And if you have to use the media in like this big fermenter, like 100 liters, like the cost is very high. And for several developing country, like even like in Thailand, we have to import all these media, then the upstream process has very high cost of production. Then we want to replace this fermenter with using plants, which is in the lower figure. Using plants, this technology is lower technology and is inexpensive. We can produce large scale. If we want to produce more protein, we can just grow more plants. Okay. However, it's new, potentially disruptive technology, but we still have to convince the regulator how they can approve and how we can do clinical trial with this technology. Okay. And actually, some of you might think this is new technology, but it started more than 20 years. And I just want to let you know about the recent major clinical development of this technology. Actually, from 2010, Fraunhofer, which is a company in US, start clinical trial phase 1 for avian flu vaccine using this technology. Okay, in 2011, the scientists in Europe get approved for plant-produced antibody for HIV, antibody for clinical trial phase 1. Okay, and in 2013, Medicago, which is the biotech company in US, they get the funding from US government, try to do the flu vaccine, and the goal of this project is like try to produce 10 million doses of the vaccine in a month. And you might think like, yeah, many companies can produce 10 million doses of the vaccine, but the key is how they can produce in very short period of time, like in a month, because in US they're very concerned about the pandemic disease like COVID-19. At that time we don't have that yet, or even with the terrorists. Then that's why they need to prepare the technology for that kind of thing. And also Medicago still working on several clinical trials for this technology. Okay. Last year, 2019, they just finished clinical trial phase 3. And actually, even in Thailand, we are one site of clinical trial phase 3 for plant-produced influenza vaccine, which is a vaccine from Medicago. Right now, there are several GMP facilities that can produce the vaccine from plant biotechnology. And I just want to show you some facility. Like the left one is the facility from BioApp. This is in Korea, South Korea, and they have, I think they launched first product, which is swine flu vaccine already, and they still have several vaccine in the pipeline. The second one, KBP or Kentucky Bioprocessing. This is the facility in Kentucky, US as well. Last 5 or 6 years, I think you all heard about the outbreak of Ebola in Africa, right? And there are some American people get infected with Ebola and sent back to US. at that time, most of them are in coma, mean hemorrhagic, and at that time, there is no drug or specific treatment for Ebola. There is a biotech company in San Diego named MAP Biopharmaceuticals. They study about the plant-produced pharmaceutical for Ebola for a long time before that. They have the good data in mice, in monkey. However, it's quite difficult to go to clinical trial because before that there is no study about plant-produced biopharmaceutical in human yet. But then they have the drug named CMAP. CMAP is a mixture of 3 different monoclonal antibody that produced by based expression, and they produce from tobacco plant. They MAP just called CDC and told them that they have this drug that never try in human, whether they want to try, and all families of every patient sign the consent form, they are okay to use. And at that time, they did test the CMAP with 9 patients, and they found that 6 survived. Like some might have a question that is this number okay? But with Ebola, people know that Ebola virus has very high mortality rate, up to 95%. And with the patient with coma, very severe condition, then 6 survive. This is like very, very successful for plant-produced biopharmaceuticals. Okay, then this is the first product that used in human. Okay, and this picture show the facility that used to produce the Ebola drug or CMAP. Okay, then what I want to introduce to you all is that molecular farming is a new potentially disruptive technology we want to use to disrupt pharmaceutical industry, because the production time is quite short. Then we can produce large amount of drug in a short period of time. Okay, and with the simplicity and scalability, plants are what I want to call is like high-tech, low-tech solution, and they can use to they offer the possibility for production of biopharmaceuticals in the region, for the region, which I think is very important, because as you know that right now when we face the pandemic situation, it's very important for ourselves to build the capacity to be able to produce drug or the vaccine in our region, right? Because when there is a new disease, like emerging disease coming, we cannot rely on just import the biopharmaceuticals. Okay, and then because we think that this is very important technology, in like before January this year, we have several products in the pipeline that we are studying now. We have the therapeutic antibody, like example, rabies antibody, Ebola, Nipah, or E71, with the cause of hand-foot-mouth disease. These are the disease that are the problem in Thailand, and I'm sure that there's still like the problem in several countries in this region. Also, we have the product in a group of immune checkpoint inhibitor that are the drug for cancer, right? We use it for like cancer immunotherapy. This kind of drug like anti-PD-1, anti-PD-L1, or anti-CTLA-4, these are the biologics that very expensive. Like in Thailand, the cost, I'm not sure in your money, but let's say one dose is like 200,000 baht, and the patient have to use every 2 weeks for 2 years. Then not many people in our country that can access to this drug. Then we think that it would be great if we can use our technology to develop and to make this effective drug that our people can get access to. And also we have like several vaccine and also other recombinant proteins. Like for example, we develop osteopontin proteins, which is the protein that can induce the bone production. Then these are the example. However, when in January this year, which is beginning of COVID-19 situation, right? That I'm sure it affects like everyone, right? Because if there is no COVID-19, I hope I can be in Indonesia and, like meet all of you, right? Then with COVID-19, then we just switch all of our facility from all of the product that we are studying previously, and we changed the facility to work with COVID-19. Then at the beginning, we just think like, okay, what is important? Then we are focused on vaccine and also therapeutics antibody. Then the left figure, you can see that after the scientists published the genome of SARS-CoV-2, which is the virus that caused COVID-19, right? We know that the spike, which is the red spike on the outside of the virus, is the important part, which is the candidate for the vaccine. The right figure is the structure of spike protein, and you can see that the outer part here is the RBD, or receptor binding domain. This is the candidate protein that can use as a vaccine, because they know that RBD can induce neutralizing antibody, and that can be the good candidate. Anyway, right now for the vaccine that all over around the world try to develop, they use different type, like some use RBD, some use only S1 or S2 or whole S, and because we don't know which one gonna work, right? We just try. Then the RBD is the potential candidate for the vaccine. Then what we did is we clone RBD gene and put into plant expression vector, and then we insert that into a grow bacterium and then infiltrate into the plant, as you saw from the video previously, right? And then we insert into the plant, then we just leave the plant for 4 more days, and then we cut and extract protein from plants. And then after that, we use a protein A affinity chromatography and purify it. Okay. Then after purification, you can see here that we get the protein, the purified protein that I think is more than 90% pure at around 40 kilodalton here. And we just, after we get this protein RBD, this is the first protein that we get. And another protein that we are interested in is like monoclonal antibody, because we think that when SARS-CoV-2 can bind to the receptor on the human cells, this receptor we know that is S2 receptor. And we think that if we can have the neutralizing antibody that can block the virus, then that will be the good treatment, like a Ebola monoclonal antibody, right? And from previous study, we know that last 10 years when we have the outbreak of coronaviruses, the first one is SARS-CoV-1, and then we have MERS, right? SARS-CoV and SARS-CoV-2 use the same receptor, which is S2. Then we just try to screen and produce all of the antibody against SARS-CoV-1, okay? And previous studies show that antibody named CR3022 is one antibody that can bind to SARS-CoV-2. And then we produce that using transient plant-based expression. We get the purified antibody here, which has a size around 150 kilodalton. And we just test it in vitro. What we did here is like we use the plant-produced RBD protein coat on the plate, right? And then we add different concentration of CR3022. And you can see that when we increase the amount of the antibody, we get the higher signal, which means this antibody CR3022 can bind to SARS-CoV-2 RBD, right? However, when we use other type of the plant-produced antibody, like that, although when we increase the amount of anti-PD-1 antibody, there is no binding. Then this binding is quite specific between CR3022 to SARS-CoV-2 RBD protein. We also test the binding with the real virus. Okay, in this study, we infect the viral cells with SARS-CoV-2, and you can see that on the left one, we use a positive serum of the patient who who got infected with SARS-CoV but recover already. Then they will have the antibody against SARS-CoV-2, right? Then you can see that we can see the green color, which show the binding between antibody and the virus. And also the middle panel is our plant-produced CR3022, and it shows that our plant-produced antibody can bind to the virus as well. However, the anti-PD-1 antibody cannot bind. Anyway, after we get this antibody, we just test it for the neutralizing antibody. You know, we just want to know whether this antibody can inhibit the infection of SARS-CoV-2. But unfortunately, this antibody cannot inhibit. Then we could not use this CR3022 as the therapeutics for SARS-CoV-2, but we can use it as the reagent for the study of the virus in the lab, right? Anyway, we still continue produce other different type of the antibody by using plants as a platform. And we just got like 2 new antibody that we hope it can neutralize SARS-CoV-2 that we will test in the future. And if it can neutralize, then we will continue study it as a therapeutics. Okay, and I just want to come back for like not only therapeutics antibody, but we also interested in vaccine development. Then what we are studying now is because the RBD protein that we produce from plants is the candidate vaccine, because this protein we know that we think that it can induce the immune response and also can induce the neutralizing antibody. Then we set up the mice experiment, and what we did here is like we inject our vaccine RBD protein. We have 2 types of the vaccine. One is the RBD that we have his tag on it. Another one is the RBD that we fill with FC region of the antibody. Okay, and then we have the one with and without alum, which is the adjuvant in the study. We did IM immunization in the mice 2 times. Then we give the mice 2 doses of the vaccine with 3 weeks interval. Okay, and you can see here that this is the titer, the IgG titer, and you can see like after first dose we get little bit we get antibody titer, but the antibody titer is higher, significantly higher after 2 doses immunization. And you can see here that when we have alum like RBD-FC with and without alum can increase the IgG in the mice. And we also study for IgG1 IgG2A ratio, and with this result our result confirmed that alum can induce Th2 response, which means it's higher IgG1 antibody. Okay, but the important result that I want to show here is the right graph, which is the neutralizing titer. Neutralizing titer means that we use the serum of the mice after immunization, and we bring the serum, we mix it with the virus in the lab, BSL-3 lab, and we can show that if this serum has neutralizing antibody, it means that when you mix this serum with the virus, it can inhibit. Then the virus cannot infect the cells. Then that is the good antibody, let's say. And from our data, you can see that the plant-produced protein mixed with alum can induce high neutralizing titer. Then this is quite a good sign, and but we have to continue the study. The next step, we have the plan to continue to study this vaccine in non-human primate, which is the monkey, and we hope to start the experiment in this month. And also we have 2 receptor. It means that it cannot get infected with SARS-CoV-2. Then we need to use hamster instead, because hamster is a good model for SARS-CoV-2 infection. Then what we want to do is like we need to immunize hamster with our vaccines and then challenge with the SARS-CoV-2 and see whether it can protect the animal from the infection. Okay, with this slide, I would like to show you the timeline that, you know, like with our technology, we use only 10 days to produce recombinant protein, both RBD and antibody. And if we have the facility, large scale facility, then we can have like, we can use like 1 or 2 more weeks, and we can produce more like large amount of the vaccine or the drug. Then that's why we think that this technology is very good for our regions, that we can prepare ourselves for the new emerging disease. And this is all my talk, that I just want to thanks all the funding from Chulalongkorn University, and Science Research and Innovation, and from Bayer Phytopharm Company. And also the important person that I would like to thank is our collaborator, Associate Professor Aluni Titi Thanyanon from Faculty of Science, Mahidol University, because her group help us to test all of our protein with the virus, because they have BSL-3 laboratory in Mahidol University. And also, I would like to thank all of my team. Without them, I would not have all of this work. You know, like then they are the people who work very hard during the COVID time. And not only this, but I just want to show you a little bit on about the company that we just start, because you heard we got the funding from Bayer Phytopharm. Then last 2 years we set up the spin-off company Bayer Phytopharm, which is the startup from Chulalongkorn University. Bayer Phytopharm get incubated by Chulalongkorn University Innovation Hub. We set up the platform to disrupt biopharmaceutical industry, and we have the CEO, Dr. Sutila, who is the health economist. And right now we use this platform to produce several types of the recombinant protein, like for the lab reagent, cosmetic, test kit, biologics drug, and all the vaccines. And these are all the products that we use the plant platform to produce. You know, then you can see that for the lab reagent and cosmetic, we have like growth factor products. Okay, we have test kit and animal and human biologics drug in the pipeline. And I just want to show you this, because if some of you here are interested in this kind of product, then please feel free to contact the company. Or if you have any idea, you want to collaborate with us, then I am more than happy to collaborate with you on this. And I think this is all what I want to talk for today. Thank you very much for your attention, and please feel free to have any questions or comment. Let me see.
Okay, thank you very much, Dr. Waranyo. Maybe can you still stay here, because maybe we should continue to the last presenter, and after that we can have a discussion. Is it possible for you?
Yes, yes.
Okay, thank you very much. So let's proceed to the last invited speaker. Now we are going to invite Professor Ibrahim Jantan from Thailor University, Malaysia. And before doing that, I would like to read a brief curriculum vitae from Professor Ibrahim Jantan. Professor Ibrahim Jantan is professor in medicinal and natural product chemistry. August 2018, he graduated from University of Mansoura, Egypt with BPharm degree in 1981. Obtained his Master Science in Medicinal Chemistry from University of Minnesota, USA in 1985, and his PhD degree in Natural Product Chemistry from the University of Malaysia in 1993. And then he has more than 33 years of research experience in natural product and medicinal chemistry and pharmacological activities of natural products. So his research interests are identification of natural bioactive compounds, their derivatives and analog as chemical lead for specific therapeutic efficacy like cardiovascular, protective, immunomodulatory, anti-inflammatory, pathogenesis, and many others. So he has been invited to deliver many keynote speaker, plenary, invited lecture in local and international conference. And also he is a reviewer of manuscript in ISI index journals such as phytomedicine, phytotherapy research, phytochemistry, phytopharmaceutical biology, drug design development and therapy, frontier in pharmacology, BMC, and many others. So to Professor Ibrahim Jantan, time is yours.
Thank you, Ibu Hardianti. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Very good morning.
Good morning.
First of all, I'd like to thank the organizing committee, especially Dr. Shamsuno, who has been communicating with me, inviting me to participate in this webinar. And also the head of STIFA, Dr. Nur Samsiar, and also for Dr. Jasruddin, head of LLDI KTI. Okay, let me share my slide now. Okay, the title of my talk is Search for Herbal Remedies from the Tropical Rainforest to Battle COVID-19. As you all know, COVID-19 is a new pandemic, and the cases around the world are surpassing 14 million right now.
Sorry,
yeah.
Dr. Ibrahim, can you
share
your slide?
I'm not sharing it now?
Yes.
Oh, let me see. I thought I'm sharing it.
Please let's stop first and then stop share.
Stop share, okay.
Stop share and then share again. Start to share again.
Okay. Okay.
We couldn't get your slide presentation yet.
Now, can you see my slide?
Not yet. Have you opened your slide presentation?
Yes. Let me see. Share slide.
Please open your PPT first and then slide share.
Okay.
Oh,
no?
Not yet. We only can see your computer.
Okay, share screen.
Yeah. Yeah, please choose your PPT in the share screen.
Okay.
Okay, yeah, that's okay.
Okay, thank you. Sorry for the technical problem. Okay, the title of my talk is Search for Herbal Remedies from the Tropical Rainforest to Battle COVID-19. So as you all know, COVID-19 is a new pandemic. So there's no drugs or vaccines licensed for treatment or prevention of COVID-19 at the moment. And COVID-19 cases worldwide, it's already almost more than 14 million already. And it's continuing to grow. It's very scary. More than 1 million people have died. So scientists and clinicians are pushing forward efforts to develop vaccines and treatments to slow the pandemic. The race is on. Yeah. How can we develop vaccine and discover a wonder drug to treat COVID-19? And it has to be faster than ever before. But if you look at the stages of drug discovery and development, timeline to discover, develop a safe, effective medicine or vaccine is very long, usually more than 10 years, right from the in vitro, in vivo, the preclinical studies, toxicity studies, and then you go for the clinical trial, phase 1, phase 2, phase 3, and then you need to go for the regulatory submission, marketing, regulatory approval, and so on, and phase 4, post-marketing. So it takes very long, and a new drug or vaccine has to go through from the lab to the clinic, market, and it costs almost more than US 1 billion, especially for complex diseases like cancer and also for COVID-19. So there should be a different approach. We need the approach should be fast. Accelerated discovery of COVID-19 drugs during this pandemic should be done in a very rapid way. So what the scientists are doing now, they are using the drug repositioning or repurposing approach. It is discovering new therapeutic uses for existing medicines. So a strategy by which new or additional value is generated from a drug by targeting diseases other than those for which it was originally intended. So all the drugs are being tested clinically now, drugs being used for other purposes initially. So now they are for the drug repurposing, they are trying to determine whether these drugs or these vaccines are effective against COVID-19. So several antimalarial and antiviral agents are being used now on the clinical trial, and compassionate use protocols and both based on in vitro activity against this virus and also on limited clinical experience. So efficacy has not been established for any drug therapy at this moment. So no specific therapies has been approved by WHO, by US FDA for severe acute respiratory syndrome coronavirus 2, SARS-CoV-2, the virus that causes COVID-19. So they need a fast track approval. So what is being done now, FDA now allows emergency use of these investigational drugs. For example, the antiviral remdesivir and also the antimalarial chloroquine, hydroxychloroquine to treat COVID-19 and even before going through the formal approval process. So before I proceed, just to a bit on the stages of COVID-19. So to make it simpler for the participants to follow my later slides. So stage 1 is a pre-symptomatic phase of fever, cough, and generalized malaise heralded by high viral loads in severely affected cases, and then followed by stage 2. After about a week, viral pneumonia manifests that involves lower respiratory tract cytokinemia. This is cytokine release syndrome or CRS, cytokine storm. It's characterized by exaggerated levels of pro-inflammatory cytokines and other phytonomonic biomarkers of inflammation, leading to rapid onset of acute respiratory distress syndrome. And finally, stage 4 will lead to multiple or multi-organ failure. So these are tables to show what are the antimicrobials or antivirals that's being tested against SARS-CoV. What tested means clinical trial. Chloroquine, hydroxychloroquine, the first one. It's formerly used as anti-malarial. In fact, chloroquine, all the synthetic drugs originated, derived from quinine, anti-malaria. The rationale for use, because previous study by in vitro, they are active against the virus, so it shows some potential. And also we have immunomodulating properties, same with hydroxychloroquine. It also have in vitro but limited clinical data suggests potential benefit. And in vitro data suggests the drugs have activity against the virus. So potential benefits inhibit the pneumonia of patients with the virus infection. But recently, WHO under their Solidarity Trials Committee, they discontinued use of this drug to treat COVID-19 because clinical trials showed little benefit for COVID-19 patients. The antivirals, lopinavir combination, these are HIV protease inhibitors. Preclinical data suggests potential benefits, and in vitro animal model in vivo studies showed potential activity for other coronaviruses. So they also show they also done randomized control clinical trial, but failed to show benefit in patients with COVID-19. So again, WHO under the Solidarity Trial Committee, they discontinue or recommend discontinue use of this drug to treat COVID-19 patients due to unfavorable pharmacodynamics. And we have remdesivir. This is the most promising drug to treat COVID-19 now. It's a broad spectrum antiviral. It's a failed Ebola drug. The in vitro activity against the coronavirus shows some potential. So at present moment, there are several large-scale clinical trials are underway. Remdesivir demonstrated significant in vitro activity, and also and clinical trial evaluating the efficacy of remdesivir in patients affected by virus are still ongoing. Another antiviral, favipiravir, this is investigational RNA-dependent RNA polymerase inhibitor, also based on in vitro study. It can be treated. It can use to treat influenza with in vitro activity. So this is also ongoing in the clinical trial. So this is the structure of remdesivir. This is synthetic nucleoside analog prodrug. It's a monophosphoramidate. It's the most promising antiviral agent to treat COVID-19 at present moment. And this is mentioned by previous speaker. This is the diagrammatic presentation of the virus, SARS-CoV-2, the spike protein, the nucleoprotein-bound RNA, and the other, the amyloid protein, and also the membrane protein. So how the antiviral works, so mechanism of antiviral action, they inhibit the viral enzymes of processes by inhibiting the viral RNA polymerase, and also inhibit the ACE2 receptor, cellular receptor inhibition, spike protein, and also they can acidification surface of cell membrane inhibiting fusion. This is how chloroquine, hydroxychloroquine works, and also immunomodulation of cytokine release. So vaccines, it's also many vaccines in clinical trials now, leading vaccines to battle COVID-19. There are more than 100 of them around the world on development of vaccine for coronavirus. And up to date, 8 candidate vaccines have been tested in clinical trials, but none have been in the market yet. And hopefully by next year, maybe early next year, one of these will come out at least, so that it can have immunity towards the virus. So you have vaccine, for example, by Moderna, we have vaccine, the mRNA, and also another one is by Pfizer. We have the also mRNA vaccine, still under clinical trial. Some are phase 1, some are, most of them phase 1, some of them preclinical, some Sanofi, GSK. You have the repurpose of SARS vaccine candidate, it's under preclinical, and so on. And how it works, vaccines produce neutralizing antibodies by B cells. So the antibodies from B cells will block the antigens, infection, leading to prevent the infection. And it can also act through the T cells. The vaccine can induce the T cell response and kill the infected cells. Besides treating the disease, they all by using drugs, antiviral drugs, and also vaccines, adjunctive or supportive care also being employed. For example, antibiotics, macrolide antibacterial, this is used together actually with antiviral agent, and also antibiotic, and also with the anti-malarial agent. It may prevent bacterial superinfection and also have immunomodulatory properties. So they also have the immunosuppressants, example, tocilizumab, sarilumab, and siltuzumab, and these are used, because they are immunosuppressants, reduce cytokine release syndrome, and inhibits the interleukin-6 mediated signaling by competitively binding to both soluble and membrane-bound interleukin-6 receptors. And you have COVID-19 convalescent plasma. This is also being tried. Plasma collected in persons who have recovered from COVID-19 that may contain antibodies to SARS-CoV-2. Clinical trials now is being conducted. Evaluate the use. Then you have corticosteroid, not recommended for viral pneumonia, but pneumonia, but may be considered for patients with refractory shock or acute respiratory disease syndrome. And also you have inhaled pulmonary vasodilators, anticoagulant, and NSAIDs. So phytochemicals have multiple effects, possible multiple effects to the cells, to the animal models, or to human beings. They can act directly, for example, multiple effects, particularly on microbes, virus, inflammation, cancer, immune system. They can act directly as antioxidants. They can act directly as antimicrobials, antiviral, by acting on the membrane, acting on the cell wall, acting on the synthesis, protein synthesis, the nucleic acid synthesis. They act directly, or they can kill the cancer cells directly. Or they can work, or they can act through the immune system. This is the area that I'm going to discuss today, how phytochemicals act on the immune system and also can as potential use as an adjuvant in treatment of COVID-19. So it can have suppressive effects or stimulant effects. It can be immunostimulants or immunosuppressants. So being immunostimulants, it will stimulate ROS, reactive oxygen species production. And this will lead to increased defense, killing virus, killing microbes, and so on. Increase ROS, so it kill the virus. So first line of defense. And it can also increase ROS production, and it will help to apoptosis, to kill tumor cells. But if immunosuppressants, yes, reduce ROS production, so have anti-inflammatory, anti-cancer effects, and also can be used as an anti-inflammatory related diseases. So this is the area that I think have potential. In fact, if you look at how compounds or natural products, how they look at the mechanism of actions that I've discussed just now, they are working on the immune system, on the innate, on the adaptive immune systems. So, present this information, a lot of news, especially in the viral in the media, social media, misinformation, use of certain foods and supplements to prevent or cure COVID-19. It's a means of claims, yeah. For example, garlic, antibacterial effects, but limited research on its antiviral property. Yet people claiming it as can cure COVID-19. Lemons, good source of vitamin C, but no scientific information on this. Vitamin C is very popular, support the normal functioning immune system, but there's no significant differences between common cold and coronavirus. No evidence vitamin C can prevent or cure COVID-19. Alkaline foods, clear alkaline foods, pH higher than the virus pH can kill the virus, which is not true because there's no scientific evidence to show this. Okay, the body regulates acidity levels regardless of the types of food being consumed. And the keto diet claims that high fat and low carbohydrate diet can boost the immune system. So no scientific evidence demonstrated that a ketogenic diet can prevent coronavirus. So herbal remedies to battle COVID-19, can they? So let us look at, based on what I presented in my slides before, it can act as an antiviral. Previously, speakers talking can be used to come up with using recombinant protein. I just really focus on the protein to come up with a vaccine. Antiviral agent, it can inhibit the viral enzyme, the viral RNA polymerase, or inhibit the ACE2 receptor, or acidify the surface of cell membrane, inhibit the fusion of the virus into the cell, into the macrophage or the immune cell. Or as immunostimulant, can boost the immune system, stimulates the first line of defense, phagocytosis, leading to ROS, or respiratory burst, and increased production of ROS containing or reactive oxygen containing molecules that are antimicrobial, antiviral. So this prevent against viral infection, as I mentioned just now in my previous slide. As a first line of defense, yeah, you have immunostimulate, stimulate immune system, produce high level of ROS, and also kill the virus or the microbes. As immunosuppression, they can down regulate inflammatory responses and reduce the excessive cytokine production associated with respiratory viral infections. So this has potential to be used as an adjuvant to treat COVID-19. So there are some studies previously published, most recent in 2020, in fact, but all the studies are predictive and using in silico studies. As of course, you know, COVID-19 is new, so not much work is being done and published until now. So most of the work are predictive and based on in silico studies. So on in silico studies on antiviral activity of herbal extracts and constituencies. Recently, there's a publication on prediction on efficacy of liquiritin in liquorized extracts and using traditional Chinese medicine to treat COVID-19 by preventing rapid replication virus in vero cells. And this was determined by using the AI, artificial intelligence system. They have not published the data yet, but you can see it in the internet and on some reports on this work. In China, the Chinese traditional medicine has been given to more than 90% of COVID-19 patients as part of their treatment, but there are no statistics or evidence to prove its efficacy. Okay, so recently there's one publication in reprint, identification of potent COVID-19 main protease or micro inhibitors from natural polyphenols and in silico strategy and unveils a hope against corona. And from this study, they have, through molecular docking study, they showed that some of the compounds, for example, hesperidine, lutein, diosmin, epine, acetylcurcumine, and so on, they are found as more effective as more effective COVID-19 than the positive control nalfenavir. So let me stress on this because this is what's going to, based on what I'm going to present on my work on the immunomodulatory effects of plant extracts and their active chemical markers. So immunosuppressants as adjunctive to treat COVID-19. So as as mentioned in my previous slide, stage 3 of COVID-19 develops symptoms of hypercytokemia, cytokine release syndrome, CRS. This is characterized by exaggerated levels of pro-inflammatory cytokines and other pathognomonic biomarkers of inflammation, leading to rapid onset of acute respiratory disease syndrome. So COVID-19 patients exhibit hyperinflammation, so an immune system triggered by the virus. The impact of initiating immunosuppression, these COVID-19 patients is being tested in several ongoing clinical trials. So cytokine release syndrome may be a component of severe disease in COVID-19 patients. So if you use immunosuppressants, they can down-regulate inflammatory responses and reduce the excessive cytokine production associated with respiratory viral infection. So I'm going to present the rest of talk on representative of my work on the immunomodulatory effects of standardized extracts of lichen or plants from tropical rainforest, and also work on the pure compounds or the active chemical markers from these plants. So the plants that I've worked on that showed very potent or potential to be used as an antiviral agent. Phyllanthus amarus, Tinospora crispa, and Zygimba zerumbate and their marker compounds. So we have, in fact, published our work already. We work on the immunomodulating effects on chemotaxis, the beta-2 integrin CD18 expression, phagocytosis, and chemiluminescence of human phagocytes. And this is actually a first line of defense on phagocytosis. And the immunomodulating effects of on nitric oxide production of phagocyte cytokines released from the leukocytes and lymphocytes proliferation. So in fact, if you're interested, you can go through papers. So, and this is Phyllanthus amarus. It's being also widely used also in Indonesia. We have another Phyllanthus neururi, so being used as an immunomodulating agent. So this is the flow chart of methodology. Just for the interest of students who like to be involved in this area. You collect the plant, you can collect it from the wild, collect it from plantation, extraction. 80% ethanol, you may ask why, because 80% or ethanol is safe to be used, and also this will help industry. If you use other solvent like methanol, they are toxic. So we have residual solvent after the extraction. So we use 80% ethanol in our study. And then we have bioassay guided isolation of active compounds using the in vitro assay. And then for the extract, we standardized them using HPLC. We also use the LCM-SMS for chemical profiling. And then for the in vitro assay, we have the chemiluminescent assay, chemotaxis, phagocytosis, CD18 surface expression assay. These are all the phagocytosis or phagocytosis assay. And then we have the T-cell proliferation assay, cytokine assay, and nitric oxide assay. For in vivo assay, we work on animal model, and in vivo innate immune response, and to look at the adaptive immune response, and also humoral immune response and cellular immune response. So these are some results just to show you standardization of the extract. This needs to be done. We need to characterize the extracts. Whenever you work on plant extracts, you need to characterize them. The least you do is to standardize them. You don't want to isolate the compound, and also you want to work on the extracts, they need to be standardized. So this is an example of standardization work using HPLC quantitative and quantitative analysis of Phyllanthus amarus extract. So these are, we use two different HPLC methods to identify phyllanthine, the hypophyllantine, and the phenolics, calic acid, the corylagine, ellagic acid, guanine. So these are the amount of the compounds in the extracts, and we are using the lignans, phyllanthine, hypophyllantines as the marker compounds. Reasons because they are most active against all the in vitro assay. So these are the structures of the major compounds. The 80% ethanol extracts of Phyllanthus amarus. These are the lignans, phyllanthine, hypophyllantine. These are the polyphenols, the corylagin, geranin, allergic acid. From this study, the results shows that in vitro effects of philanthropy virus and its isolates on phagocytic activity on human neutrophils, the standardized extracts, philantin, hypophilantin, geranin, and corylagin as active chemical markers in this case, and compounds featured high inhibitory activity on chemotaxis and oxidative bus of phagocytes. Philantin exhibits the strongest inhibition on ROS production, comparable to aspirin as positive control. Philantin, hypophilantin showed significant inhibition on the polymorphonucleosides, chemotaxis, expression of the beta-2 integrins, expression in leukocytes, and possess potent inhibitory action on phagocytic activity. We have published work. You can go and read the paper to look at the detailed study. And just to show you some data, raw data, these effects of Tinospora crispa extract, TCE stands for Tinospora crispa extract, and its isolated compounds on nitric oxide production in lipopolysaccharide, LPS-induced macrophage RAW264.7 cells. So from these studies, you can see the Tinospora crispa extract and the compounds, magnofluorine and the other alkaloids, they stimulate production of nitric oxide. So they are immunostimulating. And by inducible nitric oxide synthase significantly in a concentration-dependent way. But the non-alkaloids, the syringine and 1-octacosanol demonstrated the opposite effects, immunosuppressing effects. And they are dose-dependent, example you can see here. Its highest concentration to the lowest concentration. This is suppressing, this is stimulating Tinospora crispa extract. These are the alkaloids, magnofluorine and pharmacoanilin, and so on. So highlights of findings for the in vitro study: the strong in vitro immunosuppressive activity of the standard extraphyllanthus virus was due to the presence of their major constituencies, especially the phenols, polyphenol, geranin, corylagin, and also lignans, philantin, and hypophilantin, which are able to modulate the innate response of phagocytes at different steps, the innate immune response. Zerumbon was the active marker compound in zinc zerumbate and responsible for the immunosuppressive and anti-inflammatory activities. So the strong in vitro immunosuppressive stimulatory activity of the standard Tinospora crispa is mainly due to the alkaloids, especially magnofluorine. It has potential to be developed as natural immunostimulant and might be beneficial in improving the immune-associated diseases. So the following is our the in vivo immunomodulatory effects of the extracts and their marker compound and the humoral and cellular component immune response in Kyoto rats and Barcy mice. The effects of extracts and compounds on neutrophil migration, the maximum expression, phagocytic activity, the T lymphocyte phenotyping, lymphocyte T and B cell proliferation, and the Th1, Th2 cytokines. So the effects of extracts and compounds on the myeloperoxidase activity, nitric oxide production, macrophage phagocytosis, the delete type hypersensitivity, the DTH, serum immunoglobulins, immunoglobulin G and immunoglobulin M, and ceruloplasmin and lysozyme levels. We have in fact published our work in journals, so you can refer to journals for the detail. So for the in vivo immunomodulatory effects, for the innate immune response, we work on the cellular immune response. We look at the CD11B, CD18 surface antigen expression assay, leukocyte migration assay, phagocytosis assay, the myeloperoxidase activity, macrophage activity on the phagocytosis, and nitric oxide production. And also immunoactivity, we look at serum levels, ceruloplasmin, and lysozyme. For the adaptive immune response, we look at the cellular immune response, the T, B cell proliferation, measurement of B and T lymphocyte subpopulations, the helper cells, Th1, Th2 cytokine releasing assay, and also the delayed type purpose sensitivity, measure the odema using using the plethysmometer. So, and for the neural immune response, we estimate the level, the serum level of immunoglobulin G, immunoglobulin M, using the ELISA kits. So these are just to show diagrammatically the plantus extract, we extract with ethanol, and then we characterize them using HPLC standardized with the chemical markers. And then we use animal model, we use palsy mice, we start to rats and look at evaluate the immunomodulatory effects of the standardized extract and look at the specific, non-specific immune response and non-specific cellular immune response. This has some data to show the effect, for example, Pilantin, effect on cellular and humoral immune response. It decreased the serum level immunoglobulin and immunoglobulin G and immunoglobulin M. For the cellular, it reduced or inhibit T cells and B cell proliferation, T cell subpopulation, inhibit the delayed type hypersensitivity response, and it also reduce the phagocytosis. For the serum immunoglobulin G and immunoglobulin M levels, very interestingly, for the Dinospora crispa extract showed a significant enhancement in the antibody production. You can see it's a dose dependent. Yeah. For this, the TC dose dependent, so you can see the production level of this increased level. And for the Philanthus reduce the levels of immunoglobulin G. This is Philanthus at different concentration, 50 microgram per microgram. This is 200 microgram per ml. And then for the immunoglobulin M, also Dinospora crispa showed significant enhancements in antibody production in dose-dependent manner, and opposite direction, Philanthus reduced the level of immunoglobulin M. So in vivo immunosuppressive effects of zerumbone and Philantin, they inhibit the CD11B, CD18 addition, the engulfment of E. coli by peritoneal macrophage molecule, nitric oxide, and MPO, myeloperoxidase release, inhibited T and B lymphocyte proliferation, down regulation of the Th1 and Th2 cytokines, inhibited percentage of CD4 and CD8 in spinocytes, strong inhibition of the spleen red blood cells induced. This is for the adaptive immune system. Swelling rate of the mice paw in DT, delayed type hypersensitivity, significant inhibition of serum level of cerebroplasmin lysozyme, and also down-regulated immunoglobulin M and immunoglobulin G. So it shows immunosuppressive effects, and we have published the work in Medicine recently. And highlights of the in vivo work, yeah, the standard extracts of Dinospora crispa and magnoflorin possess potent in vivo immunostimulatory properties. So they activated the cell-mediated immunity by enhanced chemotactic and phagocytic activity of neutrophil, along with enhanced expression of pro-inflammatory integrin MAX1. So they also enhanced proliferation of spinocytes, simultaneously augmenting the production of Th1 helper cell, cytokines, and nitric oxide production. They increased the levels of the myeloperoxidase activity, and also especially the immunoglobulin G and M. For the standard extracts of Philanthus, especially Philantin and zerumbate, zerumbone, the pure compound, the active marker, were effective in vivo immunosuppressive agents. They inhibited the chemotactic and phagocytic activity of the neutrophil, production of Th1, Th2 cytokines, nitric oxide production, expression of integrin MAX1, and suppressed proliferation of pinocytes. They reduced the levels of especially the immunoglobulins. So we have published a work, you can refer to this publication. So the next essay we are going to work is to look at the effects of the extracts and the pure compounds on the signaling pathway, the inflammation of modulatory effects of the plant extract and compounds on the NF-kappa B, MAPK, and PI3K, AKT signaling pathways in macrophage. So the plants used are as I mentioned just now, we work on many plants, and some plants are very active, especially Tinospora, Crispa, Ephilanthus, the Zingiber zerumbit, Curcuma aromatica, or Curcuma longa. So you use U93 macrophage induced, will be stimulated by LPS, lipopolysaccharides, and leading to the productions of all the cytokines, the protein expression, and so on, gene expression. So for the productions of the cytokines, we determine by using ELISA, TNF-alpha, interleukins, interferon gamma. For the protein expression, all the protein produced in this, the signaling pathway, and NF-kappa B, and APK, and PI3K, AKT, all these are produced. We look at the effects of the plant samples on the expression, protein expression using Western blot. And for the gene expression, we measure using quantitative RT-PCR to look at, especially on the COX-2, cyclooxygenase 2, TNF-alpha, and also interleukin-1 beta. And this is just a detailed flowchart of determination of the molecular effects of plant samples on the pathway. Yeah, so you can see this is a pure. We use extract and pure compounds, and then these are the cell U937 human cells differentiated into macrophage. And then you use 90% ethanol extract, or we use a pure compounds, and then we treat cells, which is being stimulated by LPS. Yeah? And then these are the quantitative analysis using HPLC, SMS. For the pure compound, we identify the structure by using all these NMR spectroscopic techniques, MS, and so on. And we look at the cell viability using Alama-Bluese, ELISA, use ELISA as mentioned just now, determine the cytokines release, protein expression, Western blot, and then the gene expression, the qRT-PCR. So there are some data to show the effects of Ephilanthus amylase extract on MAC activation, protein expression, or the kinase enzymes. The P38, for example, ERK in LPS-induced U93 cells. You can see there is inhibition, yeah, with inhibition of release of the protein kinase. And this is dose dependent. You can see at 60 microgram per ml is the stronger inhibition compared to 15 microgram per ml. Same thing with the, this is the kinase, this is PGNK, and this is the PERK, and this is the P38. And you can see a very good dose-dependent relationship in terms of the protein expression of this kinase protein. And this is the effects of filantin on NF-kappa B activation, which again protein expression study. You can see it's also dose-dependent. You can see the inhibition, stronger inhibition, high dose-dependent of the protein kinase, the PIKK kappa B alpha. It's a dose-dependent relationship. You can see the immunoblot diagram with the effects. So highlights are finding immunosuppressive effects of zingiber, zerumbet, and zerumbone on the pathways, signaling pathways in human macrophages. I said they inhibited the COX-2 protein and mRNA transcription and downstream products, TNF-alpha and interleukin-1 beta. And they also significantly suppress the phosphorylation of the protein kinase dose-dependently and restore the degradation of 1-kappa beta alpha in the NF-kappa B signaling. They downregulated the phosphorylation of AKT, this kinase protein in a dose-dependent manner. They also significantly attenuated the expression of the MyD88 and toll-like receptor 4 upstream signaling. This is the presentation of the signaling pathways of all the NF-kappa B, PK, and AKT signaling pathways. And this the red block here to show the site where the compounds or the extract can inhibit or suppress or modulate the kinase, maybe the kinase protein and so on. And this is again the same show Phyllanthus hemaris and the major compound phyllanthine, hypophylanthine, neranthine also show the same effects. So it significantly suppress the phosphorylation of protein kinase dose dependently, and also downregulated the phosphorylation of the AKT, the protein kinase in a dose dependent manner. So significantly stimulated expression of ID88 and TL or toll-like receptor for upstream signaling. You can read publication, the detail of the work in our publication. So for magnofluorine, it shows immunostimulant effects. So the magnofluorine significantly upregulated. They show the opposite effects. So the production of TNF-alpha, interleukin, the cytokines, enhance the gene expression, the mRNA transcription level, the lipopolysaccharide prime, U937 macrophages, enhance the NF-kappa B activation, prompting the population of the protein kinase, and also the 1-kappa B alpha degradation. Max treatment concentration depend or dose dependently augmented, increase the phosphorylation of the protein kinase. Also, it enhanced MyD88 and TR4 upregulation, which are essential for the signaling activation. And also, MAC has impressive role in boosting immune functions by upregulating of immunological parameters through the MyD88 dependent pathway or activation. So the effects of magnofluorine and LPS activate release of the prostaglandin E2 and expression of COX cyclooxygenase 2. So the A is the effect of the MAX or magnofluorine on prostaglandin E2 production. It's dose dependently it increase. Okay? Can increase the production PG2. Also the effects also increase the COX2 protein expression, dose dependently, and also effects increase several-fold, increase on the COX2 mRNA expression. So this is a summary, to see the conclusion of my work based on these studies. We use the standardized extract, Tinospora, CRISPR, Syngimbazurumbat, Phyllanthus hemaris. These are the marker compound because they showed potent activity, especially in the in vitro study and also in vivo. And how they work, we have, for example, Tinospora, CRISPR, magnofluorine show strong in vitro and in vivo immunostimulant activity. They stimulate phagocytosis, increase respiratory paths and production of reactive oxygen-containing molecules that are antiviral. So it can be used as first line of defense, prevention against coronavirus, potential use. But of course, more work needs to be done. It's not conclusive, but we can proceed from here to work on Tinospora CRISPR, especially to look at how it can work, especially on the COVID-19 virus and the SARS-CoV-2. And then Zerumbate, Zigimba-Zerumbate, and Zerumbone, that's strong again, same like Phyllanthine, it shows strong in vitro, in vivo immunosuppressive activity. So down-regulate inflammatory response and reduce excessive cytokine production. So it can be used as an adjuvant to treat COVID-19. The potential use, of course, more work needs to be done to prove this. And the same for Phyllanthine, shows the same immunosuppressive activity and potential to be used as adjuvant to treat COVID-19. So future work, what needs to be done? Because SARS-CoV-2 is new. Yeah? COVID-19 is just happening. So this is what we plan to do in future. In vitro immunomodulatory effects of herbal extracts and their chemical markers on cells infected with the virus. And also we would like to work on the in vivo immunomodulatory effects using COVID-19 disease animal model. And continue working on antiviral effects to look at inhibition of the how the compounds or the extract inhibit the viral enzymes or through the viral and RNA polymerase enzyme, how they inhibit it. can it be the ACE2 receptor, and also whether it can acidify the surface of cell membrane by inhibiting fusion of the virus. So this is my tip. Good team members, my former students, some of them already establishing themselves all over the world, some from Bangladesh, Pakistan, some are doing postdoc in US and so on, some in Egypt, in Indonesia. So thank you for their contribution. Thank you very much for your attention. I'm open for question and answers. Thank you very much. Back to Ibu Ardianti. Thank you.
Thank you very much, Professor Ibrahim, for such kind of very interesting information. And now we are going to the last sequence in this first session, question or comment. Please, for attendance, can you write in the Q&A by writing your name, your institution, and also please mention the panelist name for whom you address your question. And now we already have a question from from Safri Badaruddin. This question is addressed to Professor Ibrahim Jantan. If I use herbal as remedies such as 2 tomatoes plus 3 cloves of garlic plus a glass of plain water, then put them into blender till they really mix and put them into bowl or glass, add pure honey and drink. My question is, what is the advantage of this herbal? That's the question to Professor Ibrahim from Mr. Safri Badaruddin.
Very general question.
Yes.
Remedies for what? Remedies for COVID-19? No, because you need more scientific data. But if you use tomato, garlic, water, so they are food, right? So no problem.
Yeah.
They have beneficial effects. But if you want to use as a health supplement, it's okay. But to treat disease, they need to be supported by scientific reports or information. Otherwise, it's just based on claim. Of course, you ask what's the advantage. They are good because they are food, but don't take anything in excess. You don't take, in fact, you take a lot of water, it's also not good for you, right? So tomato, take in the appropriate amount. They are, of course, beneficial for our health, right? But if you clean, like taking tomato, garlic, and plain water to treat disease, and you need to be supported. And these are health supplements. Health supplements cannot treat disease. Health supplements, they can be used for general health, to make yourself healthy. So that is my answer, my response to this.
Okay, thank you so very much to Professor Ibrahim for your response. And this is also from Mr. Safri to Dr. Maranyo. Dr. Maranyo, are you still there? Hello. Okay, maybe Dr. Maranyo, can you hear my voice? Yeah, let's move to another question from this one Diwasir. This question maybe to Professor Ibrahim and also to Dr. Waranyo. There is a lot of herbal remedies that are believed to cure people from COVID-19. However, these remedies couldn't be distributed to the society before providing that remedies will not give side effects to the consumer. Indeed, this is the strategy to standardize the remedies and keep all society benefits from the side effects. But currently, in this pandemic area, we need the remedies as soon as possible to avoid society for the virus as well. So maybe Professor Ibrahim, could you have an answer how the Malaysian may distribute to the society to those kind of remedies.
Bessie, there's echo in the background. I can't hear you clearly. It's echo. So can I see the Q&A? I can't see it here.
Yes, it's in the answer. There is the question is in the room answer.
Okay. Question from Aristianti. Okay, we know the chloroquine in clinic.
Sorry.
Which one?
It's already.
Okay, let me see.
In the answer column. There is a question from Rizwan.
The last question is from Safri Badarudin.
In the answer column.
In the answer column, can you see the answer column?
Answer column.
Yes, answer column.
Okay.
Yeah.
Answer column.
Here, there is one about how the Malaysia distribute to the society the remedies. Do the remedies should be standardized and prove that they don't have side effects?
Okay, let me read the question, yeah? Is this the one by Rizwandi Wasir?
Yes.
Okay, there are a lot of herbal remedies that are believed to cure people from COVID-19. However, these remedies could not be distributed to the societies before providing that these remedies will not give side effects to the consumer. Indeed, it is the strategy to standardize remedies and keep all societies being safe from the side effects. But currently, this pandemic, we need the remedies as soon as possible to avoid society for the virus as well. So could you explain how the herbal remedies in Thailand, Malaysia be distributed to the societies? Do the remedies also should be standardized and prove that they do not have side effects? Yes, I think so far as I explained in my lecture, my talk just now, there is no herbal extracts or in fact, natural compounds that is being proven, especially clinically, can be used to treat COVID-19. So any claims, especially on herbs, to treat this disease is just based on myths, or just based on claims that's not being proven scientifically. It's not evidence-based. And in Malaysia, it's very important for any herbs or if you're working on natural products or compounds to be used to treat serious disease like COVID-19, you need to provide the preclinical data and of course clinical trials data so that it can be used for society. And the herbal extracts can be used in Malaysia as a health supplement, supplements for minor disease. But if you want to claim it to treat serious disease, you need to have clinical data. You need to provide all the scientific information that prove that these extracts is effective to treat disease, especially COVID-19. No way in Malaysia, as I showed in my slide just now, it's a lot of claims, means about it, saying that in fact ginger or this keto, using keto acid or acid, like alkaline food, all this can be used to treat COVID-19. There's no scientific claims. You just cannot use it to treat disease. Of course, you can use it as help. That's the reason why in my area of research, I'm working on the immunomodulatory effects to look how the compounds and the extract work on the immune system. Because I believe working on the immune system, you really can modulate, it helps the immune system to fight or to battle the virus. Yeah, because in fact, if you look at the vaccine being developed before, the antiviral agents and so on, they are working on the immune system. Yeah, so of course it can have action, but I think to move forward, especially for vaccine development, they are, for example, presented by our friend from Thailand, just working on the protein from natural products to develop into vaccine, antigen, yeah, for the antibodies production by the B cells. So I think you have to be scientific. Anything you say, especially you scientists, you say anything, we have to be at that level, scientific level. You cannot just claim anything and then this is not good for the community. They may be misled or using something that's not effective and they can have adverse effects, side effects to them. Thank you.
Thank you very much, Dr. Professor Ibrahim, for the answer. Maybe Mr. Iswandi, have you get the answer? Okay, we move to, there is a question from Mr. Lukman, which is sent to me. How does the Malaysian government respond to usage of plant medicine for COVID-19?
As I mentioned,
how does the Malaysian government respond to the usage of plant medicine for COVID-19?
As I mentioned just now, there's no way that anybody can claim any herbs or any plants to be used or can be used to treat COVID-19 without clinical data. Or if they want to, due to the emergency use, for example, the antiviral agent, the remdesivir, the chloroquine, that's a emergency use by FDA. But all these are still ongoing. They still need clinical data. In Malaysia, we are following the WHO standard. So any herbs cannot be used or cannot be claimed to be effective against COVID-19 unless they have done enough research, especially at least they can come up with some preclinical data to show effectiveness of these herbs against the virus, and also subject and the time being subject it to clinical trial. And maybe the government, if it's effective, then as what happened in FDA under the Solidarity trial, they can emergency use, allow that to be used. But this I think is not going to happen at the present stage. Thank you.
Thank you, Dr. Prof. Ibrahim. There is one question more to Professor Ibrahim from Christine Manru. She has two questions. The first one is, what is the side effect of consuming the herbal daily while we are taking vitamins?
Vitamin?
Yes.
What
so
vitamin?
She asking about side effect of consuming herbal together, vitamins.
Vitamin? Take it together with vitamin? Vitamin
and herbal.
Oh, vitamin herbal, what is side effect?
Is it have a side effect? That is the first question.
Okay, I'll respond to that first.
And the second, yeah, please.
Can I respond to the first question first?
Yes, please.
I think when you take any herbal preparation, herbal products, I think the most important aspect is the side effects. It has to be safe. Yeah, herbal medicine has not been proven scientifically, most of them. Of course, there are some, for example, in Indonesia, you have this phytopharmaca, a few of them with some clinical data, so they can be used to treat disease. Right? But generally, for herbal medicines, the most important aspect you need to look at is the side effects. They have to be safe. So you're asking me whether there's any side effects you take herbs and vitamin. It depends on the herbs. if the herbs can be toxic, regardless of what vitamin you're taking together. And also herbs, depends on the herbs. If you have some data showing they are safe, some preclinical data on animal study, they are safe, and it has been used as in food, in ulam, for example, for many years, for example, more than 50 years, then most probably you take in low dose with vitamin, I don't think there's any side effects. But you're taking something that is a non-toxicity, yeah, you don't know whether it's toxic or not. You will take in any vitamins, so the risk is there, it may be toxic. So my advice, if you have serious disease like COVID-19, don't go for extracts, herbal extracts, go for the medicine. Ask the pharmacist and medical doctor for advice, and never go for herbal extracts to treat major disease, especially COVID-19. Okay. Second question. Yeah, Dr. Rianti.
The second question, sorry. In Indonesia, people tend to consume jamu, consists of extract from Cinnabrasaceae genus, to increase the immune system. So is it safe for all ages consument? So it's about the age of the consumer. Is it safe?
The age.
Yes.
The age of consumer. Yeah, of course, if you are a pharmacist or you study age of people, it's correlate dose to the dose of the drugs you're taking. So if you are somebody at 60 years old, above 60, elderly people, of course, the dose is different from if you are young, and also for infant, the dose is different. So the dose has to be determined scientifically. You just cannot take herbs extract, for example, same dose for everybody. It has to be determined by some data, scientific data. So herbal extracts, jamu, Indonesia jamu. I think jamu is categorized as product herba terstandard, if I remember. Yeah, herba terstandard. So some of them have shown effects on the immune system. They are immunostimulating, immunosuppressing. So you have to determine whether it stimulates the immune system or inhibit. So if you need to boost your immune system, you need an immunostimulant. Yeah, immunostimulant, as I mentioned in my talk just now, it will stimulate the innate immune system, stimulate the line of defense, yeah, the phagocytes, to kill the virus, kill or remove or get rid of the pathogen, get rid of allergen that's responsible for the effects. And if it's immunosuppressants, it's good as an anti-inflammatory, suppress if your immune system is overactive. So you can use immunosuppressing herbs that can suppress the immune system. But still, I say you need to come up with scientific data. Of course, the traditional use is there. You need to be supported by scientific data. You just cannot take anything. And as I said, when you take any herbs, the safety is the most important. And then go to the efficacy. And then safety plus efficacy is equal to the quality of the herbal product, of the jamu. So don't ever take any extracts, crude extracts or jamu without considering the safety of the medication. Look for the scientific data, scientific information.
Thank you, Professor Ibrahim. There is one more question to Professor Ibrahim coming from Hari Untarto. He asks about have your university or country, Malaysia, found antivirus for COVID-19, especially in herbal medicine?
No.
Can COVID-19 be treated by herbs?
Yes,
Yeah.
I think, okay, as I mentioned, COVID-19, the approach to battle COVID-19, you can treat by antiviral, you can treat by vaccine. Vaccine is preventive. Of course, the best is vaccine. We want to have vaccine so that the immunity, you have the herd community, so already will be immune to the virus. Okay, antiviral agent. And also you, based on my work, you can also use adjunctive preparation to help to assist the antiviral treatment. So for herbal extracts or plants, they are potential source of secondary metabolites, protein, to be used as antiviral and also as a vaccine. But at present moment, the disease is new, the virus has just been identified. I think it takes long time. In the future, somebody may come up with an antiviral agent from plants, especially from the tropical rainforest, because of the rich biodiversity. I just hope. But present moment, there's no herbs in Malaysia being claimed or being scientifically proven to be effective against COVID-19. If somebody claim, then they are against the Advertisement Act in Malaysia, so they can be punished without providing with the scientific information. So it cannot be done in Malaysia at this moment to claim any herbs can be used to treat COVID-19. Thank you.
Okay, thank you, Prof. Ibrahim. There is so many questions to Professor Ibrahim. There is also still have two questions coming from anonyms and also from Rudy Safarudin from Virginia, USA. So I will choose the question from Rudy Safarudin first. Quick question for Dr. Ibrahim Jantan. Based on your presentation, there is evidence of the plants mentioned in your slide containing compounds that might help alleviate the viral infection through the immune-related pathway. So hypothetically, if the action mechanism of those compounds prevail well in human, will it produce the same effect if we process the herb using regular traditional method? In this case, water as the solvent, as I believe the research conducted in the whole medicinal investigation utilized involve various type of solvent like acetone, ethanol, etc. So can you get the question, Prof. Ibrahim?
Yeah, based on our work, more work need to be done because we, as I said in my slide just now, future work. Because COVID-19 is new. When we did the work, there's no SARS-CoV-2 yet. So nobody know about this virus. So our work are mainly using the normal cell or cancer cells. We have not used the disease model. Yeah. So I think if you want to prove it's effective at the in vitro level, in vivo level, for the in vitro, we need to use cells that infected by the virus, coronavirus. For the animal models, also animal models disease and with the virus, we infected the virus. Then you want to see the effects of the plant on the immune system of this animal model or this cell. That will be the future work, to see how effective is it. And the reason why we use 80% ethanol, because these are the common solvents we use in industry. Of course, you can use aqueous extract, but if you use aqueous extract, you may only manage to extract the polar compounds. Yeah, polar compounds. You can isolate the non-polar compounds, which may also contribute to the activity. Because in traditional medicine, most of the preparations are using water extracts. I agree to that. But moving forward, I think doing scientific work, you need to identify the chemical markers, the compound responsible for activity. You may miss some of the non-polar compounds if you use just water extract. Using 80%, now you have the non-polar and polar compound in the extract, right? Then you can do the isolation, say guided isolation. You can identify which are the compound responsible for the activity. Yeah, thank you.
Thank you very much. Do you still should continue to answer the question, Prof. Ibrahim?
Yeah, okay.
Okay.
No
There is
problem.
from anonymous attendees. I would like to ask Professor Ibrahim Jantan, thank you very much. Very nice presentation. We have studied Pilantin, isolated from Pilantus amarus as inhibitor in silico and in vitro. The results are very good and have potential as S inhibitor. It's already published. The question is whether the same mechanism act in the S2. Please your opinion. Thank you.
Okay.
Yeah, that's the question from.
This is hypothesis, right?
Yeah.
I believe the compound, the Pilantin, will work on the same pathway, same mechanisms on the. If you use animal model, you use infected with the COVID virus or coronavirus, and also on an in vitro model using cells infected with virus. I think the mechanism action is still the same, but of course it need to be proven. That's my hypothesis. I'm very confident that, very optimistic that Pilantin will work with cells or animal models infected with the coronavirus. Thank you.
Okay, thank you very much. There is a question also to Mrs. Dr. Waranyo. However, now Dr. Waranyo already disconnected with us, so we couldn't get her answer. So we continue to one more question to Professor Ibrahim. This is in Indonesia. Is it okay to read in Indonesia?
Yeah, I can speak Indonesia, bahasa Indonesia, Bu.
Okay.
Ada masalah.
Herbal manakah yang lebih bagus untuk melawan COVID-19 dari 3 tanaman di Malaysia yang dipresentasikan dari Agus?
Okay. Tadi daripada data yang saya present tadi, my research output, I work on Philanthus amarus, ataupun kalau di Malaysia dipanggil dukung anak. Indonesia saya rasa ada Philanthus tapi lebih Philanthus neurori. You have product immunostimulant di pasaran. And I work on Zigimba Zurumbet, itu sejenis alia. And then on Dinospora crispa, ini dipanggil pokok, saya lupa. Tapi all this extracts menunjukkan data-data yang, because saya telah jalankan kajian ke atas banyak tumbuhan. Dan di antara tumbuhan saya kaji, 3 ini yang menunjukkan kesan yang paling kuat, strong effect on the immune system. My work is, as I said, banyak kali saya kata tadi, I was working on normal cell yang tidak terinfeksi oleh COVID-19 lagi. So, pertanyaan sama ada 3 of them, ketiga ini sama efektif COVID-19, perlu dibuktikan melalui kajian selanjutnya. And it depends, tadi Dinospora crispa, immunostimulant, ya. Ini digunakan awal sebagai pendinding, protection, first line of defense. Jadi kalau mau boost the immune system atau meningkatkan ketahanan badan, Dinospora crispa boleh digunakan untuk prevent virus, because virus, for example COVID-19 virus, so the body has a boosted immune system, jadi kuat untuk menghalang virus. Tapi kalau yang immunosuppressant, ada anti-inflammatory property itu yang saya sebut tadi. This is effective pada stage 3, the third stage of the COVID-19, because it's cytokine storm. So if you have immunosuppressants or any extract atau extract yang boleh merencat inflamasi, so dia ada potensi untuk menghalang the cytokine storm, which is responsible for the inflammation semasa stage 3 of the COVID-19. Okay, thank you.
Okay, thank you very much, Professor Ibrahim. That is the last question to Prof. I think because of we couldn't so I think it's enough for this discussion session, and now we come to the end of this session. Thank you very much to the invited speaker who already answered to all questions that asked today. We hope all attendees' question is clear, and if you still have questions that not yet get answered, you can contact them directly. Finally, we come to the last sequence of this seminar. Once again, on behalf of the head of STIFA Makassar and all organizing committee, appreciate to invite all invited speakers in this session and all attendees for your participation. Hopefully, the information that we have shared today would be beneficial for all of us. Thank you for your attention. Wassalamualaikum warahmatullahi wabarakatuh. And for the host, I am
Okay, thank you very much, Mrs. Bese Hardianti. Ladies and gentlemen, before we close session 1, we would like to invite speakers, moderator, committee, and several participants that are Dr. Syahruddin Kasim, Dr. Wahyu Hendrarti, Mr. Ismail Tondra, and Mr. Imam Surya Pratama to have photo session. So that I invite those all to turn on camera, please.
datang di Sekolah Tinggi Ilmu Farmasi Makassar. Bersama saya, yuk kenali kampus kita. Hai. Saat ini kita berada di ruang administrasi. STIFA Makassar juga dilengkapi dengan beragam fasilitas. Yuk! Untuk mencari referensi dan menggali informasi, saya selalu ke perpustakaan ini.
In this library, we can read books to expand our knowledge, informasi, or others.
STIFA Makassar juga dilengkapi dengan apotek simulasi.
With this facility, students have a chance to improve their skill in pharmaceutical practice.
Nah, saat ini kita berada di ruang CBC.
STIFA Makassar also have a computer-based test room.
Untuk pengembangan riset dalam penemuan obat baru juga ditunjang dengan fasilitas ini.
We also facilitated by this laboratory to support our experiment and various of drug research and invention.
Berbagai prestasi berhasil diraih oleh STIFA Makassar. Sebanyak 25 proposal PKM berhasil didanai oleh Ristekdikti dan meloloskan 3 PKM di ajang Pekan Ilmiah Nasional, serta berhasil memperoleh gold and silver medal pada ajang International Young Scientist Association di Malaysia, dan beragam prestasi lainnya. Nah, bagaimana? Segera bergabung bersama kami di STIFA Makassar. STIFA Makassar mengedepankan knowledge, skill, and character. Selamat datang di Sekolah Tinggi Ilmu Farmasi Makassar. Bersama saya, yuk kenali kampus kita. Hai. Saat ini kita berada di ruang administrasi. STIFA Makassar juga dilengkapi dengan beragam fasilitas. Yuk! Untuk mencari referensi dan menggali informasi, saya selalu ke perpustakaan ini.
In this library, we can read books to expand our knowledge, informasi, or others.
STIFA Makassar juga dilengkapi dengan apotek simulasi.
With this facility, students have a chance to improve their skill in pharmaceutical practice.
Nah, saat ini kita berada di ruang CBC.
STIFA Makassar also have a computer-based test room.
Untuk pengembangan riset dalam penemuan obat baru juga ditunjang dengan fasilitas ini.
We also facilitated by this laboratory to support our experiment and various of drug research and invention.
Berbagai prestasi berhasil diraih oleh STIFA Makassar. Sebanyak 25 proposal PKM berhasil didanai oleh Ristekdikti dan meloloskan 3 PKM di ajang Pekan Ilmiah Nasional, serta berhasil memperoleh gold and silver medal pada ajang International Young Scientist Association di Malaysia, dan beragam prestasi lainnya. Nah, bagaimana? segera bergabung bersama kami di STIFA Makassar. STIFA Makassar mengedepankan knowledge, skill, and character. Selamat datang di Sekolah Tinggi Ilmu Farmasi Makassar. Bersama saya, yuk kenali kampus kita. Hai. Saat ini kita berada di ruang administrasi. STIFA Makassar juga dilengkapi dengan beragam fasilitas. Yuk! Untuk mencari referensi dan menggali informasi, saya selalu ke perpustakaan ini.
In this library, we can read books to expand our knowledge, informasi, or others.
STIFA Makassar juga dilengkapi dengan apotek simulasi.
With this facility, students have a chance to improve their skill in pharmaceutical practice.
Nah, saat ini kita berada di ruang CBC.
STIFA Makassar also have a computer-based test room.
Untuk pengembangan riset dalam penemuan obat baru juga ditunjang dengan fasilitas ini.
We also facilitated by this laboratory to support our experiment and various of drug research and invention.
Berbagai prestasi berhasil diraih oleh STIFA Makassar. Sebanyak 25 proposal PKM berhasil didanai oleh Ristekdikti dan meloloskan 3 PKM di ajang Pekan Ilmiah Nasional, serta berhasil memperoleh gold and silver medal pada ajang International Young Scientist Association di Malaysia, dan beragam prestasi lainnya. Nah, bagaimana? Segera bergabung bersama kami di STIFA Makassar. STIFA Makassar mengedepankan knowledge, skill, and character. datang di Sekolah Tinggi Ilmu Farmasi Makassar. Bersama saya, yuk kenali kampus kita. Hai. Saat ini kita berada di ruang administrasi. STIFA Makassar juga dilengkapi dengan beragam fasilitas. Yuk! Untuk mencari referensi dan menggali informasi, saya selalu ke perpustakaan ini.
In this library, we can read books to expand our knowledge, information, or others.
STIFA Makassar juga dilengkapi dengan apotek simulasi.
With this facility, students have a chance to improve their skill in pharmaceutical practice.
Nah, saat ini kita berada di ruang CBC.
STIFA Makassar also have a computer-based test room.
Untuk pengembangan riset dalam penemuan obat baru juga ditunjang dengan fasilitas ini.
We also facilitated by this laboratory to support our experiment and various of drug research and invention.
Berbagai prestasi berhasil diraih oleh STIFA Makassar. Sebanyak 25 proposal PKM berhasil didanai oleh Ristekdikti dan meloloskan 3 PKM di ajang Pekan Ilmiah Nasional, serta berhasil memperoleh gold and silver medal pada ajang International Young Scientist Association di Malaysia, dan beragam prestasi lainnya. Nah, bagaimana? Segera bergabung bersama kami di STIFA Makassar. STIFA Makassar mengedepankan knowledge, skill, and character. Selamat datang di Sekolah Tinggi Ilmu Farmasi Makassar. Bersama saya, yuk kenali kampus kita. Hai. Saat ini kita berada di ruang administrasi. STIFA Makassar juga dilengkapi dengan beragam fasilitas. Yuk! Untuk mencari referensi dan menggali informasi, saya selalu ke perpustakaan ini.
In this library, we can read books to expand our knowledge, information, or others.
STIFA Makassar juga dilengkapi dengan apotek simulasi.
With this facility, students have a chance to improve their skill in pharmaceutical practice.
Nah, saat ini kita berada di ruang CBC.
STIFA Makassar also have a computer-based test room.
Untuk pengembangan riset dalam penemuan obat baru juga ditunjang dengan fasilitas ini.
We also facilitated by this laboratory to support our experiment and various of drug research and invention.
Berbagai prestasi berhasil diraih oleh STIFA Makassar. Sebanyak 25 proposal PKM berhasil didanai oleh Ristekdikti dan meloloskan 3 PKM di ajang Pekan Ilmiah Nasional, serta berhasil memperoleh gold and silver medal pada ajang International Young Scientist Association di Malaysia, dan beragam prestasi lainnya. Nah, bagaimana? segera bergabung bersama kami di STIFA Makassar. STIFA Makassar mengedepankan knowledge, skill, and character. Selamat datang di Sekolah Tinggi Ilmu Farmasi Makassar. Bersama saya, yuk kenali kampus kita. Hai. Saat ini kita berada di ruang administrasi. STIFA Makassar juga dilengkapi dengan beragam fasilitas. Yuk! Untuk mencari referensi dan menggali informasi, saya selalu ke perpustakaan ini.
In this library, we can read books to expand our knowledge, informasi, or others.
STIFA Makassar juga dilengkapi dengan apotek simulasi.
With this facility, students have a chance to improve their skill in pharmaceutical practice.
Nah, saat ini kita berada di ruang CBC.
STIFA Makassar also have a computer-based test room.
Untuk pengembangan riset dalam penemuan obat baru juga ditunjang dengan fasilitas ini.
We also facilitated by this laboratory to support our experiment and various of drug research and invention.
Berbagai prestasi berhasil diraih oleh STIFA Makassar. Sebanyak 25 proposal PKM berhasil didanai oleh Ristekdikti dan meloloskan 3 PKM di ajang Pekan Ilmiah Nasional, serta berhasil memperoleh gold and silver medal pada ajang International Young Scientist Association di Malaysia, dan beragam prestasi lainnya. Nah, bagaimana? Segera bergabung bersama kami di STIFA Makassar. STIFA Makassar mengedepankan knowledge, skill, and character. Ilmu Farmasi Makassar. Bersama saya, yuk kenali kampus kita. Saat ini kita berada di ruang administrasi. STIFA Makassar juga dilengkapi dengan beragam fasilitas. Yuk! Untuk mencari referensi dan menggali informasi, saya selalu ke perpustakaan ini.
In this library, we can read books to expand our knowledge, informasi, or others.
STIFA Makassar juga dilengkapi dengan apotek simulasi.
With this facility, students have a chance to improve their skill in pharmaceutical practice.
Nah, saat ini kita berada di ruang CBT.
STIFA Makassar also have a computer-based test room.
Untuk pengembangan riset dalam penemuan obat baru juga ditunjang dengan fasilitas ini.
We also facilitated by this laboratory to support our experiment and various of drug research and invention.
Berbagai prestasi berhasil diraih oleh STIFA Makassar. Sebanyak 25 proposal PKM berhasil didanai oleh Ristekdikti dan meloloskan 3 PKM di ajang Pekan Ilmiah Nasional, serta berhasil memperoleh gold and silver medal pada ajang International Young Scientist Association di Malaysia, dan beragam prestasi lainnya. Nah, bagaimana? Segera bergabung bersama kami di STIFA Makassar. STIFA Makassar mengedepankan knowledge, skill, and character. Selamat datang di Sekolah Tinggi Ilmu Farmasi Makassar. Bersama saya, yuk kenali kampus kita. Saat ini kita berada di ruang administrasi. STIFA Makassar juga dilengkapi dengan beragam fasilitas. Yuk! Untuk mencari referensi dan menggali informasi, saya selalu ke perpustakaan ini.
In this library, we can read books to expand our knowledge, informasi, or others.
STIFA Makassar juga dilengkapi dengan apotek simulasi.
With this facility, students have a chance to improve their skill in pharmaceutical practice.
Nah, saat ini kita berada di ruang CBT.
STIFA Makassar also have a computer-based test room.
Untuk pengembangan riset dalam penemuan obat baru juga ditunjang dengan fasilitas ini.
We also facilitated by this laboratory to support our experiment and various of drug research and invention.
Berbagai prestasi berhasil diraih oleh STIFA Makassar. Sebanyak 25 proposal PKM berhasil didanai oleh Ristekdikti dan meloloskan 3 PKM di ajang Pekan Ilmiah Nasional, serta berhasil memperoleh gold and silver medal pada ajang International Young Scientist Association di Malaysia, dan beragam prestasi lainnya. Nah, bagaimana? segera bergabung bersama kami di STIFA Makassar. STIFA Makassar mengedepankan knowledge, skill, and character. Selamat datang di Sekolah Tinggi Ilmu Farmasi Makassar. Bersama saya, yuk kenali kampus kita. Hai. Saat ini kita berada di ruang administrasi. STIFA Makassar juga dilengkapi dengan beragam fasilitas. Yuk! Untuk mencari referensi dan menggali informasi, saya selalu ke perpustakaan ini.
In this library, we can read books to expand our knowledge, informasi, or others.
STIFA Makassar juga dilengkapi dengan apotek simulasi.
With this facility, students have a chance to improve their skill in pharmaceutical practice.
Nah, saat ini kita berada di ruang CBC.
STIFA Makassar also have a computer-based test room.
Untuk pengembangan riset dalam penemuan obat baru juga ditunjang dengan fasilitas ini.
We also facilitated by this laboratory to support our experiment and various of drug research and invention.
Berbagai prestasi berhasil diraih oleh STIFA Makassar. Sebanyak 25 proposal PKM berhasil didanai oleh Ristekdikti dan meloloskan 3 PKM di ajang Pekan Ilmiah Nasional, serta berhasil memperoleh gold and silver medal pada ajang International Young Scientist Association di Malaysia, dan beragam prestasi lainnya. Nah, bagaimana? Segera bergabung bersama kami di STIFA Makassar. STIFA Makassar mengedepankan knowledge, skill, and character. di Sekolah Tinggi Ilmu Farmasi Makassar. Bersama saya, yuk kenali kampus kita. Hai. Saat ini kita berada di ruang administrasi. STIFA Makassar juga dilengkapi dengan beragam fasilitas. Yuk! Untuk mencari referensi dan menggali informasi, saya selalu ke perpustakaan ini.
In this library, we can read books to expand our knowledge, informasi, or others.
STIFA Makassar juga dilengkapi dengan apotek simulasi.
With this facility, students have a chance to improve their skill in pharmaceutical practice.
Nah, saat ini kita berada di ruang CBC.
STIFA Makassar also have a computer-based test room.
Untuk pengembangan riset dalam penemuan obat baru juga ditunjang dengan fasilitas ini.
We also facilitated by this laboratory to support our experiment and various of drug research and invention.
Berbagai prestasi berhasil diraih oleh STIFA Makassar. Sebanyak 25 proposal PKM berhasil didanai oleh Ristekdikti dan meloloskan 3 PKM di ajang Pekan Ilmiah Nasional, serta berhasil memperoleh gold and silver medal pada ajang International Young Scientist Association di Malaysia, dan beragam prestasi lainnya. Nah, bagaimana? Segera bergabung bersama kami di STIFA Makassar. STIFA Makassar mengedepankan knowledge, skill, and character. Selamat datang di Sekolah Tinggi Ilmu Farmasi Makassar. Bersama saya, yuk kenali kampus kita. Hai. Saat ini kita berada di ruang administrasi. STIFA Makassar juga dilengkapi dengan beragam fasilitas. Yuk! Untuk mencari referensi dan menggali informasi, saya selalu ke perpustakaan ini.
In this library, we can read books to expand our knowledge, informasi, or others.
STIFA Makassar juga dilengkapi dengan apotek simulasi.
With this facility, students have a chance to improve their skill in pharmaceutical practice.
Nah, saat ini kita berada di ruang CBC.
STIFA Makassar also have a computer-based test room.
Untuk pengembangan riset dalam penemuan obat baru juga ditunjang dengan fasilitas ini.
We also facilitated by this laboratory to support our experiment and various of drug research and invention.
Berbagai prestasi berhasil diraih oleh STIFA Makassar. Sebanyak 25 proposal PKM berhasil didanai oleh Ristekdikti dan meloloskan 3 PKM di ajang Pekan Ilmiah Nasional, serta berhasil memperoleh gold and silver medal pada ajang International Young Scientist Association di Malaysia, dan beragam prestasi lainnya. Nah, bagaimana? segera bergabung bersama kami di STIFA Makassar. STIFA Makassar mengedepankan knowledge, skill, and character. Selamat datang di Sekolah Tinggi Ilmu Farmasi Makassar. Bersama saya, yuk kenali kampus kita. Hai. Saat ini kita berada di ruang administrasi. STIFA Makassar juga dilengkapi dengan beragam fasilitas. Yuk! Untuk mencari referensi dan menggali informasi, saya selalu ke perpustakaan ini.
In this library, we can read books to expand our knowledge, informasi, or others.
STIFA Makassar juga dilengkapi dengan apotek simulasi.
With this facility, students have a chance to improve their skill in pharmaceutical practice.
Nah, saat ini kita berada di ruang CBC.
STIFA Makassar also have a computer-based test room.
Okay, ladies and gentlemen, thank you very much for keep staying in this seminar. Now let us proceed to session 2. This session will be delivered by two our honorable speakers that are Professor Dr. Suwijio Pramono, PEA Apotheker, and Abdul Halim Umar, SPAR Master Science. This session will be led. by Reni Syahroni as Farm Master Science. For information, Mrs. Reni Syahroni got her master degree from Gajah Mada University, Indonesia. She also had joined short course of health in Taiwan. Ladies and gentlemen, I'm now pleased to invite our moderator. Please welcome Reni Syahroni.
Okay, thanks Mrs. Maria. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. And good afternoon to all honorable attendees. Hope you all still excited to watch this lesson seminar until the end. Okay, for continuing the seminar today with the theme of herbal remedies for COVID-19 treatment, state of the art and perspective, it is my pleasure to lead this second session as a moderator until the discussion session ends later. On this occasion, we are honored to invite two competent speakers who have joined with us virtually. Okay, Assalamualaikum to Professor Dr. Apoteker Suwijio Pramono DIE and Mr. Abdul Halim Umar S.Farm MSc.
Waalaikumsalam, Ibu.
Waalaikumsalam. But the video is not coming because my video, okay? Yeah, not yet. Okay, yes. Okay, you hear my speed? Yeah, you hear my voice? You can hear? No,
yes,
not yet.
We can hear. So,
okay.
Okay, we can hear.
Ya, Assalamualaikum, Prof.
Yes. Waalaikumsalam warahmatullahi wabarakatuh.
Mr. Halim, are you there?
Yes, waalaikumsalam.
Okay. Good to see you both. Okay, all respected participants, both speakers have been here with us. So now we are ready to start the presentation. This session will begin with presentation for around 40 minutes to each presenters. And after that, we will discuss with two presenters. Okay, for the first presentation, it will be presented by Professor Dr. Apoteker Suwijio Pramono DIE. Before we start the first presentation, allow me to read the brief CVs of the first speaker. Professor Dr. Apoteker Suwijio Pramono DIE was born in Purworejo on November 20, 1952. In 1977, he completed his studies at Bachelor degree of Faculty of Pharmacy, Gajah Mada University, and obtained his pharmacist degree or apotheker a year after that at the same faculty. He continued his study at the master and doctoral levels until completion in 1982 from Université Paul Sabatier, Toulouse, France. I hope I'm not mistaken in. There are some of his professional activities that are, he have been a lecturer of the Faculty of Pharmacy Gajah Mada University since 1977 until now. He became a visiting professor at Institute of Natural Medicine, University of Toyama, Japan, on April 2006 until March 2007. And as a member of National Committee for evaluation of traditional medicine and health supplements for the National Agency for Drug and Food Control, Republic of Indonesia, in 1986 until now, as a chairman of division of the National Working Group on Indonesian Medicinal Plan, or POCJA TOOT 1991 until now, as a member of the WHO Expert Advisory Panel on Traditional Medicine Program since 1991 until now. And then as a co-chairman of Asian Traditional Medicine and Health Supplements Scientific Committee, or IPSC of ICCSQ PWG on Traditional Medicine and Health Supplement in 2007 until 2013, and he has been appointed as a chairman since 2013 until now. Next, as a chairperson on pharmaceutical legislation, regulatory science, and pharmacopoeia of Federation of Asian Pharmacists Association, or FAFA, 2014 until 2018. And he once joined National Focal Point for International Center for Science and High Technologies, ICS, and United Nations Industrial Development Organization, UNIDO, in 2008 until 2014. In addition, he has also been experienced as an editor, scientific committee, and other in various seminar proceedings, monographs, book publishment, and presented paper. He also collaborated with several researchers in various publications in various international journal indexes Scopus, which focus on research and development of natural ingredients or herbal medicine, especially to Andrographis paniculata and the other certain plants. Okay, in this seminar, Professor Dr. Apotheker Suwijio Pramono DE will present the topic about potency of Indonesian herbal medicine in therapy of COVID-19. Now, would you please welcome our first speaker, Professor Dr. Apotheker Suwijio Pramono DE. Please take your time, and to remind the time that you have for presentation is maximum 40 minutes.
Okay, thank you very much for your nice introduction. Assalamualaikum warahmatullahi wabarakatuh. I'd like to thanks to the organizing committee to invite me to share what kind of the talk today. I want to share with you the potency of Indonesian herbal medicine in therapy of COVID-19. So I can look at now the background of you know, this is the recent publication in Europe, complementary therapies in clinical practice. This is Elsevier recently, and it is stated that there is no effective treatment for COVID-19 until now as antiviral. So this is the statement of Chinese researchers. However, during the treatment of COVID-19 in China, we found that the intervention of traditional Chinese medicine can reduce the severe symptoms of patients. So traditional Chinese medicine is not antiviral, but it supports the therapy in curing the symptoms of COVID-19 infection. If we look at supporting therapy, so we can look at the immunostimulants, antioxidant, anti-inflammatory, and the three of the kind of activity is close related between one and other. And then expectorant, or it is better we call mucolytic, and also hepatoprotector, and of course, if there is antiviral, but it need evidence base. It need evidence base. So if we look at the evidence base level of result of the research, the first one is empirical data. Second one, in silico or computational of chemical structure, in vitro in cells, enzyme or in virus, in vivo in animals, and also if there is a case study or clinical observational, and then randomized clinical trial. And the last one, which is the very, very validity level, is multi-center RCTI, randomized clinical trial. So, about the immunostimulant, what kind of herbal we can look at as a potency to develop, to cure, not as antiviral, but for supporting therapy. The first one is herbal, a source of vitamins and mineral. We can mention here vitamin C, vitamin D, vitamin E, zinc, selenium, and provitamin A. If we use natural resources of this vitamin, natural resources, we call herbal. For example, if we use Psidium guajava fruit, for example, in Indonesia it is called jambu biji. Yeah? This is a herbal. But if we use pure compounds, vitamin C, vitamin D, vitamin E, so we call health supplement. But I don't want to focus in this vitamin as immunostimulant because usually it is antioxidant. Yeah? But I want to focus as asked from the organizing committee about the herbal containing active chemical substance or active chemical constituent. If we look at the single plant material, we can mention Curcuma santorisa or temulawak, Curcuma domestica, kunyit, Phyllanthus niruri, and the Professor Ibrahim Jantan talked about Phyllanthus amarus. We have Phyllanthus niruri, and then Andrographolis paniculata or sambiloto, Psidium guajava, jambu biji, Morinda citrifolia, nonifruit, and also gel of aloe vera. Or we can use a mixture of plant material. We know in Tawangmangu, in the central of Java, we have the polyclinic of jamu, special to cure patient with jamu. And one of the jamu is for immunostimulant. And then we also look at the possibility to use topical and inhaler products. We look at now the first plant material, Curcuma santorisa. This is the plant material, and it contains curcumin, dismethoxycurcumin, and essential oil with the main constituent is santorisol, and also we found polyphenol. As immunostimulant, so I don't want to look at the in vitro and in silico. I better look at the research on in vivo on rats treated with the diet 2% of curcuma, I mean the temulawak itself, in powder form, yeah, in feed, so mixed with the food of the rats during 3 to 5 weeks. It is significantly have the immunostimulant activity. And then, of course, antioxidants. in FIFO in the rats, so but especially in FIFO dose 500 milligram per kilogram body weight in hepatotoxic rats induced by CCL4, it is very good antioxidant. And then anti-inflammatory in FIFO on carrageenan-induced edema mice food also significantly produce the anti-inflammatory. And then the last one, the important one for temulawak is it has hepatoprotective effect. We have our research in FIFO in paracetamol-induced rats and really very, very significant result. And it is very important. Why? Because if we look at the therapy of COVID-19 right now, usually with antibiotic, rendesivir, etc., chloroquine, etc. So usually the antibiotic also have to be metabolized by the liver. So usually in the hospital who care with the COVID-19 usually also check the SGPT and SGUT of the patient. So the hepatoprotective here is very important because the consumption of the antibiotic can attack the liver. So this is supporting therapy. This is temulawak. And usually, empirically, people use first one with the decoction, or in Indonesia it is called rebusan. But also, we can simplify, the temulawak is after peel and then slice, not with the, make the decoction, but just only after slicing this, and then we can put the boiled water, and after 5 minutes, we can take this kind of remedy to cure us supporting therapy for also for COVID-19, but the important thing one is to inhibit the attack of the liver from the antibiotic. This is the first one, temulawak. And then the second one is turmeric or curcuma domestica. In Indonesian languages, it is called kunyit or kunir. This is the plant material. It contains curcumin, desmethoxycurcumin, and bis-desmethoxycurcumin. And the essential oil with the artemisinin as main compound. We look at the in vivo test. Yes, it is significantly has immunostimulant in vivo on mice. And then antioxidant in vivo on hepatotoxic rats. Anti-inflammatory, it is very famous, curcuma domestica in vivo on rats. And this is a note. In small dose, the curcuma domestica can reduce mark or ulcer. But in the big dose, oppositely, can increase the ulcer. In Indonesia, we know there is a preparation, it is called kunir asam, turmeric and tamarind. It is well known, especially in Java. It reduces pain during menstruation. This is the potency of Curcuma domestica. We look at now about the changer, Singaber officinale. The plant material, we know there are three of changer. The big one, the big changer, or in Indonesian language is Jai Gajah, and then the small one, Jai Emprit, and then red ginger. The pungent principle, zat pedas, in Indonesian language is zat pedas, the pungent principle is quantitatively bigger than the two other ginger, but the components are similar, gingerol, etc. Whilst the component of essential oils are totally different, totally different. So we just look at the GCMS of these three kind of ginger. The Singaber, the red ginger has essential oil, which is totally different, the component in comparison to these two ginger. So we can look at now result of the in vivo test. The immunostimulant of ginger with the essential, the researcher used essential oil in cyclophosphamide-induced mice by increasing humoral immune response to produce antibody. So this is in vivo. And also as anti-inflammatory, ginger extract 2000 milligram per kilogram body weight reduce inflammatory agent. Clinical study of 3 gram ginger powder per day also reduce inflammatory agent. So this is a clinical study. And as anti-nausea, we have a lot of publication, RCT clinical study, randomized clinical trial study. And also, we know that ginger can warm the body and also perspiration. In Indonesian language, peluruh keringat. This is important for the someone if, for example, have the COVID-19 because the temperature high, we can reduce the temperature by the the stimulate the perspiration. But we have to look at the possibility of negative side effect. Those 6 gram of dried ginger can irritate abdomen and intestinal mucus. So this is perhaps we can have attention about this. Dose of 6 gram dried ginger. This is about the ginger, or Singiber officinale. And now, this is Phyllanthus neruri. The plant similarly, or perhaps like the amarus, Phyllanthus amarus in Malaysia, but we have Phyllanthus neruri. The chemical constituents are phyllanthine, hypophyllantine, etc. is a lignan, but also there is a flavonoid, camphorol, and its glucoside. But in Phyllanthus amarus, not flavonoid, but phenolic acid. But the phyllanthine, hypophyllantine is the same. About the in vivo test of the Phyllanthus neruri, it has immunostimulant of the water extract, 50 milligrams increase the effectivity of standard therapy for TBC patients. So there is a clinical trial for tuberculosis can increase the effectivity of standard therapy. And then antioxidant in vivo on nimesulide-induced mice, it is also significantly show the antioxidant activity. And the Philanti herba inhibits CYP, cytochrome P45. So it can influence bioavailability of other drugs, including insulin and also oral antidiabetes. So we have to make attention about this herbal because it can influence the bioavailability of other drugs. And then we also find the research on hepatoprotective paracetamol-induced mice. This is Philanthus niruri, and we have some of the product on the market about the Philanthus niruri. But also Philanthus niruri has diuretic effect. This is other activity of Philanthus niruri. Well, we continue now about the Andrographis paniculata, Sambiloto or Sandiloto. It is means because the taste is very bitter. It is called also king of bitter, Sambiloto or Andrographis paniculata. The main constituent is diterpenlactone, mainly andrographolide and deoxyandrographolide. I'm sorry, this is still in Indonesian language. And also, we found flavonoid polymethoxy. About the in vivo test, immunostimulant, the extract, hexanic extract, 2.7 milligram per mice has the immunostimulant in hepatitis B vaccine-induced mice. So the mice is induced by the vaccine of hepatitis and then give the Sambiloto or hexanic extract of Andrographis paniculata. You know that the diterpenlactone, andrographolate, and deoxyandrographolate is non-polar substances. So it can be extracted by the non-polar solvent. The clinical trial on patients with upper respiratory tract infection, patient reduced the symptom 2.1 times better than placebo. This is a clinical trial. And the antioxidant and anti-inflammatory, unfortunately, were not significant effect. Now we look at the Psidium guayava. It contains good amount of vitamin C and also pro-vitamin A. It contains also iron, phosphor, and calcium, and flavonoid, myricetin, quercetin, abigenin, and also anthocyanin. And also we found phenolic acids, ellagic acid, and kochic acid. The in vivo test result, antioxidant, firstly, due to high content of vitamin C and flavonoids. The anti-inflammatory dose 9 gram per 15 milliliters influence chronic histology parameter of the animal. And the flavonoid content are also important for inhibit fragility of blood capillary. This is a fruit of Psidium guayava. We also use the leaf of Psidium guayava, but now we prefer to take the fruit as herbal, contain vitamin C, vitamin A, iron, flavonoid, etc. The next one is Morinda citrifolia or noni. Yeah? This morning there is someone to ask about noni. We can look at the empirical dose as juice of one mature fruit one time a day. We look at the activity in vivo immunostimulant, and the active constituent is polysaccharide, so polar compound. But in this kind of fruit, there is anthraquinone, it is called morindon, with the laxative effect, so laxantia. And it contains also scopolamine, which act as hypotensive agent. And then the seronin is alkaloid as hypoglycemic. Unfortunately, the taste is rather acid and the smell is unique. Perhaps not all people like the smell. But this is Morinda citrifolia. And now, my last talk is about the very, very popular thing in this moment. It's about Eucalyptus globulus. We look at that this essential oil in silico, I mean computational approach, yeah, 1,8-cineol had potency as antivirus. The essential oil also is proven as antivirus in vitro, virus, but not in virus of COVID-19, other virus. And also, the essential oils has mucolytic activity. This is important for curing the COVID-19. The essential oils, unfortunately, has the activity which is not really convenient for us. It can irritate the mucus. So it is not recommended to be taken orally. Use as topical preparation and as inhaler. So topical and inhalation. And about the kalung of Eucalyptus globulus, it has to be proven clinically as antiviral because we know that the kalung of Eucalyptus globulus also contain the extract of this plant, and the Department of Agriculture next month will produce this kind of remedy, so we can look at it. But if it is claimed to be a remedy or to be a drug, to be something to cure, it has been proven clinically. If not, no. And I'm happy that Department of Agriculture say that the Eucalyptus globulus, the essential oils, not to cure, but to inhibit, to protect from the infection of COVID-19. So I'm happy now, and as I am a expert of the BPOM in Jakarta, I know that the researchers asked to the BPOM how to continue the research, and then BPOM gave some, how, the method how to continue the research until clinical trial. So I think what I have material to talk is enough for herbal. So the last PowerPoint of mine is about research recommended for herbals. The first one, continue the antiviral via docking, and then proven by in vitro. And because we have difficulties to test in pharmacodynamic in animal, because it is not really easy to give infection to the animal. So we can look at now to the pharmacokinetic in vivo, to look at how the metabolism of the substances in the body. I mean, in the animal first. And then the last one, we can do on top clinical trial. What does it mean on top? It means that because it is a supporting therapy, we have to add to the standard therapy in the hospital to cure the COVID-19. So it is not allowed to cure COVID-19 only by the herbal. Still with standard therapy, ritonavir, chloroquine, etc., 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 and then we can add the supporting therapy. And then the second one, optimization of immunostimulant effect in order to isolate the active chemical constituent and create product based on active fraction. It means it is not necessary to produce isolated substances because it is, of course, very, very expensive. We can use the fraction, not only extract, because usually the extract is not really have strong enough the activity. But if we use fraction, active fraction, and it is really good for the development of the supporting therapy. And the third one, optimization of mucolytic effect as supporting therapy for COVID-19. And the last one, of course, as I mentioned, the optimization of hepatoprotective effects as supporting therapy of COVID-19. This is the priority research for herbals as supporting therapy, not as antivirus, but as supporting therapy. Immunostimulant, mucolytic effect, hepatoprotector, antioxidant, and anti-inflammatory. So this is my talk. Thank you very much for your kind attention. I beg to the moderator.
Thank you for the informative and interesting presentation, Prof.
it is okay. Is it okay for you to wait for a while, Prof? Because we will
Okay.
continue to the next presentation.
Yeah, no problem.
Okay, thank you. Okay, for once again, participant, we remind to who want to ask that you can write down your question on Zoom Q&A feature, and don't forget to write your name, your affiliation, and name of the speaker that you want to ask. Okay, now last but not least, we come to the second speaker of our seminar today. While waiting for the share screen of the presentation, would you please allow me to read the CVs of our second speaker? Okay, Mr. Abdul Halim Umar S. Farm MSc was born in Goa 8 November 1985. He is an alumnus of STIFA Makassar. He graduated in 2009. Then he got his master's degree in 2014 at Faculty of Pharmacy Hasanuddin University, Makassar. And now he is doing his doctorate in the postgraduate of plant biology program study at IPB University Bogor. He has been a lecturer of Sekolah Tinggi Ilmu Farmasi Makassar since 2011 until now. He attended many professional trainings and seminars. He also collaborated with several researchers in various journal publications with research interest in especially on phytochemistry, metabolomics, chemometric, bioinformatics, and plant culture, and etc. So for efficienting time, I invite Mr. Abdul Halim Umar S. Farm MSc. He will present topic about medicinal plant with COVID-19, a perspective from metabolomic, bioinformatics, histochemistry, and tissue culture in vitro approach. The presentation will be presented in Bahasa, and for remind the presenter that you have maximum 40 minutes for presentation. Okay, Mr. Halim, time is yours.
All right, thank you, Ms. Moderator, Ms. Reni Sahruni. I would like to take this opportunity to sharing my research, actually chapter from my dissertation, some chapter. Mungkin ini agak berbeda dengan yang pemateri-pemateri sebelumnya, ya Bapak Ibu sekalian. Ya saya akan sharing mengenai beberapa bagian dari penelitian saya, ya namun menggunakan bahasa Indonesia. Baik, Bapak Ibu, saya akan berbicara terkait dengan pendekatan metabolomik, kemudian bioinformatik, kemudian histochemistry, and tissue culture. Ya, spesialis ini untuk kultur suspensi sel, ya terkait dengan tumbuhan obat, ya yang digunakan untuk pengobatan comorbidity atau penyakit penyerta, ya yang ada pada COVID-19. Jadi mungkin agak berbeda dengan yang sebelum-sebelumnya. Karena kenapa saya mengangkat tema comorbidity? Karena mortality rate dari COVID-19 ini sangat tinggi, ya ketika ditinjau ada penyakit penyerta. Ya, penyakit penyerta itu banyak dilaporkan, ya terutama di daerah-daerah yang apa istilahnya menjadi titik epicentrum. Ya, jadi yang pertama di Cina, kemudian berpindah ke Italia, kemudian sekarang yang menjadi epicentrum utama itu adalah Amerika. Baik, ini highlight yang akan saya bicarakan beberapa menit ke depan, yang mudah-mudahan waktunya cukup. Ya, namun sebelumnya Bapak Ibu saya mohon maaf ya karena seperti tadi yang dijelaskan Ibu Moderator, karena beberapa chapter dari disertasi ini masih dalam tahap under review dan beberapa juga masih tahap menunggu keputusan bisa menampilkan data secara keseluruhan, tetapi saya berusaha untuk menyisipkan beberapa hasil penelitian yang saya kira bisa mewakili Jadi ada beberapa chapter, jadi poin 1 sampai poin keempat ini berbicara mengenai metabolomik ya dikombinasi dengan chemometric. Ya, jadi metabolomik ini kami kombinasi dengan chemometric supaya bisa lebih informatif ya, karena data dari metabolomik ini sebenarnya ada 3 pendekatan ya. Jadi yang pertama itu adalah metabolit fingerprinting, kemudian metabolit profiling, ya, dan yang ketiga itu adalah metabolit targeted analysis. Ya, jadi kami menggunakan 2 pendekatan itu. Yang pertama fingerprinting, kemudian yang kedua adalah metabolit profiling. Ya, jadi data yang keluar itu hanya berupa gugus fungsi dan bilangan gelombang ketika kita berbicara di metabolit fingerprinting. Ya, tetapi kalau kita berbicara di metabolit profiling, yang keluar itu adalah senyawa. Ya, dan ini sangat susah kita untuk menentukan gugus mana dan senyawa mana yang berefek terhadap biological activity yang dilakukan tanpa adanya dukungan atau sokongan dari teknik chemometrik. Ya, jadi Bapak Ibu nanti akan sebelum saya lanjut lagi akan ada beberapa software yang digunakan di dalam sini. Jadi saya kira ada beberapa software yang saya anggap familiar. Ya, kemudian di tahap selanjutnya 5 sampai 9 ini tahapan bioinformatika. Ya, jadi kalau Bapak Ibu lihat yang nomor 5 ini ya, sekilas kita lihat seperti SARS-CoV-2 ya, yang memang cukup memiliki similarity dengan SARS-CoV itu sekitaran 79 sampai 80% sebagai informasi tambahan juga bahwa spike-spike yang ada di sini ya, ketika kita bandingkan dengan bad-CoV atau SARS-CoV itu sekitaran 5 sampai 6 ikatan baru dengan human S2. Ya, jadi memang ikatannya lebih kuat dibandingkan dengan yang SARS-CoV ataupun bad-CoV yang diteliti. Ya, kenapa penyebarannya juga sangat cepat dibandingkan dengan SARS-CoV atau bad-CoV ya. Tapi kita tidak berbicara mengenai bad-CoV, ya, kita hanya membandingkan SARS-CoV dengan SARS-CoV-2. Kenapa penyebarannya itu sangat cepat? Karena ini dia menginfeksi epitel, karena ini terekspresi di beberapa jaringan. Ya, salah satunya adalah epitel saluran napas. Jadi dia terekspresi di bagian bawah dan bagian atas, ya, yang SARS-CoV-2 ini. Jadi kenapa penyebarannya sangat cepat? Dan yang dilaporkan terakhir oleh WHO itu memang yang pertama melalui droplet, kemudian mikro droplet, kemudian di udara yang dilaporkan terakhir. Jadi memang belum ada kepastian sama sekali. Jadi poin di kelima ini, jadi data yang diperoleh dari nomor 2 ini, ya, semua senyawa, sekitaran 100 lebih senyawa, ini kemudian kita mencoba membuat pola seperti ini. Ya, jadi kita menghubungkan antara compound, target, kemudian disease, dan pathway-nya seperti apa. Ya, ini di poin nomor 5. Ya, karena ini berbicara secara keseluruhan, artinya senyawa yang ada di dalam tanaman yang kami teliti, ada 2 tanaman, nanti sebentar akan lebih jelas. 2 tanaman yang kami teliti ini, secara umum dia sebenarnya efeknya seperti apa. Ya, ini baru bicara di poin ke-5. Kemudian poin ke-6, ini comorbidity-nya, kita spesifiknya kemana? Apakah spesifiknya ke hipertensi atau penyakit saluran pernapasan ataupun diabetes mellitus, ya. Dan untuk yang di poin 6 ini kami fokus ke diabetes mellitus. Ya, jadi poin nomor 1 ini berbicara mengenai uji in vitro, ya, uji in vitro yang selanjutnya kami kaitkan dengan penyakit diabetes mellitus. Jadi ada antioksidannya, kemudian ada inhibitor alfa glukosidasenya. Kemudian poin ke-7 nanti akan ada interaksi protein-protein apa yang terkait atau yang mendasari, ya, penyakit diabetes mellitus ini. Ya, kemudian di poin ke-8 ini berbicara mengenai gen ontologi. Itu biasanya ada 3, kemudian ditambah lagi dengan cake pathway. Ini cake ini Kyoto Encyclopedia Gene and Genome. Jadi banyak sekali pathway yang ada di sini, termasuk manusia, kemudian ada juga dari insect Drosophila melanogaster, kemudian ada dari Gallus malus, kemudian ada dari zebrafish, ya, dan lain-lain sebagainya. Ya, khusus untuk tanaman sendiri ini masih, saya pikir masih sangat terbatas, ya, karena baru beberapa tanaman yang cukup lengkap mengenai patuinya. Ya, mulai dari asam sikimat, mevalonat, malonat, kemudian metil eritriolofosfatnya itu sudah lumayan. Ya, tapi khusus untuk tanaman kami itu belum ada sama sekali. Ya, kemudian nomor 9, ya, ini masih di dalam tahap bioinformatik, tetapi pendekatannya itu lebih ke arah docking molekular. Ya, jadi senyawa-senyawa yang terdeteksi di poin 6 ini, itu kita lanjutkan di poin 9 untuk melihat seperti apa binding affinity. Kemudian residu asam amino apa saja yang dihasilkan di tahap ini. Ya, kemudian poin ke-10, tapi ini di skip ya karena keterbatasan dana. Ya, sebenarnya di poin ke-10 ini kami berbicara mengenai metabonomik. Ya, jadi kalau yang kedua ini 1 sampai 4 ini berbicara mengenai metabonomik, kalau yang ke-10 ini berbicara mengenai metabonomik. Ya, jadi ini ada hanya perbedaan istilah saja. Ya. Walaupun masih ada yang sering menukar istilah metabolomik dengan metabonomik, ya, itu masih ada. Tapi khusus kami ini masih menggunakan istilah metabonomik. Ya, ini sangat-sangat familiar di orang-orang yang kalangan farmakologi. Ya, karena ini berbicara mengenai pertubasi biokimia yang terjadi di dalam tubuh akibat pemberian obat atau akibat dari suatu penyakit atau akibat adanya toksikan. Ya, ini berbicara di sini. Ya, awalnya kami ingin melihat pertubasi apa yang terjadi di dalam setelah pemberian ekstrak dari tanaman yang kami uji. Ya, tetapi ini kami skip ya, Bapak Ibu sekalian. Kemudian poin ke-11, ini di beberapa negara yang kami amati perkembangan obat herbalnya, ya ternyata jarang sekali yang menggunakan tanaman itu secara utuh. Ya, jadi hanya menggunakan tanaman itu secara terfragmentasi. Ya, maksud kami terfragmentasi itu hanya menggunakan organ-organ tertentu. Ya, jadi ada yang menggunakan akar, kemudian ada yang menggunakan batang saja, atau ada yang menggunakan rimpang saja. Ya, makanya kami melakukan uji histokimia ini untuk menentukan sebenarnya dia terakumulasi di mana. Ya, jadi senyawa ini ada suatu tempat mengakumulasinya. Ya, jadi yang dikategorikan dengan istilah struktur sekretori. Ya, jadi ada beberapa struktur sekretori yang kami dapatkan di dalam tanaman ini dan beberapa tipe senyawa metabolit sekunder yang diakumulasikannya. Ya, kemudian yang terakhir, saya kira ini yang juga sangat menarik. Kalau yang pembicara kedua tadi, itu berbicara mengenai kultur jaringan juga, tetapi dia bermain di plasmid dengan kromosom. Kalau kami ini berbicara di tingkatan kultur sel. Ya, jadi kalau awalnya orang mengeksploitasi besar-besaran tanaman ini, ya suatu saat nanti kami berpikiran ke depan, tanaman ini suatu saat nanti akan mengalami kepunahan. Ya, karena tanaman ini sebenarnya native dari India. Ya, dan ini sudah masuk ke dalam tahap critical endanger ya tanaman ini. Ya, karena memang di sana dieksploitasi besar-besaran yang menjadi bahan baku dari Ayurvedic mereka. Ya, jadi kami di Indonesia juga menjaga ini karena sebenarnya sudah beberapa tanaman yang hampir punah. Ya, termasuk yang pernah menjadi sangat populer di masyarakat Sulawesi Selatan itu adalah Sandrego. Ya, yang sampai sekarang juga tanamannya sudah sangat jarang. Ya, suatu saat nanti kami menghindari hal-hal yang seperti itu karena ini juga merupakan saya pikir amanah dari STIFA. Ya, karena ini banyak digunakan di bahan dasar pembuatan kosmetik yang dikembangkan di STIFA. Ya, jadi intinya kami hanya mengambil daun dan ini sudah berhasil. Ini tahap akhir yang kami lakukan. Jadi kami hanya mengambil daun, kemudian kami melakukan 2 pendekatan. Kami membuat dia sebagai culture cell dengan tujuan untuk membuat dia sebagai chemical factory. Kemudian nanti akan kami ekstraksi. Kemudian yang kedua, kami tumbuhkan tanaman ini menjadi tanaman utuh. ya hanya dari organ daun. Ya kami tidak ambil bagian bawah untuk menghindari nanti kepunahan. Baik, ini sebelum saya masuk ke yang poin-poin yang tadi 1 sampai 12, ini ada beberapa referensi yang saya kira cukup menarik untuk di-share kepada Bapak Ibu sekalian. Seperti apa sih perkembangan obat herbal yang ada di dunia? Ya, karena beberapa negara itu memang sangat masif juga untuk mengembangkan obat herbal mereka. Ya, karena sekarang yang kita kenal sangat masif itu ya yang pencarian vaksin, yang sekarang itu sudah ada yang sampai tahap kedua, fase kedua. Di apa istilahnya? Selain pencarian vaksin itu ada penggunaan obat yang kalau kita di farmasi mengenalnya dengan sistem off label, atau ada juga yang mengenalnya sebagai drug repurposing, atau ada juga yang mengenalnya sebagai drug repositioning, atau ada juga yang mengenalnya sebagai drug reprofiling, yaitu sama saja ya. Ya, jadi ini di Cina, ya karena ini di Cina itu sebenarnya mirip-mirip dengan di Indonesia. Kalau di Cina dikenalnya dengan TCM. Ini kami telusuri di jurnal ini, ternyata dilaporkan itu Sufengjidu formula ini digunakan sebagai imbos ya. Jadi masih jarang obat herbal itu dilaporkan sebagai treatment untuk COVID-19. Jadi hanya sebagai booster ya atau meningkatkan sistem imunitas. Ya kemudian kami telusuri karena hanya nama yang di sini yang dihasilkan. Kami telusuri ternyata ada sekitaran 9 komposisi. Ya tetapi secara umum baik di obat jamu kita ataupun di Unani ataupun di Ayurvedic itu sebenarnya hanya 4 komposisi utama. Ya jadi ada yang sifatnya imperial, kemudian ada yang sifatnya ministerial, kemudian ada yang sifatnya servant, kemudian ada yang sifatnya sebagai asisten. Ya jadi seperti apa kegunaan dari masing-masing bahan ini ya mungkin nanti akan kita lanjutkan lah ya mungkin di topik yang lain. Kemudian ini oleh Song et al juga melakukan network farmakologi ya dan menghasilkan 4 senyawa ini sebagai kandidat utama untuk pengobatan virus tetapi bukan spesifik ke COVID-19. Ya, bukan spesifik ke SARS-CoV-2. Jadi ada quercetin, kemudian resveratrol, camprol, kemudian egonol. Ya, yang ketiga ini dilaporkan dia menghambat transkripsi dari virus. Kemudian quercetin ini dilaporkan sebagai antioksidan ya di jurnal yang dilaporkan tersebut. Kemudian ini masih di Cina, ya herbal medicine for treating COVID-19. Ini sebenarnya ada beberapa tahapan sih. Ya, yang paling banyak digunakan itu adalah Glycyrrhiza radix. Ini kalau kita di Indonesia kenalnya dengan akar manis. Ya, kemudian ada Armeniaceae semen ya atau prunus. Ini apricot. Ya, apricot, kemudian Ephedra herba, saya kira orang farmasi sangat familiar dengan tanaman ini ya karena kandungannya ada ephedrin dengan pseudoephedrin. Kemudian Gypsum fibrosum ini sebenarnya ke arah makro dengan mikronutrien sebenarnya. Ya, dan mereka itu di dalam penanganan COVID-19 ya artinya memberikan perawatan ke pasien itu ada protokol yang diikuti ya. Mungkin agak berbeda dengan yang dilakukan di rumah sakit sementara untuk penanganan COVID-19 di Wisma Atlet Jakarta. Kalau di sana itu mereka menggunakan CPG, ya Clinical Practice Guidelines. Ya, jadi memang agak berbeda ininya. Kemudian bagaimana dengan Unani Ayurvedic? Ya, jadi kalau di Cina dikenalnya dengan TCM, obat herbal mereka. Kalau di ini umumnya digunakan di Asia Selatan, ya Unani, atau ada juga yang menyebutnya sebagai Yunani. Kemudian yang dominan untuk Ayurvedic ini sebenarnya di India, walaupun India itu masuk ke dalam negara Asia Selatan. Ya, untuk Unani ini lebih banyak digunakan oleh masyarakat Muslim, ya istilah ini. Ya, jadi mulai dari Pakistan, kemudian Nepal, Bhutan, Afghanistan, Sri Lanka, Maldives, yaitu ada beberapa yang menggunakan istilah ini, tetapi dominan untuk masyarakat Muslim. Ya, kenapa itu namanya ada yang ke Arab-Araban ya? Ada sarbat unab, sarbat kaksi, sarbat sofa murakkab. Ya, ini nama-nama Islam saya pikir. Ya, kalau kita di Indonesia mengenalnya sarbat itu sebagai sirup buah. Ya, ini sarbat unab. Ini diperoleh dari Sisyphus jujubah. Ya, kalau kita di Indonesia agak beda spesiesnya ya, tapi mirip-mirip bentuknya. Ini seperti apel, kemudian Strabelus asper, ini buah serut kalau kita di Indonesia. Jadi bentuknya itu mirip-mirip dengan apa ya? Kalau di Makassar itu lobe-lobe mungkin ya mirip-mirip dengan itu, tetapi dia warnanya merah. Ya, dari suku Morase. Kemudian yang kedua ini menggunakan Borago officinalis. Ya, jadi Borago officinalis ini saya pernah lihat di daerah Malino. Ini sangat jarang tanamannya. Dia kita kenalnya dengan istilah bunga bintang. Ya, warnanya itu warna ungu. Ya, kemudian di paper ini juga disarankan ya untuk meningkatkan imunitas dengan meminum jus anggur atau lemon 3 kali sehari, atau paling tidak sanitasi lingkungan sekitar dengan menggunakan air mawar atau dengan menggunakan sandal water. Ini bukan sandal yang direndam ya, bukan. Sandal water itu dari Santalum album, ini dari kayu cendana, atau kita lakukan fumigasi dengan menggunakan kampora atau dengan menggunakan akar wood. Ya, akar wood ini saya kira sangat terkenal juga di Indonesia. Kita kenal dengan istilah gaharu, karena di Indonesia itu merupakan salah satu penghasil gaharu yang cukup baik saya pikir. Di Indonesia kita kenal ada 2 spesies yang menghasilkan gaharu yang kualitas terbaik. Ya, ada dari Aquilaria, kemudian ada dari spesies Gilirinops. Kemudian seperti apa Ayurvedic? Ya, Ayurvedic itu melaporkan juga, ini saya ambil dari Times of India, dilaporkan ini kerjasama antara Institut Teknologi India dengan ICE Jepang. Ini melaporkan ashwagandha, Withania somnifera, atau ginseng India, kalau kita kenalnya di Indonesia itu tanaman ciplukan. Ya, kemudian Tinospora crispa ini juga dilaporkan pemateri sebelumnya. Kemudian Glycyrrhiza glabra, ini akar manis juga. Ya, tapi ini saya kira prinsipnya sama untuk semua negara. Ini menggunakan istilah obat tradisional itu ada dasar dan biasanya dilakukan secara turun-temurun. Biasanya kalau TCM itu mengarah ke penggabungan dari 5 elemen sama dengan Ayurvedic, tapi Ayurvedic itu lebih, karena ini lebih banyak ke masyarakat Hindu dan Buddha yang mengaplikasikannya. Ini biasanya dikenal dengan Pancamahabhutan, sama prinsipnya dengan penggunaan TCM, Pancamahabhutan, penggunaan 5 elemen juga. Nanti dari 5 elemen ini kemudian dipecah lagi menjadi bagian-bagian yang terkecil, ya, yang dikenal dengan tridosanya. Kemudian istilah obat tradisional, ya, untuk di Jepang itu kita kenal dengan istilah kampo, ya, sama saya kira dengan yang lain juga, menggunakan CPGS juga, Clinical Practice Guidelines juga. Kemudian yang menarik itu yang jamu, ya, yang ada di Indonesia. Tapi saya belum mengkategorikan jamu ya, karena ini masih penggunaan secara tunggal. Kalau kita jamu itu biasanya kombinasinya biasanya 4-5 tanaman. Ya, maksud saya organ tanaman. Ya, ada daun sambiloto, daun meniran, daun sembung. Ini saya ambil dari CNC Indonesia dengan Kompas. Ya, ini dilaporkan digunakan di rumah sakit sementara untuk COVID-19 di Wisma Atlet. Ya, tetapi untuk penggunaan ketiga ini, ya, karena ini sudah lumayan agak ini ya ada datanya, ini digunakan untuk orang yang ODP dengan pemantauan, ya, ketiga ini. Ya, jadi memang hanya digunakan untuk info saja. Ya, kemudian seperti apa sih penggunaan network farmakologi dalam kaitan obat ya yang menjadi kandidat obat untuk COVID-19. Yang tadi yang herbal medicine untuk di Cina itu, yang herba ephedra, kemudian semen armeniaceae, kemudian Glycerin radix, kemudian Gypsum fibrosum, ini dibuat pola jejaring farmakologinya. Ini lumayan sangat baru, tahun 2020. Ya, ini ternyata diperoleh main compound itu quercetin, camphorol, herbacetin, ya dan lain-lain sebagainya. Dan jumlah targetnya juga lumayan. Kemudian main targetnya TNF alpha, kemudian interleukin 1 beta, interleukin 2, dan lain-lain sebagainya. Ya, jadi maksud saya menampilkan ini supaya memberikan gambaran seperti apa pendekatan jejaring farmakologi itu di dalam pencarian obat. Artinya bisa mereduksi biaya dan bisa mereduksi waktu. Baik, ini terkait dengan komorbiditas yang dilaporkan. Ya, jadi yang pertama itu dilaporkan memang di Cina, di daerah Wuhan, provinsi Hubei. Ya, kemudian dari Hubei itu dia menyebar ke Henan, kemudian dari Henan ke Xinjiang, kemudian dari Xinjiang berpindah lagi ke Guangdong. Kemudian dari situ kemudian di lockdown, akhirnya pindah ke Italia. Kemudian dari Italia nanti pindah lagi ke Amerika. Ya. Ternyata yang dilaporkan di daerah-daerah yang menjadi titik epicentrum itu, ya Indonesia belum menjadi epicentrum, yang mudah-mudahan tidak. Ya, Cina, kemudian Italia, kemudian New York, ini hipertensi menjadi nomor 1, kemudian diabetes, kardiovaskular, kemudian respiratory system disease. Ya, jadi yang dilaporkan oleh yang et al. Itu, dia metodenya systematic review and meta-analysis. Kemudian yang saya ambil di Italia itu dari pusat data statistik mereka, Statistika Research Department, tetap hipertensi itu yang paling tinggi. Kemudian di New York itu hipertensi juga, diabetes di urutan ketiga, ini menggunakan pendekatan retrospektif cohort study. Ya, kemudian di Indonesia sendiri dilaporkan hipertensi, diabetes, ya tambahan yang terakhir ini adalah demam berdarah. Ya, jadi memang rata-rata di beberapa negara yang menjadi epicentrum itu dilaporkan tingginya kematian akibat COVID-19 itu karena adanya penyakit penyerta. Penyakit penyerta itu seperti yang tertera di slide ini. Ya, walaupun ada dilaporkan juga pengaruh gender, kemudian pengaruh usia itu ada juga yang dilaporkan. Baik, ini bagian yang pertama. Ya, jadi saya hanya berbicara secara umum Bapak Ibu karena alasan yang tadi. Ya, jadi dari sampel ini tanaman, kami menggunakan 2 tanaman, yaitu Curculigo orchoides dengan Curculigo latifolia. Ini sebenarnya kami juga ingin membandingkan sebenarnya mana yang lebih bagus dari kedua tanaman ini. Kami melakukan uji in vitro. Setelah melakukan uji in vitro, kami melakukan analisis metabolomik, ya, dengan pendekatan metabolit fingerprinting dengan metabolit profiling. Ya, jadi metabolit profiling ini nanti yang akan keluar adalah data waktu, kemudian kelimpahan relatif, ya, kemudian dari sini kita menggunakan software lagi. Ya, dari software itu nanti ada proses tahapan-tahapan, kemudian akan kita peroleh ternyata yang ada di puncak ini, di peak ini senyawa ini, yang ada di peak ini adalah senyawa ini. Ya, seperti itu seterusnya. Kemudian di fingerprinting, ini kita berbicara mengenai bilangan gelombang. Ini kami menggunakan tipe absorbansi. Ya, jadi yang keluar di sini nanti adalah gugus fungsi. Ya, kemudian untuk memudahkan ya kita untuk melihat mana sebenarnya yang berkontribusi utama atau berkontribusi mayor terhadap aktivitas yang kami lakukan, itu kami menggunakan kombinasi dengan teknik chemometrik. Ya, sebenarnya teknik chemometrik itu banyak jenisnya ya, tapi kami hanya menggunakan teknik principal component analysis, kemudian partial least square. Ya, 2 ini yang kami gunakan. Ya, jadi PCA itu kami gunakan untuk mendiskriminasikan. Ya, bayangannya itu karena kami menggunakan 2 tanaman, kami mengelompokkan 2 tanaman ini. Apakah bisa dengan menggunakan teknik chemometrik atau tidak? Itu yang pertama. Kemudian yang kedua, menggunakan teknik PCA ini untuk melihat apakah senyawa yang ada di daun, senyawa yang ada di pelepah, dan senyawa yang ada di rimpang itu berbeda atau tidak. Ya, ini kami menggunakan teknik PCA dan ternyata hasilnya itu berbeda. Ya, kemudian dari teknik PLS ini itu kami mendeteksi gugus fungsi mana, kemudian dari PLS ini juga data dari UHPLC Orbit Trap MS-MS, alat yang kami gunakan, ini senyawa apa yang dominan atau senyawa apa yang berkontribusi utama terhadap bioaktivitas yang dilakukan. Ya, jadi kami combine antara PLS yang di sini dengan PLS yang di sini, senyawanya ini, terus gugus fungsi pada nomor sekian, ya, yang berkontribusi paling utama. Jadi nanti akan ada datanya yang saya tampilkan sebentar. Ya, jadi nanti akan keluar data-data seperti ini. Baik Bapak Ibu, kalau ini saya berbicara mengenai metabolomics, pendahuluan sedikit dulu di sistem biologi. Sebenarnya posisi metabolomics itu ada di mana sebenarnya? Ya, jadi ini semakin ke bawah, ini kompleksitas selulernya semakin besar. Ya, kalau kita terus sinkronkan dengan data, maka semakin ke bawah ini datanya juga akan semakin besar. Ya, karena bermain dengan metabolomik dan chemometrik itu kita bermain datanya bukan ratusan ya Bapak Ibu, tapi kita bermain data itu sekitar ribuan. Ya, jadi mengolah datanya itu yang lumayan lama. Kalau hanya untuk analisis itu biasanya 2-3 minggu kita sudah dapat data yang bagus, tapi pengolahan datanya itu yang membutuhkan waktu yang lama. Kita lihat di area dogma sentra biologi. Ya, ini sebenarnya istilah-istilah ini baru muncul di tahun 1987-an ya. Ya, awalnya itu menggunakan istilah genom. Ya, ini diprakarsai sebenarnya oleh Hans Runker itu sekitaran 1820-an, tetapi masih menggunakan istilah genom. Ya, jadi sufiks e itu ya, genom. Sufiks genom itu kemudian berubah menjadi X itu sekitaran 1987-an. Yaitu diprakarsai oleh Frank Ruddle. Ya, istilah X sendiri ini kalau kita telusuri lagi secara harfiah, ini berarti secara keseluruhan ya atau totalitas. Jadi mempelajari mengenai metabolom yang ada di dalam suatu individu itu secara total. Ya, jadi genomics ini juga ada bagian-bagiannya yang mungkin bisa nanti di-sharing ya terkait dengan metagenomics, kemudian epigenomics, kemudian di tahap transkriptomik ini biasanya orang bermain di exomics. Ini terkait dengan histon dengan intron, ini kebanyakan di sini. Kemudian di proteomik ini juga banyak ya sekarang di istilah proteomik ini. Maaf. Proteomik ya, ini banyak yang berbicara mengenai glikoprotein, kemudian fosfoproteomik. Ini kemudian nanti dikaitkan dengan siklus Krebs. Ya, jadi biasanya juga orang bermain-main di sini ya terkait dengan metabolit engineering. Ya, jadi biasanya dengan menekan ya, biasanya mengkombinasi antara genomics dengan proteomik. Jadi seumpamanya kita gen-gen tertentu, ternyata ini yang meningkat, atau kita overekspresi gen tertentu, ternyata ini yang mengalami perubahan. Kemudian ini yang dikategorikan sebagai era post genomik. Ya, kemudian nanti baru muncul metabolomik. Ya, di sini posisi kami sekarang ya metabolomik ya terkait dengan phytochemomics. Ya, tetapi kami khusus bermain di secondary metabolite. Ya, karena ada juga yang lipidomics, ada juga glycomics, ya, dan istilah-istilah sekarang itu banyak berkembang. Saya lihat ada lagi istilah phenolomics, ada istilah photomics, ya, dan lain-lain sebagainya. Ya, tapi kami khusus di metabolomics, khusus di phytochemomics, khusus di secondary metabolite. Kalau ada lagi yang ingin melihat fenomena yang terjadi ketika tumbuhan ini berinteraksi dengan lingkungan sekitar, apakah itu nanti dipengaruhi oleh faktor abiotik maupun biotik. Ya, kemudian yang lebih kompleks lagi, interaktomics, kemudian reaktomics, kemudian fluxomics. Ya, ini lebih kompleks lagi, tapi ini biasanya mengkombinasi dengan teknik bioinformatika. Ini biasanya orang bermain di sini. Baik, ini seperti apa flowchart dari penggabungan ya antara metabolomics dengan chemometrics. Ya, karena jarang sekarang orang hanya bekerja dengan metabolomics. Ya, dan saya pikir ini sudah menjadi simbiosis antara metabolomics dengan chemometrik. Ya, jadi seperti ini bayangan apa yang kami kerjakan di laboratorium kami selama ini. Untuk tahap pertama, kami menggunakan alat ya karena beberapa alat itu memang memiliki spesifikasi khusus ya terutama di deteksi massanya. Kalau kami menggunakan UHPLC orbit trap MS ya kami kombinasi lagi dengan MS. Ya kalau di Mabes Polri itu kami pernah cek ke sana juga, itu menggunakan HPLC IT TOF yang mereka gunakan. Ya saya pikir lumayan lah harganya. Sekali nginjek itu, sekali running itu sekitar 1,8. Ya, jadi Bapak Ibu pikir bagaimana ketika menggunakan sampel yang banyak. Jadi metabolom di Indonesia itu saya pikir masih terkendala dengan biaya. Ya mungkin nanti suatu saat harapan kami STIFA bisa mengadakan alat ini ya. Ya jadi dengan menggunakan alat ini kita bisa langsung mengetahui metabolitnya karena ini beberapa software itu bisa diperoleh secara online atau bisa juga menggunakan software bawaan. Tapi kami sendiri karena datanya itu bisa bias, jadi kami menghindari yang seperti itu. Kami menggunakan in-house database. Ya, jadi semua data terkait dengan tanaman itu yang satu famili ataupun satu genus itu semua kami data. Kemudian kita buat data bank, kemudian itu yang nanti akan kita gunakan sebagai pembanding. Itu kalau kita berbicara mengenai di tahapan metabolomik saja terkait dengan profilingnya seperti apa. Tapi kalau kita mau lanjut lagi dengan teknik chemometrik, ya ini ada beberapa tahapan lagi. Ya, noise filteringnya seperti apa, peak deteksinya seperti apa, alignmentnya seperti apa, normalisasinya seperti apa. Ya, jadi ini campuran antara matematika dengan statistik ya di sini. Tetapi Bapak Ibu tidak usah khawatir ya karena ini sudah sepaket dengan alat yang digunakan. Kalau kami menggunakan MS dial. Ya biasanya banyak software-software yang open source ya dan bisa didapatkan secara gratis ya untuk mengolah data-data dari metabolomik ini. Kemudian kita lakukan pre-processing ya dan saya pikir yang tahapan ini yang lumayan memakan waktu. Kemudian variable sectionnya, apakah nanti akan kita buat seleksi berdasarkan ranking ya seperti yang tadi ditampilkan di awal. Oh ternyata kalau senyawa ini kita lakukan uji terhadap antioksidan, nilai VIP-nya berapa? Ya walaupun banyak ini, tapi yang sekarang yang paling familiar yang digunakan istilah VIP. Ya, very important in projection score. Ini yang biasanya paling banyak digunakan. Tetapi di software kami sendiri ini tidak ada. Ya, jadi ini adanya di SIMKP atau di yang secara online metabo analis. Atau kita lakukan lagi modeling of data. Ini yang kami aplikasikan di penelitian kami dengan menggunakan teknik PCA dengan PLS, partial square discriminant analysis, atau menggunakan ini tidak kami gunakan ya. Ini random forest atau istilahnya SPM support vector machine atau artificial neural network atau banyak lagi pendekatan-pendekatan yang lain. Tapi khusus untuk kami menggunakan ini karena kami hanya ingin melihat seperti apa pengelompokan tanaman, apakah bisa dibedakan antara spesies ini, spesies A dan spesies B, kemudian dari organ tanamannya apakah bisa dibedakan juga atau tidak. Kemudian PLSA yang tadi untuk melihat kontribusi mana dari gugus fungsi itu yang paling bagus. Ya, ini saya kira sama dengan yang tadi general analysis workflow in chemometric tools. Ini khusus yang fingerprinting. Ya, jadi fingerprinting ini sebenarnya datanya hanya untuk melihat pola ya, hanya melihat pola. Ya, ini ada untargeted dengan targeted. Ini alat-alat yang sering digunakan. Ya, saya kira sama prosesnya tadi, harus ada pre-processing, kemudian ada treatment untuk noise, alignment-nya seperti apa, normalisasinya seperti apa. Ya, ini saya masuk dengan apa yang kami lakukan. Ini kami mengambil sampel ini, 2 tanaman ini, ya, jadi Curculigo orchoides dengan Curculigo latifolia. Ini kami cek di International Plant Name Index, itu ada sekitar 78 spesies. Kemudian kami cek juga di World Checklist Selected Plant Families, itu ada sekitar 79 spesies. Dan ada sekitaran 20-23an yang accepted ya. Artinya itu yang digunakan, nama itu yang digunakan sekarang. Kami baru meneliti 2, ini pun masih sangat-sangat terbatas kami pikir, jadi masih membuka peluang untuk peneliti-peneliti lain untuk meneliti yang famili sejenis. Ya, jadi ini ada beberapa daerah, karena kami memang ingin melihat apakah ada perbedaan antara tiap lokasi pengambilan sampel, ya, kemudian organnya juga kami akan lihat nanti. Ya, ini sebenarnya ada data sebelumnya ini ya, tapi karena keterbatasan tadi makanya kami tidak tampilkan Bapak Ibu sekalian. Ini hanya data ini. Ya, jadi seperti ini penampilan data untuk metabolomic analysis. Ya, seperti ini. Jadi ada sekitaran 79 senyawa. Ini kami menggunakan 2 adaptide. Ya, jadi ada di M+ dengan di M-. Ya, jadi ini software yang kami gunakan. Nah, jadi ini untuk heat map-nya sendiri, ini bisa kita lihat ini sangat-sangat bervariasi. Kalau dia semakin merah, ini artinya senyawa ini di dalam organ tersebut itu paling intensitasnya paling tinggi. Ya, dan bisa kita simpulkan kalau intensitasnya tinggi berarti akumulasi senyawanya itu banyak di dalam organ tersebut. Ya, jadi semakin dia hijau ya, ini semakin kecil kadarnya. Kalau semakin merah dia semakin besar. Ya, dengan melalui pendekatan PCA dengan PLS, ya, kami dapat 2 kandidat senyawa, yaitu Curculigo saponin M, ini yang mengarah ke antioksidan, kemudian Sinanuriculosida A, KIT, ini yang mengarah ke inhibitor alfa glukosidase. Ya, jadi ini memang karena masih bergabung antara primer dengan sekundernya, jadi bobot molekulnya itu masih di atas 1000-an. Ya, jadi kami di dalam software itu ada settingan sih sebenarnya. Jadi kami range itu dari 100 sampai 1500 massa yang bisa tercover. Ya, jadi di atasnya itu sudah tidak bisa. Karena memang prinsip dasar dari metabolomics itu senyawa yang dideteksi itu lebih besar, lebih kecil atau sama dengan 1500. Ya, jadi 2 senyawa ini yang menjadi senyawa utama yang kami peroleh. Kemudian kami kaitkan dengan gugus fungsinya. Ya, ternyata yang berkontribusi utama itu adalah gugus fungsi yang tertera, ya, yang ada tulisan putihnya. Ya, jadi ada di R3, kemudian R11, kemudian R ini 2122, kemudian 2324. Ya, kemudian karena ini laporannya berbeda dengan yang kami telusuri di pustaka, ya, dilaporkan di pustaka itu ternyata kurkuligosid yang banyak berefek sebagai antioksidan, ya, dan beberapa golongan fenolik, ya, yang masuk juga derivat dari flavonoid yang dilaporkan. Ya, ternyata di penelitian ini yang 2 ini termasuk ke dalam tetracyclic triterpen. Dan itu ternyata dilaporkan oleh Teng et al. Ya, senyawa yang ada di sini, gugus fungsi yang ada di R1, R11, ya, R2122, 2324, ini yang meningkatkan efek antioksidan dan inhibitor alfa glukosidase dari senyawa tetracyclic triterpen. Ya, jadi mendukung apa yang kami temukan dan apa yang kami hasilkan dari proses kombinasi antara metabolomik dengan chemometrik ini. Ya, ini juga kami cek ya, karena ini kami menggunakan in-house. Betul, senyawa yang terdeteksi ini ya, terdeteksi ini kurkulikosaponin dengan sinanuriculosida. Ini kita cek pola fragmentasinya dengan yang MS-MS-nya. Ini kami menggunakan 3 voltase, 10, 35 dengan 50, tetapi di 10 voltase ini dia sudah terlihat pola fragmentasinya. Jadi ada parent ionnya itu 491, ini pola fragmentasinya, jadi kami hanya mengambil yang tinggi-tinggi ya, Bapak Ibu. Kemudian kita lihat pola fragmentasinya seperti apa. Dari MZ-nya 491, kemudian kehilangan H2O, nanti dia membentuk 473. Ya, dan akhirnya nanti semua yang ini masih kerangka yang sama. Masih kerangka yang sama. Ya, jadi ini kami yakini bahwa senyawa ini betul adalah senyawa sinanuriculosida. Ya, begitu juga dengan kurkulikosaponin M. Ya, jadi ini ada sekitaran 4 heksosanya. Ya, jadi ini terfragmentasi hilang satu-satu, kemudian nanti ujung-ujungnya nanti akan kembali ke struktur dasar. Ya, pentasiklik triterpen. Jadi ini juga pola fragmentasinya kami meyakini bahwa senyawa yang terdeteksi itu betul ya, senyawa kurkuligosaponin. Nah, sampai di situ yang chemometrik.
Waktunya mengingatkan sekitar 5 menit lagi.
Oke, baik. Mungkin saya agak percepat ya Bapak Ibu. Ya, jadi data yang saya lihat saja, yang ini saya lewat. Ya, jadi data yang kami peroleh di metabolomik itu kami cek ya, karena sekitar lebih besar dari 80% itu penggunaan obat itu melalui gastrointestinal. Ya, jadi kami cek obat ini dia memiliki tingkat absorbansi bagus atau tidak. Ya, jadi yang kami lanjutkan ke tahap berikutnya itu adalah senyawa-senyawa yang memiliki tingkat absorbansi yang bagus, ya, berdasarkan pada parameter 5 principal. Ya, jadi seperti ini yang kami buat, yang gambar tadi itu. Ya, jadi ini ada sekitaran 33 senyawa yang dari hasil filter tadi yang mengecek absorbansinya bagus atau tidak. Kemudian disease-nya ada, ini terkait dengan diabetes ya. Disease-nya ada 11, patuhnya 13, target proteinnya ada 13. Ini khusus untuk DM. Jadi kalau kita lihat polanya DM itu yang kami tandai berwarna merah. Tetapi secara keseluruhan, Bapak Ibu, ini untuk cancer. Ya, secara keseluruhan. Tapi karena kita comorbidity-nya hanya ingin mengarah ke diabetes mellitus, maka kami lanjutkan ya dengan mencari yang seperti ini. Khusus untuk diabetes mellitus. Kalau yang tadi itu hanya 33 senyawa yang khusus untuk keseluruhan total, kalau ini hanya 21 senyawa yang ada kaitannya dengan penyakit diabetes mellitus untuk comorbidity. Ya, kami buat modelnya ini lebih berwarna hijau, itu dia lebih besar degree-nya atau target. Ya, jadi ini aldoketoreduktase famili 1 ya, member B1 ini yang memiliki degree yang paling banyak, ada sekitaran 8 senyawa ya yang terkait dengan target ini. Kemudian kita lihat ada diabetic complication, ada diabetic katarak yang menjadi tujuan utama dari AKR1B1 ini. Kemudian ada hidroxysteroid dehydrogenase 11B1 ya, kemudian ada kurkulikosaponin dengan G-protein couple bile acid receptor. Ya, seperti ini ya tampilannya Bapak Ibu. Saya agak percepat ya. Kemudian ini seperti ini protein-protein interaksi yang terjadi. Ternyata yang paling banyak ini adalah mitogen activated protein kinase 1. Ya, yang mendasari ya terjadinya patofisiologi penyakit DM. Kemudian seperti ini gen ontologinya. Biologi prosesnya ternyata didominasi oleh peptidyl serin fosforilasi. Ya, ini sebenarnya terkait dengan pensinyalan ya insulin substrat reseptor 1 maupun 2. Kemudian sitosol ini kita ketahui pertukaran ya, pertukaran ANA dengan CA+ di sini memiliki peranan yang penting di dalam proses patofisiologi dari DM. Saya nggak percepat. Seperti ini binding affinity ya yang terjadi antara yang tadi yang hasil dari bioinformatika kami coba dan hasilnya seperti ini ternyata kurkuliginin B, kemudian sinanuriculosida A, kemudian kurkuligosaponin L ini yang memiliki binding affinity paling kecil. Ya binding affinity paling kecil berarti nanti itu yang interaksinya paling besar dengan reseptor nanti. Kemudian ini graphical abstract ya untuk melihat senyawa ini sebenarnya terakumulasi di mana. Ini saya agak percepat. Ya, jadi intinya ketika senyawa itu dihasilkan oleh sel ya, apakah itu entah nanti di retikulum endoplasma, di sitosol maupun di sel-sel yang lain, itu tidak akan disimpan lama di tempat tersebut. Ya, jadi harus dikeluarkan. Ya, jadi bisa saja melalui bilirubin translocate, kemudian ATP binding cassette atau melalui MET, kemudian ATPase atau PPase atau melalui snare. Ya, dan intinya nanti akan ditempatkan di struktur sekretori tertentu. Ya, jadi ini beberapa struktur sekretori yang kami identifikasi di tanaman ini. Ya, seperti ini Bapak Ibu tampilannya struktur sekretori. Ini rongga sekretori yang kami peroleh. Jadi bentuknya seperti ini. Kemudian ada epitelnya 2 lapis. Ya, ini untuk Curculigo orchoides yang di bawah ini latifolia. Ini pengujian fenoliknya. Ini banyak sekali. Sangat tinggi memang fenolik dari tanaman ini. Kemudian ini terpenoidnya. Kemudian yang terakhir, ya untuk explant yang daun ini, ya untuk di orchoides ini memang ada beberapa variasi ya. Memang terbentuk kalus atau memang langsung terbentuk tunas dan akar. Kemudian ada yang terbentuk tunas, kemudian nanti akarnya, kemudian ada yang terbentuk multikalus. Yang multikalus artinya di sepanjang tulang daunnya itu terbentuk ya. Dari nanti sini, ini yang menjadi goals kami. Dari kalus ini kami akan nanti produksi metabolis sekunder dari tahapan ini. Ya seperti ini, tahapan-tahapannya hanya gambar yang saya tampilkan Bapak Ibu. Datanya itu, maaf saya tidak bisa tampilkan ya. Kemudian ini seperti ini bentuk kalus yang nanti akan kami perbanyak. Ya ini suasana pengerjaan kami di laboratorium. Ini yang sudah besar sekarang. Ini mungkin sudah bisa dibawa pulang ke Makassar, ya hadiah nanti buat Ibu moderator ini. Ya, ini sudah besar. Ini aklimatisasi tahap pertama, ini sudah kami tanam. Ya, ini yang menjadi pertanyaan mendasarnya, akan kami analisis beberapa minggu ke depan. Ya, jadi hasil dari kultur ini, apakah memang ada senyawa ini terkandung di dalamnya? Ya, kalau pertanyaannya ternyata tidak ada, akan kami adakan ya dengan penambahan elisitor. Ya, jadi kami buat dia dalam suasana tercekam, karena dalam suasana tercekam itu umumnya tumbuhan akan mensekresikan metabolis sekunder. Ya, saya kira ini mungkin saya perlu perkenalkan sebelum saya akhiri. Ini Bapak Ibu, ini kembar ya. Kalau petani kedelai itu punya malika, ya kalau saya punya orcha dan orchi. Ini dari orchoides, kalau ini dari latifolia saya namakan latif ya. Ya, ini orang-orang hebat ya yang membimbing saya. Mungkin kalau ada dari Bapak Ibu sekalian atau dari rekan-rekan mahasiswa, welcome. Ya, dan kami siap untuk mengantar untuk bertemu ya kalau semuanya membutuhkan sesuatu. Jadi ada Prof Dia, ini promotor saya, kemudian ada Pak Raffi yang membimbing saya di chemometrik dengan metabolomik, kemudian ada Ibu Yohana yang membimbing saya di plan structure in histochemistry, kemudian Pak Hamim ini di pitoremediasi. Jadi kalau ada Bapak Ibu sekalian yang ingin menambang emas dengan menggunakan tanaman itu bisa menghubungi beliau. Ya, ini menggunakan pitoremediasi. Jadi bisa kita tambang emas dengan menggunakan tanaman. Ya baik, Bapak Ibu, ya cukup sekian. Saya kira banyak kekurangan. Ya mohon maaf Ibu moderator dan partisipan. Ya, saya akhiri cukup sekian nun wal kalami wa ma yasturun, demi pena dan apa yang dituliskannya. Baik, saya kembalikan ke Ibu moderator.
Oke, thank you Pak Halim. Ya, presentasi yang sangat menarik dan menginspirasi ya buat kita para peneliti. Participant, we have listened all presentation from two speakers, so now it's time for discussion session. We have time about 30 minutes for discussion. Okay, I will read the incoming question from the participant, and now we have some question from Q&A Zoom feature. Saya akan memilih beberapa ya, dan mungkin beberapa pertanyaan.
I have answer, no?
Ya.
Yes.
Ya, beberapa pertanyaan sudah dijawab juga oleh pembicara pertama kita ya, Prof. Pram. Oke, mungkin untuk yang pertanyaan pertama, Profesor Pramono. Yeah, the question from Lukman. The first question, available in Indonesian market, an immunostimulant content Echinacea purpurae, according to your presentation. Is it possible for COVID-19 treatment? And the second, stability testing including physical and chemistry parameters. How important the chemical stability in the tablet or syrup, and how to evaluate the chemical stability if we don't know the marker active compound?
Okay. Now I answer?
Yeah.
Okay, directly based. Echinacea, yes. But it is not really Indonesian plant, but now we can cultivate here in Indonesia. So we can develop the Echinacea purpurea, etc., because it has the immunostimulant activity. We have several products in the market with Echinacea species. So you can develop the Echinacea as supportive therapy for COVID-19. But of course, we have to do the clinical trial. Same with the others. This is Echinacea purpurea, Echinacea another species, etc. So you can use it for the research and then develop as a supporting therapy. And the second question, I forget what is the second question.
The second question, okay, stability testing including physical and parameters.
If you do not have the biomarker, you can look at the chemical constituent, the group. It means, for example, in Maniran or Philanthus niruri, we have philanthine, but the quantity of the philanthine in the Philanthus niruri is very, very small. It is rather difficult to to use this kind of chemical constituent for the marker for product. It's rather difficult. So the Pharmacopoeia Herbal Indonesian Herbal Pharmacopoeia, FHI Pharmacopoeia Herbal Indonesia, use the flavonoid total as to check the reproducibility and to standardize the extract and also the product. So we can take the group of chemical constituents exist in the plant. This is the method to do the standardization, also to check the stability of the product. Yeah.
Okay, thank you, Prof.
Yeah.
And the next question to Pak Halim. Ya, ini dari Bapak Agus Winarno. Ada beberapa pertanyaan. Yang pertama, kenapa orang hipertensi lebih tinggi angka mortalitas terhadap penyakit corona? Kemudian, herbal apa yang dipakai di Cina dan Indonesia? Apa benar golongan darah golongan A lebih rentan terhadap corona dibanding golongan darah AB, B, dan O? Oke, silahkan Pak Halim.
Baik Ibu, terima kasih. Saya langsung jawab ya. Pertanyaan pertama, kenapa orang hipertensi ini lebih tinggi angka mortalitasnya? Sebenarnya karena saya berkecimpung di metabolomik ya, jadi mungkin nanti Bapak Ibu dosen yang sempat hadir di sini yang orang farmakologi, tolong dikoreksi kalau saya ada kekeliruan di dalam menjawab ya terkait dengan kenapa obat hipertensi ini orang hipertensi ini lebih tinggi mortalitasnya. Ya, yang pertama perlu kami sampaikan bahwa human S2 ini dia terekspresi di beberapa sel epitel di dalam tubuh ya, termasuk di sel epitel saluran napas, kemudian di sel epitel saluran pencernaan, kemudian ada juga dilaporkan di liver, kemudian ada juga dilaporkan di saluran endokrin ya, itu yang pertama. Kemudian ketika kita kaitkan dengan hipertensi ini, ya terus terang kalau yang ini saya belum ada data. Kalau data yang ada sama saya itu hanya terkait dengan gender. Ya, dilaporkan di jurnal terindeks itu bahwa orang laki-laki itu lebih rentan terkena SARS-CoV-2 dibandingkan dengan perempuan. Kenapa? Karena ekspresi dari human S2 ini pada laki-laki itu lebih banyak dibandingkan dengan perempuan. Ya, itu yang pertama. Kemudian yang kedua, kenapa perempuan itu ketika dibandingkan dengan laki-laki ini sangat rendah persentasenya terkena SARS-CoV-2 ini? Ya, itu ternyata dikaitkan dengan hormon estrogen yang ada di dalam tubuhnya. Itu ternyata hormon estrogen kalau kita compare antara laki-laki dengan perempuan, itu ternyata lebih banyak di perempuan ya, hormon estrogen tersebut. Ya, itulah kenapa sempat ingin dijadikan sebagai kandidat obat yang dexamethasone ya, dari golongan steroid. Ya, kemudian herbal apa yang dipakai di Cina dengan di Indonesia? Ya, kalau ini mungkin di slide-slide yang sebelumnya, kalau herbal yang dipakai yang paling banyak persentasenya di Cina itu yang glycyrrhizae tadi, ya, yang akar manis Glycyrrhiza glabra, itu yang paling banyak digunakan. Kemudian kalau di Indonesia ini saya hanya mengambil tadi data dari CNN yang mungkin nanti bisa dilihat nanti dari Prof. Sujiwo. Ya, ternyata yang dilaporkan di CNN itu dan di Kompas ini ada daun meniran juga sebenarnya dilaporkan. Ya, kemudian kalau di tahap in vitro ya IPB itu tapi belum publish papernya. Ini ada di tahap in vitro itu menggunakan siniber. Ya, di dalam masih tetapi penelitiannya itu tahap jejaring farmakologi. Kemudian yang ketiga, apakah benar golongan darah A lebih rentan? Ini maaf kalau yang ini saya tidak ada data sebenarnya. Ya, untuk golongan mana yang memiliki rentan terkena SARS-CoV-2 yang paling tinggi, saya nggak ada data, Ibu Reni.
We move to the next question. It's from Pak Syahrudin Kasim. If for Prof. Pramono,
Yes.
we combine the plant or personal to the gas how that can be used as COVID-19 drugs? And next, what the side effect of consuming the herbal daily while taking COVID drugs?
Okay, so about the first question, I think I have answered for the other person, I think. So it is better that we take the formula first, because we have two study of subchronic toxicity test when we mix between Meniran or Philanthus nirudi, and Nigella sativa, Habatus sauda or jinten hitam. Separately, the first and the second one, and these two plants separately, is safe in subchronic toxicity test in rats. Safe. But when we mix these two kind of plant, the hepatotoxicity appear. We have two subchronic toxicity tests, and these two kind of research gave the increase of hepatotoxicity. So I ask to everyone to mix one and two plant. So we have to look at first if it is exists in the traditional medicine, or perhaps in the traditional book, empirical use of fiber in the people or not. If not, make attention. Yeah, make attention. This is the mix between one and two plant. Yeah, so this is the case of these two plants. And then the second question about what I said in the second question.
Side effect of consuming the herbal daily while taking COVID drugs.
Yes. If, for example, we continue to take, for example, this is our experience. Temulawak itself, temulawak or curcuma santurisa, if we take, for example, not juice, but slice the rhizome and then give the put the white water, and then after 5 minutes we consume it. Yeah. During 15 days, the SGPT and SGUT will decrease. But myself, I took this, and my SGPT and SGUT decreased very, very low. It is not really good. So I advise, if you take, for example, 2 weeks, and then stop first, and you can take again after 1 week without taking this kind of herbal. This is generally like this. And if you take with the synthetic drugs, like in the COVID-19, so minimal 2 hours after taking the synthetic drug. Minimal. It's better if you take, for example, 4 hours after. This is usually we advise to the patient like this. Yeah.
Okay, thank you, Prof. Okay. Next question to Pak Halim. Ini pertanyaan dari Ibu Aisyah Fatmawati. Ya, yang pertama tadi sempat menyinggung masalah pola pada fingerprinting. Pola seperti apa saja yang ingin dilihat, Pak? Kemudian yang kedua, apa yang mempengaruhi pada saat absorbansi ada 33 senyawa. Ya, kemudian pada pengukuran diabetes mellitus senyawa berkurang menjadi 21. Silahkan Pak Halim.
Oke, baik. Maaf Ibu Reni, bisa saya share screen lagi ya?
Oke.
Sudah tampil ya Bu? Belum ya?
Sudah tampil.
Oke, baik. Ya, jadi terkait dengan pola apa yang ingin kami lihat, ini mohon maaf sebelumnya ya Ibu, karena ini datanya sebenarnya ada tetapi tidak saya tampilkan. Ya, jadi mungkin ini mohon maaf gambarnya agak kecil. Ya, seperti ini gambar dari metabolic fingerprinting. Ya, jadi sebenarnya yang kami ingin publikasikan itu, ya ini hanya representatif dari beberapa pola kromatogram. Ya, ini hanya representatif, jadi kami hanya mengambil yang memiliki kandungan total fenol tertinggi. Ya, jadi polanya seperti ini. Ya, jadi ini ada rimpang dari latifolia, rimpang dari orchoides, kemudian pelepah dari latifolia, kemudian daun dari orchoides, daun dari latifolia. Jadi terkait dengan pertanyaan Ibu Aisyah tadi, ya ini polanya yang ingin kami lihat, apakah pola ini untuk setiap organ itu berbeda apa tidak? Itu yang pertama. Ya, jadi kami melihat polanya organ antara organ rimpang, ya rimpang, pelepah dengan daun itu ada perbedaan atau tidak. Itu yang pertama. Kemudian yang kedua, kita ingin melihat apakah ada perbedaan pola dari spesies, karena ini 2 spesies. Itu yang kedua. Ya, ternyata dari sini ada perbedaan pola. Ya, secara kasat mata saja ada perbedaan pola. Ini kalau kita perbesar, ini ada di daerah sekitaran 3.000-an, ya, yang menandakan gugus AOH. Ini daerah pita absorbansinya yang cukup luas. Kemudian ada di daerah ini maaf tadi yang daerah 3.300-an. Kemudian di daerah 3.000-an ini ada SP2, ya SP2CH. Kemudian ada CH saja. Kemudian kita lihat di daerah fingerprinting ini daerah 1.800 sampai 400. Ini yang ada persamaannya ya, persamaan. Karena kalau kita lihat di daerah fingerprinting itu otomatis untuk setiap tanaman maupun organ itu hipotesisnya pasti akan berbeda. Ya, jadi ini kita lihat ada hanya satu persamaan di daerah sekitaran 1.150 yang sama, tetapi intensitasnya yang paling tinggi itu di rimpang orchoides dengan di latifolia. Ya, itu yang terkait dengan di metabolic fingerprintingnya. Kemudian terkait dengan pola yang ingin kami lihat di chemometrik, yaitu dengan menggunakan teknik PCA. Jadi data ini yang 45 data, nanti datanya akan banyak ke atas Ibu. Ya, jadi datanya ini kemudian kita reduksi dalam 2 komponen utama. Ya, jadi PC itu principal component analysis, ya itu kami setting hanya 2 PC. Jadi PC1 dengan PC2. Karena data yang ada di sini satu kromatogram saja, ini datanya itu sekitaran 1.873. Jadi ini kalau kita kali 45 bisa puluhan ribu. Ya, jadi itu kami reduksi menjadi PC1 dengan PC2. Ini berapa PC1-nya, berapa PC2-nya. Ya, dengan tujuan untuk melihat apakah memang model ini bisa digunakan untuk mendiskriminasi sampel, itu yang pertama, spesies, atau bisa juga digunakan untuk mendiskriminasikan organ tanaman. Ya, karena ini untuk kedepannya ini kami menggunakan juga dasar ini untuk proses dan tujuan untuk autentikasi. Ya, mungkin seperti tadi yang dijelaskan Prof. Suwijio tadi, ya. Kalau orang mencampurkan, ya, ini obat herbal, bahan dasar. Kalau kita ingin mencampurkan seumpamanya daun kelor dengan daun meniran, ya, Phyllanthus niruri tadi, itu kalau sudah dalam bentuk kering itu sangat susah kita untuk membedakan. Ya, jadi kami mempersiapkan ini, apakah nanti ketika suatu saat ketika ini diaplikasikan nanti di STIFA, akan ada pihak-pihak tertentu yang ingin membuat produk yang sama, tetapi dari bahan yang berbeda, dan itu diklaim sebagai bahan dari curculigo orchoides ataupun curculigo latifolia, maka bisa kita lindungi dengan teknik autentikasi ini. Ya, jadi ini yang tujuan kami ke depannya. Ya, seperti itu pola yang kami usung, Ibu. Kemudian pertanyaan kedua,
pada saat absorbansi ada 33 senyawa, kemudian berkurang jadi 21.
Oh, lewat. Ya, jadi ini Ibu datanya. Jadi kami ini hanya melihat dengan berdasarkan pada aturan 5 Lipinski, ya, atau 5 principle. Kenapa disebut aturan 5 Lipinski? Karena ini semuanya kelipatan 5. Ya, jadi ketika senyawa ini memiliki bobot molekul lebih besar dari 500, ini maka absorbansinya itu tidak akan terjadi, ya, menurut aturan 5 principle ini. Ya, itu yang pertama. Kemudian kita lihat milok P-nya seperti apa. Ya, jadi ini distribusi antara apa istilahnya? Kalau kita di fitokimia itu menyebutnya distribusi air dengan pelarut yang non polar dengan polar, ya. Kalau kita infuskan ke tubuh, ini biasanya lemak dengan air seumpama. Ya, jadi ini ada. Jadi ketika dia lebih besar dari 5, maka ini tidak bisa diserap oleh tubuh. Ya, jadi seperti itu bayangannya, Ibu. Ya, jadi beberapa parameter ini kita gunakan, yang mulai dari bobot molekul, kemudian milok P, kemudian rasio antara O dengan N, kemudian ini kami juga menguji di blood brain barrier-nya, kemudian bagaimana dengan human intestinal absorption-nya, ya. Tapi ini menggunakan menggunakan software online semua. Jadi ini bisa diaplikasikan nanti. Ya, jadi dari 33 sebenarnya 79, Ibu. 79 senyawa ini kita cek semua. Kemudian dari 79 ini hanya 33 senyawa yang memenuhi kriteria untuk bisa diabsorpsi oleh tubuh. Kemudian dari 33 senyawa ini, ya, kita buat modelnya seperti ini. Ya, ternyata 33 senyawa ini kalau kita konsumsi, ya mungkin tersimpan di rimpang, karena selama ini rimpang yang banyak digunakan dan dilaporkan di India. Maka ini fungsinya sebagai obat kanker, ya, dari 33 senyawa ini. Tetapi karena kami hanya spesifik kepada comorbidity, yaitu obat DM, maka dari proses pembuatan ini itu ternyata hanya sekitaran 21 senyawa yang ada interaksi dengan protein target yang terkait dengan penyakit diabetes mellitus. Ya, jadi hanya 21 senyawa. Ya, jadi maaf kami tidak tampilkan datanya yang 21 senyawa itu. Ya, salah satunya tadi curculigin B, kemudian curculigo saponin L, kemudian apalagi yang paling utama, cyanuricosida. Yaitu kemudian kita cek seperti apa ininya, seperti apa docking molekularnya. Ternyata yang ketiga senyawa itu memang yang memiliki binding affinity yang terendah. Saya kira cukup sekian, Ibu Reni. Terima kasih.
Okay, terima kasih Pak Halim. And maybe it's last question for Prof. Pramono. Okay, it's from Safri Badarudin. Are these extracts such as Myristica fragrans, yohimbin, Erythema alingifolia radix, Cinnaberisoma, Curcumerisoma, arise the main libido? Is there any effect to consume, Prof? And yeah, and once again, Prof, yeah, it is anonymous. Jika pembuatan minuman herbal dari jahe atau kunyit dan lain-lain dibuat dengan cara direbus, apakah bahan aktifnya akan rusak?
Okay. Well, the first question, it is not really related to COVID, but aphrodisiac. It's very interesting. Yeah. according to our experiment in the laboratory, the first aphrodisiac and the potent aphrodisiac is cabai Jawa, Piper retrofractum, and then the second one is ginger. Not only red ginger, but chai gajah or chai empret is okay. Yeah, that is this kind of, and then Ericoma also, but really according to our experiment in red, with the parameter of the introducing, climbing, coitus, etc., the frequency, the first one, the potential one is Piper retrofractum, and then Chai or Singiber officinale, and then the Euricoma longifolia. This is according to our experiment. Kemudian untuk pertanyaan yang kedua, apa tadi pertanyaannya?
Ya, jika yang bahan seperti jahe, kunyit, kalau direbus apakah tidak rusak?
Baik, jadi memang kalau itu dipanaskan terlalu tinggi, banyak yang rusak. Itu sebabnya sesungguhnya sudah ada petunjuk dari Badan POM ataupun Kemkes untuk apa menggunakan istilahnya kalau di kefarmasian infusa. Nah, jadi dengan panci infus, yaitu pancinya itu ada dua lapisan, yang lapisan bawah itu isinya air biasa sebagai pemanas, kemudian bahannya ada di panci yang kedua. Orang bilang seperti panci tim untuk bayi itulah gitu. Nah, kemudian dipanaskan. Kalau yang panci bawah itu airnya mendidih, maka panci yang di dalamnya temperaturnya tidak akan lebih dari 100 derajat, tapi hanya 90 derajat. Insya Allah kalau itu yang dilakukan, tidak terlalu banyak yang rusak. Ya, walaupun juga seperti kurkumin, mau tidak mau ada yang juga menurun kadarnya. Itu sebabnya, maka biasanya saya memberikan suatu istilahnya arahan, kalau kita menggunakan misalnya saja yang sudah kita banyak pengalamannya, temulawak segar itu 25 gram misalnya saja, dengan hanya diberi air mendidih, kemudian setelah 5 menit dikonsumsi. Tapi kalau itu direbus, maka dosisnya itu harus ditinggikan, walaupun kalau itu temulawaknya temulawak kering itu tidak perlu 25 mg. Karena apa? Temulawak yang segar kan kadar airnya juga tinggi. Itu sebabnya untuk temulawak yang kering cukup antara 10 sampai 15 gram misalnya saja begitu. Insya Allah kandungan kimianya masih istilahnya itu memenuhi untuk indeks terapinya. Tidak semuanya rusak. Tapi kalau pemanasannya itu berlebihan, jelas rusak semua. Entah itu dari jahe, entah temulawak, entah kunyit, yang biasanya seperti itu. Demikian jawaban saya.
Okay, thank you very much, Prof. Okay, thank you for all questions from participants and explanation from all presenters. It is really interesting topic and gives us many important and valuable information. Hopefully that all explanation was given by the speaker were clear. We apologize if still there questions that are not answered because of limited time. Maybe if you want to discuss with the presenter, you can contact them personally by email. Now we come to the end of discussion session. We appreciate to all attendants and speakers for your attention and enthusiasm to this seminar until right now. For the conclusion, for supporting therapy in curing COVID-19, we can use some traditional medicine which have indication as immunostimulant, antioxidant, anti-inflammatory, expectorant or mucolytic, hepaprotector, and antiviral activity. And as a researcher, we still have challenge how to optimize the herbal effect, especially for COVID-19 treatments. This target can be done use some approach such as metabolomic and metabonomic approach. Besides that, of course, we also need to provide clinical trial evidence for indication and safety of using herbal, especially for antiviral indication. Okay, let me close this discussion session. I deliver the control of the event back to the host. I'm Reni Syahruni. Thank you very much, and wassalamualaikum warahmatullahi wabarakatuh. See you next.
Waalaikumsalam warahmatullahi wabarakatuh.
Warahmatullahi.
Okay, thank you very much, Ms. Reni Syahruni. Before we close the last session, we remind which are provided by committee via chat room. Link for e-certificates and post-test also shared in chat room and WhatsApp group. Don't forget to join post-test, especially for participants who wants to get e-certificates. Last, we would like to invite all participants to have photo session. So please turn on your camera to have photo session, please. Okay, all participants. Mati punyanya Karen. Tapi kita kelihatan di atas. Karen, enggak kelihatan. Okay, thank you very much. Ladies and gentlemen, this is the end of seminar today. On behalf of organizing committee, we would like to say thank you very much for speakers and all participants today. Hopefully, this online international seminar will enlarge our knowledge about herbal remedies for COVID-19 treatment. Now we declare that international seminar today is closed. See you next time, and Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh. Terima kasih Bu Radia.
Ya, sama-sama Pak. Sukses.